Good morning, Internet. Good morning, everybody. Good morning, people all over the world. And welcome to NDC Manchester, where I'm not, and you probably aren't either. Yes, hello, everybody, and how are you all doing out there? My name is Dylan Beattie. I am going to be your host for the rest of the day here live on the internet. We are streaming NDC Manchester, the first NDC Manchester conference, live on YouTube all day. We're going right through till 6 o'clock tonight. We got some amazing speakers and content coming up for you. We've got Stacy Cashmore will be joining me in a few minutes to talk about building your personal brand using Blazor and personal apps. We got Steve Sanderson, Janani, Subbiah, Irina Scurtu, Heather Downing, Mark Rendle, Ian Cooper, Richard Campbell, and Carl Franklin joining us later with a special live edition of .NET Rocks. So it is going to be an awesome day. The way that this thing is going to work, it's not just a broadcast, it is a two-way interactive event. Say hello in the YouTube chat. I can see, hey, Lars is on the call. Hey, Lars, how you doing? Robin, Dan, Tom. So yeah, get involved. Get in the chat. Say hello. Let us know what you're thinking. We're going to be running all kinds of interactive stuff through the course of the day. We're going to be running some prize draws. My keyboard is warped in the sunlight. Yeah, I left it too near a glass of water and it melted and went all curvy. So, so yes, welcome. And it's been a very, very strange year. I was just looking back through my calendar for the last 12 months. And so this time last year, we had NDC Copenhagen, was the 1st to the 3rd of April 2020. And it was all set to go. You know, we had a venue booked in Copenhagen and we had speakers and people had got plane tickets and all this kind of stuff. Everything was happening. And then, as you know, we all remember and know well, the pandemic hit, and it hit hard and it hit very, very suddenly. Things started locking down. And we had about 3 weeks to figure out how do we run a conference over the internet. And we scrabbled, we got hold of all the speakers we could. We're like, have you got any ideas? We talked to partners, sponsors. We did the most intensive week of investigation of different formats for doing online video and presentations and chat and all this kind of stuff. And we came up with a format and we made it happen, and we ran NDC Copenhagen online. And at the time, you know, if you all think back to it, we're like, well, it might be like this for a month or two, maybe until the summer. If you remember that? And some people were like, it's going to be longer, and some people were like, it's only going to be a couple of days. So we're like, well, we'll do Copenhagen online. And then we had NDC Porto, which was April last year, right? The end of April. We had that all set up and ready to go, and started putting some plans in place for doing that online if we had to, and we did. And then NDC Oslo, which is our biggest flagship event. That last June, we ran that online. We had over 1,000 people connected live for 3 days of sessions and stuff. It has been an astonishing learning curve for everybody involved in exploring the limits of the technology, figuring out what's possible, how we can make all this stuff work. But we did it, and, you know, we're developers, we're nerds. As soon as we know how to do something, we get bored and we're like, let's do something different. And so we wanted to launch NDC in Manchester this year. There's an amazing technology scene up in Manchester in the north of England. We're going to have some guests joining us a bit later to tell us more about that and how you might be interested in getting involved with some of it. But we had an amazing venue lined up and all this kind of stuff, and I was thinking, is it going to happen? Is it not going to happen? And when it became apparent that we weren't going to be able to do an in-person event in Manchester this year, we thought, well, what should we do instead? We could do another, but because it's a new event, because we've never done Manchester before, we wanted to do something a little bit different. We wanted to connect with some people we'd not had a chance to connect with before. We wanted to have a chance to reach a new audience, give some new speakers an opportunity to become part of the NDC community. And we thought, what about a live conference? So Jakob Bradford, who's the manager of NDC conferences, who kind of puts all this together behind the scenes, what he actually said to me, what if we did a conference that was like Eurovision Song Conference? So that's me. I'm going to be Graham Norton or maybe Terry Wogan if you're a viewer of a certain age for today. But that's the kind of energy and format that we are trying to go for today. We are live on the internet. We're going to be streaming all day. We got guests joining us in the studio here. We'll talk a little bit later about the studio setup and how we put all this stuff together. But I'm going to introduce you now to some of the tools that we're going to be using to make this thing feel like a live and interactive event. So throughout the day, our speakers are going to be streaming to you live, and we're going to be using a platform called Slido to take all your questions. So we're going to do a little Slido warm-up exercise now. So if all of you jump across to here, you can join the Slido at slido.com, hashtag NDCMCR. That is the code for today. And we're just going to run a couple of little word cloud polls just to kind of wake everyone up and see if it's all working out there. So let's kick this off. Get over there, NDCMCR, and just let us know. Stick your comments there. It's going to build a dynamic word cloud for us. What country are you joining us from this morning? I've already seen some folks in the chat from Nepal. Oh, wow, awesome. Hey, Nepal. We got Germany. We've got South Africa. We got, by the way the Slido thing works, we're going to be doing some prizes and giveaways, which is why we ask you to register. Later, there's going to be some interactive NDC quizzes. So give us your name and your email address, and that way, if you win something, we'll be able to follow up later and find out your shipping details. Someone from Mansfield. Yeah, so Richard said login. Yeah, it's just registration. We need an email address so that if you win anything, we can send you your stuff and figure out where you are. All right, we've got, what do we got? UK, England, Netherlands, Denmark, United Kingdom, Bristol, Stipperstone, Switzerland. We got someone joining us from Hello World. Hey, Hello World, nice to see you. Hello World says hello world back. We've got Yorkshire, Lincoln, Porto. This is awesome. And the word cloud is working, and the latency is predictable, and all these little details. This is the first time, as I said, we've run an event with this particular format. And so we're juggling a whole bunch of stuff. So yeah, Richard, just create an account, name an email address. Like I said, it's because if you win something in the prizes that the prize draws and quizzes we are running later on Slido, we got to be able to get hold of you. Otherwise, you have this thing where it's like we say, all right, well, Bob123 won the quiz, and then we get 100 emails from people going, hey, I'm Bob123, can I have my prizes, please? And we have an authentication problem. So yeah, log in, email address, name, join in with that, and we're going to be using that to do various bits and pieces throughout the course of the day. But it's time to push one of the buttons here on my magic little Elgato Stream Deck that is the nerve center of this entire operation. And let us get the first of our speakers onto the call today. I think Stacy is here and standing by. Let's switch that across, and I'm going to push that button there. That's going to fall off there. Good morning, Stacy. How are you?
Good morning. I'm fine, thanks. How are you doing, aside from throwing equipment across the room?
Oh, you have no idea the amount of equipment that I've got. I'm in my little home office here. I have a second room in my house. That when I moved house a couple of years back, it's like I have a room where I can keep the computer and the drums and stuff. And Stacy is pretty quiet. Let's make Stacy louder. We crank that up a little bit, and we'll crank that up a little bit. There we go. Yeah, we're fine. We've got about probably 10 miles of cable just in this room and about another 500,000 miles of cable around the world. And if you've ever done live events, you know, the whole point is the more cable you got, the more likely it is that something may go wrong at some point in the proceedings.
How else do you make life interesting?
How are you, Stacy? How have you been keeping busy during lockdowns?
I've been keeping busy in lockdown trying to do way too many talks.
Yeah.
Oddly enough, I've given more talks in lockdown than I did before lockdown.
Well, you don't have to travel, so you can use those extra days to do more talks, right?
It does make life a little bit easier for some things. I talked in America without getting on a plane, which for me is awesome. I have a little fear of flying, and going across the Atlantic is something that kind of scares me just a little tiny bit.
So one of the yeah.
it was nice to be able to do that, and I've just started my Twitch stream.
Yeah.
I'm not ready to do live coding yet. I've not quite got that level of courage, but I'm building a Lego 911 on Twitch every Sunday now, which is a lot of fun.
Streaming Lego on Twitch, that's pretty awesome. So are you keeping like frames so you could do like a time-lapse fast-forward build, or you just people go on and
I'm not doing that for this one. What I generally do when I build Lego is just take lots of photos and then just completely spam Twitter with 20 pictures of every bag that I build. But as soon as I'm streaming this one live, I don't really want to stop every 5 minutes and go, oh, just get pictures. So I'm just doing pictures of the end of every stream this time and uploading the build to YouTube just as a standard build.
I think there are some companies who have done very well out of everyone having a lot of spare time, and I think the Lego company is very definitely one of them. And did you see the new space shuttle Discovery that was announced this week?
That is. I have two things I want to buy. I want this. Well, I want to buy the Lego shop, but
Yeah.
I want to buy the space shuttle and the haunted house. Because that haunted house, the Addams Family-esque thing with the vertical drop lift in it, that needs to be in my modular street.
Fantastic. So, what are you going to be talking to us about? What are you working on, and what have you brought here to NDC to share with us, Stacy?
I am going to be talking to you today about building your own brand, which it kind of came from a tweet that I saw last year that was, if you're posting to Dev.to, to Medium, whatever platform it is, as awesome as those platforms are, you are spending your time, your energy, your expertise on building those platforms up. And wouldn't it be better to have your own place on the web and build your own brand up?
So
it's kind of the first steps to starting to do that.
I'm old enough to remember the internet when there was no social media and everyone had their own blog and their own website and their own mailing list, and things like Twitter and microblogging didn't exist. So I'm very interested to see what is you're going to be sharing with us. Right, on that note, let's hand over the stage. Please, will you give a big welcome, presenting live at NDC. Are you sharing your screen, Stacy? Will they be live coding?
I am indeed sharing my
Okay,
screen.
you want to bring that up?
Hopefully.
We will switch across, and if all this works, it's always daunting being the first person speaking at a conference, because you're the one who gets to discover all the problems with the equipment that nobody found in rehearsal.
It's either going to be awesome, or it's going to be hilarious, and we're just going to make the best of it.
So you share your screen. I'm going to push this button and try not to knock the Stream Deck over this time, and we'll take things from there.
Cool. Thank you very much.
All right.
And good morning, everybody. Thank you so much for joining me here today. I'm absolutely psyched to be presenting at NDC.
We don't have your screen yet.
Sorry?
We don't have your screen yet.
You don't have my screen yet? That's so weird, because I pressed share. I hate Zoom. Do you have the screen now?
We have the screen now. There we go. You are live. Let me push that button there. And yes, we're good to go. All yours.
There we go. We have the first fun of the day, trying to get Zoom to share a screen. How many developers does it take to share a screen in Zoom? Yeah, like I was saying, I am really psyched to be presenting at NDC. When I first started speaking a couple of years ago, this was kind of on my list of one of the conferences that I desperately, desperately wanted to give a presentation to. So this is awesome to be here. Now, like I was just saying, last year I saw this tweet come across my timeline talking about building your brand. That if you're blogging on somebody else's site, you're building their site. And as awesome as these sites are, I personally blog on dev.to. And it's a great platform. It's easy to use. It looks nice. There's lots of people using it, but all of my stuff is under dev.to/Stacy Cash. I'm not building my own brand. And because that spoke to me, I thought, well, let's do something about this. So I went out and I got myself a domain name. And because who can ever stop at one domain name, I actually got myself 3 domain names. I got stacyclouds.net.com and .dev because I couldn't decide which one to do. And then I did nothing, because I think there's loads of people out there that will recognize that buying domains and using domains are 2 completely different hobbies. And the thing that stopped me from moving forward was the problem of eating the elephant. If I was going to make my own site, then I wanted to make my own site. That meant that I wanted to write it and play with stuff and learn things. And it suddenly goes from being this simple thing of just installing WordPress on a free hosting thing somewhere and giving it a custom domain, and turning it into, I need to write an app to display blog posts, to allow people to search for them, to do authentication so that I can do things inside of the app, to make it look awesome, which is interesting because I am not a CSS expert, as you're about to see. and all of the other things that you need to do to make a really cool site. I have enough to do with my job at the moment, and this thing was just so huge. It was sitting on me like a lead weight, and I just let it kind of fall by the side just a little bit. And then in the middle of last year, I started playing with Blazor. And specifically, I started playing with client-side Blazor and deploying it to Azure static web apps, which are currently in preview. And I started to see lots of possibilities for what I could do with this thing. In my day-to-day job, I use Angular to build web applications, and I am not an Angular expert. We have an awesome team of developers that do that. But with Blazor, it's C#. That's my day-to-day work. I can write stuff in the same language as I use in the backend, deploying it to a static Angular application inside of Azure. I only have one resource. I get continuous integration and delivery out of the box when I create it. It just kind of makes my life easier. And it made me see that rather than trying to eat this elephant, I can start to build my brand up in small, bite-sized morsels and try and go step by step until I reach the point where I can go, I'm happy with this. I've now got a place where I can introduce myself on the net. And on that note, hi, I'm Stacy Cashmore. I've been a software developer since the mid-1990s, and I'm a Microsoft MVP in developer technologies. Now, when I talk about static web apps, there's an amount of advantages and disadvantages that I think I want to cover before we get started with the fun stuff. Now, first advantage, there's no server. It's serverless. And yes, we all know there's at least one server in serverless, but I don't care about it. It's much easier to maintain than having to make a fully fledged Azure App Service web app and trying to organize everything independently. It also allows me to host my Azure functions in that same single resource inside of Azure as my front end runs, which means I don't have to have separate functions. I don't have to make them talk to each other. It's just done for me. Again, it makes my life just that little bit easier for a side hustle. And the third one is that workflow. When you create a static web app inside of Angular, it gives you a GitHub action, which gives you continuous integration, continuous deployment. It even gives you a way to do pull requests and check your work in a production-like environment before you go live. And this is all out of the box. I don't have to do anything for it. And I like things that I don't have to work for. There's also disadvantages, of course. If you've got the advantages, it also goes the other way too. The first one there is that wonderful word, preview. This is not in general availability yet. I don't know when it's going to go into general availability. And that means that whilst I'm using it for my website, and whilst I might use it for some small things at work, I would not run production load in this just yet. I want to wait until it's general availability before we do that. It's also, at present, GitHub Actions only. I know that they're working on getting it to work with Azure DevOps, but right now, if your code's not inside of GitHub, it's really difficult to work with. It's probably not the technology for you. And then there's two more things which are worth mentioning, which they're not necessarily disadvantages, but I like to talk about them. One is Scott Hanselman's wonderful phrase of knowing the magic one layer below the metal that you're using. And you can't really do that with this. I am using an Azure static web app, and I am using the out-of-the-box GitHub action. And it is one single action which builds your site, discovers your site, deploys your site, handles the pull request environments for your site. I don't know what it does inside, and I kind of wish I did. It's not a problem. It's just, I wish I had that little bit extra knowledge. And the last one, I have heard people complaining that in order to set this up, you have to authorize the Azure portal to make changes in your GitHub repo. I don't have an issue with that. I know what it's doing. I know people who are against it on principle, and for them, it's just not the technology for them to use today. With all of that aside, let's start to do the fun stuff now. And let's actually create a client-side Blazor application with an Azure Function API make it do something to show you how it works, and then let's get it deployed. After that, we're going to make it do something really fun. So the first thing that we need to do is create our static web app. So inside of my Visual Studio, I hope I've made this big enough for everybody to see. We are going to create, if the computer does its thing, come on, you can do this, a Blazor app. We're going to call this client. And when you set up your workflow inside of the Azure portal, by default, it looks for client and API as a project name. So you can call this what you want, but it just works much cleaner through the step through if you just call it client here. I need to put my code in that location so that my GitHub repo picks it up, and I need to give it a special name. This is just so that the demo picks it up. This isn't something you particularly need to do. It just makes it quicker to show you stuff. So for the Blazor WebAssembly app, we're going to be running in .NET 5.0. We are going to configure it for HTTPS, but because we want to run it in a static website, we are not going to click the ASP.NET Core hosted switch. And because I'm doing nothing with progressive web apps, we're going to leave that one as well. So let's create this one and let it scaffold up. And let's hope that the computer can handle both the Zoom and creating a little application. I remember computers in the 90s were really slow too. It seems that no matter how powerful they don't get any quicker. Now, inside of our solution, we are going to be adding a new project. And that's going to be our Azure function. This is how we're going to get our data to our client-side application. And like I said, we're going to call this API just because that's an easy way to get this set up. We want a HTTP trigger so that we can call the API. Let's get this scaffolded. Come on, you can do it, computer. And there we go. Now, there's a couple more things that we need to do just to get this working locally. First one is because we need to run both the client and the API to do debugging, I want to set multiple startup projects here in our properties. And that's kind of it. If I deploy this now, it will work, but it's not going to do anything special for us yet. So the first demonstration I'm going to show you is just how to get data from that API. And anybody who's created a Blazor client-side app will recognize this counter, fetch data, and index page that we have. And we're going to use this fetch data page in order to do the first demonstration. What this does out of the box is get data from a JSON file on the server, and it just puts that data on the screen so that you can see to get data from the back end and put it forward. We're not going to do this from the JSON file. We're going to use an Azure function for this to show how to do a call to the back end. First thing we're going to do is rename this to weather forecast because I hate the name function 1. And then because you really don't want to spend the next 35 minutes watching me do typo after typo after typo, I've got some code snippets I'm going to bring over. So this is your function. It's going to be a really simple one. All we're going to do is return an array of weather readings just to pretend that we're that JSON file that our client can use. So this is all we need here. We're just literally returning some hard-coded data, and it's going to come through to our client. In the client itself, we need to make a couple of changes. In our fetch data page, we need to get the data from the right location. So let's bring that across. Instead of bringing it from the weather.json, we're going to get it from this API/weather forecast. Now, we can deploy this right now to a static web app, and it will work for us. We can't debug this yet because inside of a static web app, there's a proxying done so that the API and the client side run on the same URL. That isn't the case on my computer. So we're just going to need to make something to allow our web app to go cross-site in order to get the data that we need. First one that we need to do here is create inside of our client application a new file. I can try. Let me just create this class and now have a look. So let's create this. Let's go back to the page then. And Come on. Is that better? Okay. So now that we've added our app settings.json, which apparently I added totally the wrong thing here, but yeah, it's called an app settings.json, so it'll do. We're just going to bring in one setting, and that's going to be our API prefix. And we're going to point this at localhost 7071 so we can talk to our API. This is where the function runs by default. But we need to know how to use this, because having it is one thing, using it is a second. And for that, we need to make a change to our program CS. And on line 20, we have our HTTP client that we're going to use to get this data. And it gives it the base address of just the host environment. And we don't want that. We want to add this little bit here saying, if we have a configuration for API prefix, use that. Otherwise, then we'll just use a host address. So in Azure, it will just run normally on the local machine. It allows us to talk to this different port number. And talking to that different port number, unfortunately, gives us a second issue. And that is that we are now making a cross-origin request to our API. So we need to allow the function to cope with that. So we're not going to add a class, because I'm adding totally the wrong thing there. We're going to add a new item. And this item is going to be a JSON file again. And we're going to make a launch settings so that when we hit F5, it does a certain thing. And for this, all we're going to do is bring across a command line argument that says, if I'm running this, just run it with cause enabled for anything, so I can talk to it from my client side. And if I have done everything correctly here, she says, hopefully, the build should start, we should get our function running, we should get our front end working, and we should be able to see things happening. Come on, you can do this, little computer. Honestly. Yeah, here we go. So now we have our client app loading. The first time you load the Blazor app, it is a little bit slow because it is bringing that WASM compiled .NET environment down into your browser. But once it's there, it is kind of blazingly fast. And I just want to show you on the back end that I really am getting the data from where I said I was getting the data from. So if we come here, we've got our data loaded, and we can see that it's coming from 7071. We are talking to that function in the back end. One last thing to do before we make our first deploy, and that is set up our routes. When you're making a client application, because everything runs in the browser, the server doesn't know about any of your routes. If we deployed this as is, we could click to everywhere. We would go to all of the routes. But if you press F5 on something, you're going to get a 404 error because it's going to go to the server looking for your route, and it doesn't exist. So we need to give it a way to fall back and find the right location. Now, when I first did this, I did it in totally the wrong way. I set up a really complex proxy using Azure functions. It worked, but it was a little bit hideous. And it turns out there's a much easier solution that we should use, and that is the routes.json, which is a file we can put in our www root. Yet another JSON file. And you know what? I might actually give it the right name. It's early in the morning. And inside of this routes.json, we're just going to tell it what it needs to do if it can't find what it's looking for. So anything that's not found, redirect to index.html, and of course return us that status code of 200. Otherwise, we still get a 404 in the browser. Now we can deploy this, and it should work well for us. Should. So let's push this up to my GitHub repo. Yes, save this. Let's check that it does actually push, otherwise the next bit's going to be a little bit boring. Yep, that's gone. And now let's jump to our browser and actually show our application. Now, I have my repo here. So if I refresh this, there's my API, there's my client. And we're going to set up a new static web app inside of Azure. I have a resource group that I've already made, this Blazor Talk demo resource group, and we're going to add a new resource here. And that's going to be our static web app, which is in preview. We will create this. We'll wait for Azure to catch up, check this subscription and resource groups correct. Check I can type. See, this is why I have code snippets to bring across, because typing when people are watching is interesting. Blazor demo. I'm in the Netherlands, so I want to run this inside of West Europe, and then I need to sign in with GitHub. That thing that, like I say, I know one or two people that just really have an issue with. So let's log in there. Yep, that's now authorized. Then we just need to check what code we want to deploy. So I want to deploy the Blazor Talk demo. I want to deploy the main branch. And then you get a load of presets that you can do. So you can deploy Angular, React, Svelte, Vue, and the one that we're going to pick here, Blazor. We need to tell the GitHub action where our client is, where our API is. Like I say, this is why I called it client and API, and give it an output location that it builds to. Now, as far as I can see, this can be anything you like, as long as it's not an existing directory inside of your repo. Otherwise, bad things happen. So let's review and create this. That looks good. And static web apps take like seconds to create. They are really quick. So the deployment's complete. We can go to the resource. And now we have this ashy stone. I love the names they come up with for this. And if we click on this, and if Zoom stops getting in my way, we can now see that we have a static web app. It's live. It's waiting for your content. Where is that content? Well, that's here. We have this GitHub action that has just been added, and this is kicked off. And like I say, this builds our client, it builds our API, it deploys it, and it makes it all work wonderfully. It also takes about 5 minutes, and I don't particularly want to stand here and watch this for 5 minutes. There's other stuff which I'd rather go through with you. So we're going to come back to this soon. In the meantime, I want to go back to my code. And now that we've made our static web app, let's start working on making it a little bit nicer and not just a standard Blazor application. Let's actually start to build our brand. First one I want to do is just close all of this, to clean this up a bit. And then we're going to clean up our solution just a little bit, remove stuff we don't need so that we've got a clean base to start with. First one is we don't need that weather forecast. So let's get rid of that one. The second one is I don't want this counter demonstration, so we can get rid of that. I don't want the fetch data demonstration, so let's get rid of that. In our shared folder, there's a couple of changes I want to do just to get rid of a couple of extra things. In the main layout, I want to get rid of the Blazor information because I want to add my own stuff there at some point. And in our navigation menu, and all of this is scaffolded for you out of the box. So you don't have to think about layout in the beginning. You can delay that till later. Again, not eating that elephant. But I do want to get rid of the navigation links for the things that we've just removed. So now we have this cleaned up a little bit. Now we can start to add our own things. And we've got 3 steps that we need to take in order to start putting our own work on the net. The first one is we need the API to get the data that we want to display, and we need to pass it forward to our website. And then in that website, we're going to need a service which gets a hold of that data and stores it for us, so we're not doing a call every time we want to see the data. And then we're going to need to make just a couple of components to put it on the page and to show it to our users. So the first step in all of this is getting the data from dev.to. I say that's where I post when I write blogs, and they have a really nice API available for us. We can just go to articles and pass in a username, and we get a list of the summaries for that user. So here we have a list of my articles I've written. You don't need a developer key for this. This works out of the box, and we can use this to start putting our own information on our own web page. So let's go back to our code. The first thing that we need to do is add a couple of models if we're going to do this, because we need to know the data we're receiving and we need to know the data that we're sending out to the client app. So let's add a new folder, because I like to keep my code a little bit organized. And we're going to add two classes here. The first one is going to be a text post summary. And this one is just going to hold the data that we're going to send through to our client-side application. And here we just have the ID of the blog post, the URL, the title, description, the cover image, which I don't use in this demo, but I forgot to take out of the link, and the publish date for that particular blog post. Then we need to know what information do we want from that dev.to API. So we're going to add a second model here. And that one we're going to call a dev.to blog post summary. And for this one, I just used a tool that I found in Google. I pasted the JSON result, and it gave me a nice C sharp object back so that I can just get the data I need. I've removed all of the extraneous things that I'm not interested in. So again, I'm only getting the ID, the title, the description, the URL. And it's just something that I can now use to read the data I want from that JSON that I get back. Now we need an adapter to convert between the two. So let's call it adapters. And of course, this you could do with something like, I've forgotten the word because my brain has just gone empty, but we could do this automatically, but it's just a small piece of code, so I don't particularly mind adding it. Add a new class, and we're going to call that blog post summary adapter. And this doesn't do a whole lot. This just takes in a JSON input, deserializes it to an enumerable of dev.to posts, and then we just read out the things one by one. Like I say, you could do this with Automapper, but it's such a small piece of code. I don't particularly mind doing this by hand just for one adapter. Last but not least, we need our function, of course, because without a function, we can't actually get our data back. So let's add a new Azure function to our project. Let's just call it blog posts. We want a HTTP trigger. We get a nicely scaffolded class back, which we're not going to be using. Instead, we're just going to have a small get function that runs on blog posts. Come on, computer, what are you doing? And all this does is get a HTTP client. Yes, I should probably use dependency injection for this, but for demo, it's fine. And we're just getting the articles from dev.to, converting them into our blog post summaries and returning those to our client. And that's all that we need to do for our Azure function. This should now work for us. Now we need to actually display this data in our site. And for that, the first thing I want to do is add a model to the front end for the data that we're going to receive. And yeah, I should probably share this between the back end and the front end here, but again, it's such a tiny amount of code that for a demonstration, I don't mind repeating myself just a little bit. So let's add a new class again. We're going to call that blog post summary. Spot the deliberate mistake there. And inside here, again, we just have the ID, blog URL, title, description, cover image, and publish that. So this is now available to us inside of our front end. Then we're going to add our service. So let's add a new folder here for services. Again, let's try and keep it slightly organized. And inside of services, we want to add another class. And we're going to call that blog post summary service. And all this is going to do is make that call to the API, but only if we need to. Here we are injecting the HTTP client because we get it out of the box in our client application. And we just have one function which loads summaries. And what it says is if our summaries property is null, or if we have said force this load, so I always want to get new summaries, then get the summaries from our API. And that's it. this is all that we need to do to get the data from our function into our application. Now we just need to use this service inside of our site. Now, if you're using a service inside of a Razor component, it is useful to use the dependency injection. So we're going to add that here. And I'm just going to import the using statement. So in our program.cs, we just add a scope service, which is our blog post summary service. We now have it available to us. We can start making our components. Now, the first one that we need to do is we need to make a page for our blog posts. So we're going to do that inside of our pages folder here. We're going to add a new Razor component because all pages are Razor components. All pages are Razor components, not all Razor components are pages. I'll explain the difference in a second. And we're going to bring in just a snippet here. At the top, we have this page property, and we're going to set that to blog posts. And that is the path in the site in order to reach here. And then inside, we're just going to check to see whether or not we have summaries in our service class. And if we don't, we're just going to say, we're loading, get back to us in a second. When we do have summaries, we're going to put each one on the page using this component that we're going to be making in a second. But first of all, we need to make the code behind for our Razor component in order to get this summary service. So let's add a new class. Now, you can put all the code in the front end, but I just have a personal preference for code behind. It doesn't matter which way you do it. If you do call your code behind the name of your component.cs, then Visual Studio does nicely organize it for you here. And then the code that we want to bring across here to make this work. We are implementing iComponent, and our backend class needs to be a partial class in order to work with that front-end component. We're injecting our blog post summary, and all we have here is on initialization, load the summaries. That's all the code that we need. The service then does its thing, and when they're available, we will display this component. But of course, we need to display this component. So let's add that now. You could put this component in the page, but hopefully if I have time, you'll see why I'm not doing that in a minute. So new folder called components. I think that's spelled right. I hope that's spelled right. Otherwise things are going to go wrong in a minute. And in this component, we're going to want to make that blog post summary component that we were just talking about. So Blazor component, blog post summary. And here we just have a simple piece of HTML without that page directive. So this one cannot be used as a page. That just takes the summary title, description, and blog URL to put our summary on the screen. And as you may have noticed, we have red squiggles again. And that means that we need another code behind file to make this work. So let's add that class in here. And it's a really simple code behind class. And all we do is add a parameter of a blog post summary that we can display on the front end. Our red squiggles are now gone. We can almost use this now. And I say almost because we need to add a using statement to get access to this blog post summary. But if you're doing anything in Blazor, rather than adding the using statement to each of the components, there's this wonderful _imports.razor file. And we can add our components in here. And if we go back to our blog post Razor page now, we can see that it's picked it up from the right place. There's one last thing that I want to do for my first attempt at building my brand. And that is, whilst a user can come to my site and they can click on the blog posts and see the list of them, I want them to see the latest blog post on the front end first. So I think I've just about got enough time to show you this one too. And for that one, we have our index Razor. This is our main page. And at the moment, all it does is say, hello world, welcome to your new app, blah, 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 blah. We're going to add a backend or a code behind to this one too. So index.razor.cs. And here, we're just going to bring across a couple of code snippets. So the first one is just our empty class, make sure that it works. And then we have the summary that we want to put on the front of the screen. So we have our blog post summary service, the same as we had before. We have a private property of a summary, and we have a public property with a get. And what we say is, if our summary is already loaded, put that one on the screen. If we don't have a summary to display yet, then get it from the blog post summary. And for that, we need just a couple more functions to make that work, because we don't have get blog post summary yet. And for this one, we just say from our service summaries, if they exist, order them descending by the published date, as in I want the latest, and get me the first one, because that's the one I want to put on the screen. And of course, on the initialized async, we need to call that load summaries again. Now we can add the code to the Razor page itself to actually get our function. And we don't want hello world, because hello world's boring these days. We want build your own brand. And again, if the service summaries is null, we want it to show loading. If we have it, if we don't have any blog posts, then just say, sniff, sniff, we don't have one. If we do have a blog post, we're using that same blog post summary component to display it on the page. So let's run this one locally and show you this in action. So hopefully this builds reasonably quickly again. Come on, computer, you can do it. Seriously, it doesn't matter how fast computers get, they are never fast enough. They always leave you looking at it thinking, why are you taking so long? It's doing stuff, and of course it's opened the browser on the wrong screen again, so let's bring that here. And here we have build your own brand. We are loading from the back end, and here we have my blog post, setting up an Azure environment. This is a series that I was writing a while ago. I need to do the next one sometime soon. And if we click on the link, we go straight to dev.to, so we can actually see our code. And I realized that I forgot to put the navigation link in here. So I'm going to have to do this the hard way. Come on. If I go to my blog post screen, now we can see all of the blog posts that I have available. And again, we can click on any of them and open them up in a new screen. So we have taken that first morsel of putting our own website onto the internet. We're still using all of the cool stuff on dev.to. It's just that first step. People can now find it on our site. Now, before I push this up to GitHub, I do want to make sure that I add the navigation links, because otherwise it's way too much of me having to type. And for that one, we come into this navigation shared class, the one that we deleted everything from earlier. And we're just going to add an extra one to go to blog posts. And I don't want a plus button. I want a document button to be displayed. Make sure I've not broken anything. So now we're going to push this up to GitHub, and hopefully it's going to deploy in time for me to show you this working before I run out of time. So add dev.to link. We're going to commit alt and push. And then let's see whether, of course, we need to do a pull, because when I created the Azure static web app, it created that action for us. So we need to do a pull before we can push. That seems to be done now. Let's go back to our actions. That first one ran. We can see the second deploy is already going. We have that continuous delivery set up. Because I pushed to master, it's going straight out. And if I now go to my Blazor demo and we click on this link, there is our Hello World app live in the world, deployed automatically, and using that API backend to make sure we get the data that we want. So that's kind of the first bits that I wanted to show you. There's only one thing left to do whilst it's deploying, and that is this URL. Yeah, Ashy Stone does look cool, but it is not the brand that we want to build. I got my own URL. So let's have a look at how we can add our own URL to our static web apps. Now for this one, I'm going to go through it quickly and then go through it a little bit slower for you to show you each of the steps. And I do that because this takes a few minutes to work. I have a static web app already set up. I can come to the custom domains. I can add a new one. I'm going to add www.stacyclouds.com. And I'm going to validate to make sure that works. And then I'm going to add it. So this is now creating the custom domain. Like I say, this takes a few minutes. We'll come back to that in a second. I have a second app here, and I can go through a little bit slower, trying to show you what I've just done. So a static web app, you can add a single, right now, custom domain to it. So the whole custom domains is a little bit of a misnomer. I hope they fix that before we get to Gemma availability. And if we click add, we get this nice slide-in panel saying, what is your URL? Because we need to validate this before we connect to it. So if we do www.stacyclouds.dev, and I try, it tells you need to add a CNAME record with this value so that it knows that you have access to this URL and you're allowed to use it. Now, if you don't have that available, it's going to give you a validation error. The CNAME record is invalid. Please make sure it's correct. This can take about 48 hours for it to go through sometimes. That's why this one is set up before. And it's the only bit of this that you can't say, in 40 minutes, you can set up this amazing thing, because this bit takes 2 days. You don't have to do any work for 2 days, but it takes 2 days. If you have a URL where it's not that there's no CNAME record, but it's set for something else, you get a different error message. So this lets you know that the request envelope is invalid. The custom domain is linked to something else. You can't use it for this site. So we have 2 error messages telling us what we need to do. So that is how we set this up. Let's cancel this. So I have 5 minutes left. This is always the interesting part of the demo. The last 2 things take time, and are they going to work fast enough? Custom domain is currently being created. The GitHub action is still running. This could get a little bit interesting. Right, what can we do whilst that is waiting to be deployed? There's one last thing that I can show you whilst it's being deployed, actually, and that is the workflow that I was talking about. When you make a pull request and you want to check that something works before you merge it. I have one set up earlier for those in the UK. Blue Peter, here's one I made earlier. When you create a pull request and there is a GitHub action for a static web app, it will do you a deploy to your URL dash your pull request number. This is pull request number 1. West Europe, and then the rest of the standard application. So if we go to this location, we still see our application. And I think I made a change here. I made a change on my site too. Oh, the weather outside is frightful, because when I first made this demonstration, it was terrible weather here and snowing outside. If I go to the standard web app, and I do that, like I say, by removing that -1.westeurope, and I reload the live site and go to fetch data, we can see we have 2 different pieces of information. And that allows us to check that the changes we've made are doing what we want it to do before we actually push it to production. And again, this all comes out of the box, which I kind of love. So that is how we do our pull requests. The other nice one here is obviously you don't want this to sit in the air forever. But when you complete your pull request, it will delete this and clean up after itself. And again, you don't have to do anything, which is always cool. One word of warning here, and it's also mentioned in the documentation, this is live for the world to see. If you are putting something up to your web app, which you don't want the world to see, you can't use this functionality, I'm afraid. You have to just test it locally and hope it works in production. Now, how are we doing? We have the custom domain created, so I can show you the custom domain now. So we had for this web app talk, let's close this one. Come on, close. For this static PR, if we open this link, we have the website. Yet again, that wonderful Blazor, just scaffolded application. If we now go to www.stacyclouds.com, we see that same application. It's working for us. There's a couple of things to know here. One is it only works for www right now. You can't do anything other than www, which means if somebody goes to stacyclouds.com, they're going to get a completely different page parked on the bun because that's where my DNS is located. Phooey. You can fix this with all sorts of different things, depending on how your DNS allows you to handle this. You can set up an Azure function to do linking through to this, but it's something to bear in mind. Hopefully, before we go to GA, they're going to fix this because obviously this is a big no-no if you actually want to use this for a proper production thing. The last one, I see that our second deploy is finished. So if I go to my Ashy Stone, the one that we've just created, go to the home page, we now get our dev.to latest blog post on the front. We have our blog post button, which takes us to all of our blog posts. You notice this displays instantly because we are keeping those blog post summaries inside of that service, so we don't have to load them each time. And when we click on it, we can drop out to the outside world. So that is pretty much what I wanted to show to you today. In the last 40 minutes, 39 minutes, we have managed to create a website. We've made an Azure function URL. We've deployed it into Azure using those static web apps. And then we've made changes to start building your own brand without eating the elephant. There's lots more stuff I still need to do to this, of course. I want to make it look awesome. I want to put my own CSS on the top of it. I want to host my own blogs and change that canonical URL in dev.to so that Google starts to point to my site just a little bit. But I can do this step by step as I go forward and start to build up my own brand on the internet. Now, if this has got you interested, you want to have a play with this, then I recommend going to MS Learn and taking a look at the documentation for this. This QR code will take you straight there. And if you don't want to build this, I would still recommend going to MS Learn because there are so many amazing resources there that can help you improve the way that you use Microsoft's technologies. So that is it for me today. Thank you so much for spending this first hour with me. Thank you so much to NDC for having me. And I hope you enjoy the rest of the day. Thank you very much.
Stacy, that was fantastic. Let's get a massive global round of applause emojis. We have some questions in Slido and in the chat. So the top voted question is, and this is something that a lot of people have asked about Blazor. Does building a Blazor app and then hosting it in Azure, is there a cost of entry? Is it possible to do this without incurring costs?
Right now, the static Blazor web app is free. So it is possible to do free. I believe if you use the Azure function, then standard Azure function pricing applies to it. But you know what? Unless you are doing thousands upon thousands upon thousands of calls to your function, it's pretty much free.
So there you go. Yes, it is free. You can do this stuff for free. Another question that comes up about Blazor that a couple of people said in the chat, is it going to be another Silverlight?
I knew that question was going to come up every time. It is not another Silverlight, I am very pleased to say, because it is a WASM compiled version of the .NET runtime. It is native to the browsers.
So WASM is WebAssembly, which is actually baked into the browser. It's not any kind of a plugin or anything. And
exactly,
as we've learned from long history, once something is in a web browser, you can never take it out.
Yes. Otherwise, bad things are going to happen.
Except Java applets, but you know.
That was a good thing.
Quick question. Can we get the source code for this demo? I saw you were pushing stuff up to GitHub there. Is that a repo you can make public or share with us?
What I'm going to do, I have one repo which is without the dev.to stuff, and I will put that link on Twitter because I can't remember it from the top of my head. So I'm going to share that one on Twitter. And I think I'm going to have to make a blog post out of this talk as well. So my partner's going to kill me for saying this, but inside of 4 weeks is going to be another blog post kind of going through how to do this.
Question from Lee. You talked in the demo there about some 404s. Are they logged anywhere before the redirect happens?
No, they're not logged anywhere, I don't believe. I will happily be corrected there. This is...
Presumably that's something you could plug in a handler or something if you did want to capture those before redirecting. Yeah.
I would assume so. This is the whole roots.json part of Blazor. It's something which I've not got into too deeply yet. That's one of the bites of the elephant that I still need to take. So I'm not 100% sure exactly how this works. I don't know if it's the static web app itself that takes this, because there isn't anything running. This is all purely inside of the static web app, so I don't know how you can put some middleware into this. What you can do, or what you will see, is that if you put in a root which doesn't exist, you will still get your, hey, this page doesn't exist thing coming up because it can't find your root in the client side. And for that, you can put your own logging software in there. And I think I'd probably recommend doing that because unless you explicitly want to know when somebody deep links to your application, I don't think logging the 404s to the backend is entirely useful.
Cool. All right. Thank you. A couple more questions before we take a short break. Does the link require the server to load all of the JSON, or can it, for example, transpile to OData?
I have absolutely no idea. I'm going to be totally honest there. I really don't know.
There you go. Never be afraid to admit that you don't know something. It's an opportunity to learn. So,
absolutely.
Question Richard says, is the scaffolded layout there in Blazor, is that based on Bootstrap? Do you know?
I believe so.
It looks bootstrappy.
It also does look bootstrappy. It's the next step that I'm going to do, because the link that I showed for the stacyclouds.net, it looks remarkably similar to the one that I've just shown on the screen. My next step is just stripping out all of this CSS and trying to learn CSS whilst doing it.
That sounds like a fun project.
I want to make it look kind of cool before I take the next step forward, and I hate CSS. It's not my thing.
The other nice thing folks watching on the stream might have noticed is that the purple gradient on the Blazor default thing is almost exactly the same gradient as the NDC Manchester branding. We asked them to do that specially because we knew this was going to happen. Now, just a couple more questions, two last questions, both about GitHub Actions. One of them is, can you align GitHub Actions with your different Azure DevOps environments?
It's not something I've done. The first time I gave this talk, somebody was really not necessarily the politest in the chat, telling me I was completely wrong for saying you cannot use static web apps in Azure. You just have to run around roundabouts to do it. So possibly. I do know that the team is busy working on getting Azure DevOps to work with the static web apps. I believe it was supposed to be available in March, but I'm guessing it slipped.
Fair enough. And last question is, can you add step actions to GitHub to do QA tests and to block deployment in case of failure?
It is just a standard workflow file. So if you want to do those tests before you call the actual GitHub action that does the static website stuff, yep, you can do that. You can do what you want inside of there. Fantastic.
All right. Thank you very much, Stacy, for joining us this morning.
Thank you very much for having me.
Thank you, folks on the stream, for all your excellent questions. We are going to take a short break now. We are going to interrupt the stream just for a second. There's a couple of comments in chat about folks only getting 720 pixels of high def on the other end of it, and we have found what I think is the setting that needs tweaking, but I can't tweak it without stopping the stream. We're going to be off the air for about 15 seconds, then we're going to take a short break. During the break, head over to expo.ndcmanchester.com. Our partners have got some expo booths set up over there. Fill out your details for a chance to win some amazing prizes. We got some AirPods Pro or AirPod Pros. We don't. What's the plural of that? We got some special Lego sets giving away. We're giving away some workshop tickets and various other things. So head over, check that out. We'll be back in, like I said, about 15 seconds. Then we're going for a commercial break, and then we will have Ian Cooper joining us to talk about TDD Revisited. So we'll see you all in a few seconds. We're back. We're live. And apparently, according to Anthony in the chat, 1080p is working now. All right, let's admit the next of our speakers. Please, everyone, welcome to NDC. I'm going to press a button here that is going to fix the layout. It's all very, very sophisticated here at the headquarters, as you can tell. There we go. And welcome, Ian Cooper. How are you doing?
Hey, my friend. I'm all right this morning. How are you?
Yeah, okay. I'm live on the internet with 200, 300 odd people watching, which is always an exciting way to start the day. It's better than espresso for giving you that little shot of energy in the morning. So
yeah, I've had to lock the cat out for the event. The cat has become possessed and attacks me. So I decided that I didn't want the viewers to wonder why is Ian screaming strangely during the middle of his presentation. It'd be difficult to explain the cat is actually biting me.
Excellent stuff. We are actually, just want to check, we got some setup to do. We are going to take a very short break. We are going to run a commercial reel. We got a bunch of sponsors. We've got Evendi, we've got Mago, which is the Manchester Airport Group. We've got Synopsis. We've got all kinds of people. Black Marble have helped us put this event together. They've supported NDC throughout everything we've done, pre-pandemic and during the pandemic. We're going to hear from them now for a couple of minutes, and then we are going to be back in a few minutes with Ian Cooper and TDD Revisited. We'll see you shortly.
At Ivendi, we build technology that makes it easier for dealers to sell and consumers to buy vehicles.
So what Ivendi does is we build a platform that facilitates online retailing. This means that we basically make it easier for people to buy cars and for dealers to sell them. We do this from end to end, so the full journey from consumers coming to the site right through to the finance applications that go through. So to facilitate that, we have really important relationships with banks, with vehicle manufacturers and with vehicle retailers themselves. The tech stack we use is mainly AWS, and we use C#.NET as our predominant backend language. And we use a little bit of Azure as well. We deploy most of the stuff in containers using Kubernetes on EKS. And we're a big fan of event sourcing here. That helps us to separate the domains out into separate areas, which allows us to keep those domains nice and segregated, and also facilitates the auditing, which is a big part of us working in a regulated environment.
I chose Ivendi mainly because of the people. They're very welcoming, they're really knowledgeable and seem really passionate about the technology and the quality of the products that they're creating.
Welcome to Mago. We're an airport-centric travel company owned by MAG, the country's largest airport group. Most importantly, we're a globally unique digital tech business based right here in Manchester. We operate as an innovation hub, a truly agile e-commerce business driven by data and the latest tech to provide airports across the world with a unique blend of products, technologies and services for their passengers. We have become synonymous with airport customer e-commerce platforms, which we're constantly evolving. If you plan to fly again in the near future, you may well use our system without realising that it's actually a Mago product. We are a business for someone who wants to create and do something a bit different. For the techies, we have a fail-fast CI/CD approach using .NET Core at the back, Vue and React at the front, and AWS cloud hosting. We expect to grow our team over the coming year, so please keep an eye on our Mago LinkedIn page for the latest jobs. Thank you.
And we're back. Hello, Internet. How are you all doing out there? Yes, Joel, you need to go out and buy a 4K TV so you can get the maximum stream quality out of this. We are here in the virtual studio with Ian Cooper. How you doing, Ian?
I'm good, my friend. Yeah. Ready to sort of share some stuff about TDD with everybody.
So you had a talk from, was it 2014, about TDD? Where did it all go wrong?
Yeah, NDC, I can't remember if it was 13 or 14, but long enough ago that we got old, yeah.
And it was a talk that got so many hits on YouTube that it made you cool with teenagers, I understand.
It did, yeah. My stepson, who is convinced I know nothing about anything, decided he wanted to become a YouTube star. And I did say to him, "Well, have you ever seen, my YouTube video?" And he replied, "What, that you and your 5 mates watched?" And when I pointed to the numbers on YouTube, for at least 10 minutes, he was slightly in awe of the fact that I seemed to be some kind of YouTube star. He since disabused himself of most of those notions. But there was a moment, Dylan, just a moment.
That was just a moment where you were actually cool.
Yeah, a moment where I was actually cool.
Thanks to the
happen again.
Thanks to the power of test-driven development.
Indeed.
So what else? We've got about 5 minutes before we kick off the talk itself. What else have you been working on during the weird lockdown pandemic thing, Ian?
Interesting, yeah. So we're about to get out a version 9 of Brighter, which is the open source project I work on, which helps you do messaging in .NET Land. And it's been a little bit of time getting V9 out. We had a couple of the other contributors go away on paternity leave, which is a good thing, but not quite originally in our kind of planning model. Yeah, there's some good changes coming. We clean up really our outbox and inbox support. We always had it, but we had different names because of the time at which we wrote them. Those names weren't really standard, and our behavior was a little unusual. So we've now cleaned those up a bit. We've got new versions of some of our transports like Kafka and SNS and SQS. And we've got, for the first time, we've got an actual good, solidly working one for Azure. We've always had kind of prototypes, and we know that it's fairly easy to write your own transport for Brighter. And we knew that people out there had written their own transports for Azure, and we finally got some of them submit one back to the project, so that we've now got a working one. Yeah, so we're pretty pleased, excited to get that out. We've been playing a bit with things like GitHub Actions. We've got a slightly new pipeline, but Toby Henderson, a friend of both of ours, has been beavering away trying to get that to work properly so we can get that all released. Yeah, and that's been quite exciting recently. So I'm pleased to see that getting back on track.
And you've also been running some occasional... So Ian and I, for those you don't know, we help run the London .NET user group, which Ian started when .NET was in beta, I believe. Like before even Visual Studio .NET went to release in 2002 or so.
It was, yeah. And I often talk about the fact that... I was lucky enough to get into speaking, really, because when we started the user group, there were no speakers. No one knew anything about .NET. So we had to kind of like go away and do the research ourselves and come back and present to the rest of the group. So it gets you over that hurdle of talking to other people quite early on.
It is one of the interesting things, I run workshops for people who want to get into conference speaking and all kinds of things. And there's two kinds of people I talk to. The people who they see someone who's on stage and they're just amazing. And they're like, I want to do that. That looks like so much fun. But then there's the kind of the unspirational ones, which are the people who go to a meetup and they see somebody and they're like, I'm terrible, but I'm better than that. Yeah. And it's one of the really interesting things about, community events is you do see people kind of very, very early on when they're still figuring out the levels and the format. And it's, one of the things that I think has been really interesting about NDC Online for the last year or so has been we're still seeing a pipeline of people who want to get into conference speaking and are submitting, they've done a talk at some online user groups and meetups and they're submitting that content and trying to, get that on the agenda for NDC and other events that I work with, which is brilliant. That's something I thought might not happen. I thought a lot of people would just be like, I'm going to wait till this is over and then I'll try and get into speaking, but it hasn't. And it's amazing to see so many people still enthused about trying to get into it and stuff.
Yeah,
So,
I do wonder whether also, in some ways, you may even find that, the ability to do it from home, that you're pulling in people who are more used to, Twitch streaming models, etc. So are we getting some people who actually have been working in this kind of format now?
Yeah.
Mixing in with our format.
There was definitely a moment where I was like, I need to talk to people who play Minecraft on Twitch because they know more about this than any of us do.
Right.
So...
Anyway, it is their world suddenly, isn't it?
It is their world, and we are just playing in it. But we're starting to get the hang of it, I think. Anyway, I make it 10 by the official event clock here. So, Ian, if you would like to share your screen, I will push the magic button and hope that nothing blows up when I push it this time. It didn't blow up, I just knocked the thing off last time I did this.
Right, let me just find the right one. Share the screen. Let's play that.
There we go.
The magic will work.
You've done the thing. You need to click the button that switches the presenter view and the other view. But I'm gonna punch that. So we're gonna switch the stream over.
Hang on. So I did have this working. I managed to get it to do the right screen.
There is a hilarious combination of factors that comes into play when you're doing this, which is that quite often when you do something in Zoom, it moves windows around that you had lined up just neatly and just nice.
Yeah.
Actually, they all do that. Everything, the ones that run on your desktop, Zoom and WebEx and various other apps I've used, have a habit of going, no, we're going to put this window over here now. So let's see what we can see. There is a, yep, hit it, and if this works.
Can I get the...
So there's a button top left that will switch the displays. Swap displays button.
Okay,
That's the one you want. Boom, there we go. All right, please give a big NDC Manchester online welcome. TDD Revisited in Cooper.
Hey all, and welcome. Let's talk about TDD. So many of you may have seen that I gave a talk back in 2013 at NDC Onslow called TDD, Where Did It All Go Wrong? And this talk doesn't contradict any of that, but it's designed to give you perhaps slightly more focused guidance for if you kind of agree with the sentiment of that talk of what you and your teams should take forward as practices. And I've divided it into a set of what I think of are fallacies that we all hold about TDD and what principles we should be using instead. You can find me on Twitter. My DMs are open. If you want to ask me about any of this material, I will try and reply, my small children permitting. Nothing much too interesting to say here. I think Dylan's spoken about quite a lot of this just now with you and I. And I would encourage you all to try and get into speaking if you can. Start your local user groups. They'll be hungry to hear from you. And you really can help focus and develop your own ideas. As you just mentioned, I work on an open source project on Brighter. We are always keen to have new contributors come and join us. Okay, we've got a lot to get through, so let's really crack on. So I'll talk a lot about these fallacies and principles, and at the end, I'll talk a little bit about clean architecture and how that can actually help us. Okay, so let's get into it. The first fallacy I want to talk about is the key one, I think, and that's the idea that developers write unit tests when we're doing test-driven development. If I go away and look at Wikipedia and look at what its definition of unit testing is, the key idea is it's saying that we want to isolate the unit which is under test and have substitutes which effectively stub in for the other units we may be collaborating with so that we can test that individual unit in isolation. And that leads us to this idea of having a unit test for the individual little black box, an integration test which tests a couple of black boxes talking to each other, and a system test which tests all of the things in one. And the goal is this kind of idea of defect localization. I'll be able to know that the defect belongs inside this unit that I'm testing, and that's where the problem is. And if it's basically got tested units, then when I have two units tested together, the problem is how they integrate, right? And our goal is to essentially help us find where these problems occur. And there's a requirement really here to have some notion of what we call a test double generically. So usually we refer to this as simply as a mock or a stub or a fake. We have a requirement to have those to exclude the things that aren't the thing that's under test, right? Otherwise we can't achieve this defect localization. And the height of this kind of approach, when people in the kind of test-driven development area talk about, is this idea called need-driven development. And the idea behind need-driven development is we start kind of at the outside. We write a class, and then we say, okay, it needs to talk to another class. So I will replace that dependency with a mock. And that means that either we need to have some idea of our class hierarchy before we kind of begin our testing. We may, if we're very XP focused, take something like CRC cards and play those and have an idea, therefore, of what we think our object structure is. Or we may do it by a process of discovery. We write the test around our outer class, and as we dig into it, we say, that's probably something that's responsibility of another class. And rather than write that class now, I'll simply stub it out. I'll put basically the definition for a mock into my test. And then essentially I'll move on and do the rest of the work that relates to this class. And that leads to this pattern where you're testing the expected indirect outputs. By that we mean we test all these calls I'm making to other classes. And often we're using that approach of saying, well, I can figure out whether this is behaving correctly because at this point it should pass this value to this other class with, you know, in the parameters it makes in the method call to it. And the problem with that a little bit, though, is that now our test understands all of the details of our implementation. And what we don't have is something that solely focuses on the contract, the contract of the thing we are testing, right? And we've coupled our test into our implementation details. If I want to change how that works, I now have to change the test too. So let's say that one of those collaborator objects that I'm talking to, I decide, actually, it has too many responsibilities. I need to split that in two. In order to split that in two, I have to change my test because I now have two mock objects that I'm talking to. So there's this coupling. The test and the implementation details are inextricably linked together now by this need-driven development process. And my kind of experience of this, even back in 2007, was that this was highly problematic. So when I wrote a class, what I tended to end up with was, under this kind of approach, was I had to basically take every single collaborator and provide a injection point in the constructor via using in a sort of strongly typed language interface so that you can use duck typing and things that are dynamically typed, so that effectively I could inject all my collaborators. And the problem with this became that all of our classes tended to end up with 3 or 4 dependencies that they were injecting. And because that collaborator itself, when we wanted to pass the concrete type in, it had 3 or 4 dependencies, we saw the rise of inversion of control containers because it became too complicated to build the graph ourselves. We couldn't do poor man's DI anymore. We're at the composition root. I simply created a few top-level objects, which when they needed something, we just knew it up. I had to essentially get everything built via essentially this model of using an IOC container. And we add a lot of complexity to our code just to support this idea of doing need-driven development. But the problem became that as we expressed before, our tests will now break whenever we want to change any of that kind of graph that we've set up. So our tests have this enormous dependency on this graph of need that we've created. Our tests have become very needy. Our code has become very needy. And that was never really our goal. Our goal was to really think much more about a contract first based approach to testing, to say, I want to understand what is the contract that I'm expressing in the code under test. I want to explore that through my tests. I don't want to understand the implementation of that contract. And that leads us to our first principle, which is that developers write developer tests. Now, the word unit testing crept into our lexicon because it was something we used in verbal communication on common parlance. And Kent was very aware of that. And in the TDD book, he said, you know, verbally, I call them unit tests, but they don't match the accepted definition of unit test very well. And in fact, in the book, the only single place that he uses unit tests is to deny them in this book, right? Everywhere else, he just tends to use the word test, or occasionally in some places, small test. Right? So explicitly, Kent is saying these are not unit tests, and they don't meet that definition. So what are tests? How can we define them? What should they be? Well, one key thing to understand is that the cycle of TDD is red, green, and refactor. Right? And one of the problems you will find with using a kind of unit testing approach is that you end up, in many cases, not doing very much refactoring. And occasionally when I run a kind of workshop around TDD, I push people through the exercise of using the unit testing approach to doing a kata first. And one of the observations they often find is they do have a red stage and they have a green stage, but there's very little refactoring. And that's because you've done much of your design thinking up front in order to allow you to mock everything out. When you've done the design thinking up front, there really isn't much need for the refactoring step. Whereas if I use an approach which says, I'm going to do refactoring, and I'm going to do refactoring I've done green, and in green what I'm doing is writing sinful code. I am cutting and pasting from Stack Overflow. I'm writing a huge transaction script. I'm understanding the algorithm so that my tests go green. And it's in the refactoring step that I produce the structure and the design. And so really, in refactoring, we remember that we say, I can basically change the implementation details without changing the observable behavior, and therefore I don't need to write new tests, right? That's the key goal of refactoring, right? You can say, I can go and change the implementation details. That's safe to do because the tests will preserve the behavior for me. And if I break the behavior, a test will warn me. And that's exactly the same in the TDD cycle of red, green, refactor. That's not something that occurs post TDD. In TDD, you're doing exactly the same thing. You're changing the implementation details, but the tests tell you it's fine. You haven't broken the contract. You still behave the way the contract expects, right? And I can't do that if any changes to my internal structure would involve me rewriting the test. So this notion that I've coupled my tests deeply into my implementation details can't work with refactoring. It limits refactoring. It truncates the TDD lifecycle from red, green, refactor to red and green. And it provides a maintenance headache for you because you start trying to change your code and your tests keep breaking. And Kent's been, talking about this recently, making the observation that if a program's behavior is stable from an observer's perspective, no test should change. In other words, if I'm changing the implementation, but the behavior that I'm expressing is the same, then I shouldn't have to change any tests. And the important thing to understand about TDD is it's a kind of contract-first approach to design of our API. Okay. And by API, really, I just mean exports from a module, however we want to define a module in our use case, be that something explicit like a Python module that exports, or be that something like access modifiers being public in something like .NET, right? But what we're saying is the contract is what we're actually exploring with TDD. It's a way of doing that contract first approach of saying, hey, I want to create a usable contract to express this behavior, and I want to check my implementation of it right afterwards. And so if I change the implementation without changing that contract, if I support refactoring, then I don't need to change tests. Kent also talked about this in only 2019. Kent was making the same point again, right? He's saying tests should be coupled to the behavior of code and decoupled from the structure of the code, seeing tests that fail on both counts, right? So our tests coupled to the contract that we have under development. They don't couple to the implementation. They don't use things like mocks heavily. And Kent's statement of personal style, which he made in an interview with Martin Fowler and DHH, was to say that he doesn't go very far down the mock path. His test is completely coupled to the implementation of the interface if you do that, right? So you don't use mocks to isolate the SUT. You're not using a unit testing approach, okay? You don't want to observe the indirect outputs. Okay. And a part of the problem here is that the key idea in unit testing is that failure of a unit test implicates one-on-one only unit. And that is, if you like, the driving force, that basically the method, the class, the module, or the package, or whatever you have, the failure must direct you towards the failing unit. But in test-driven development, where we work with what we call programmer or developer tests, the goal is that failure only implicates the most recent edit. So the idea is when I write a test and I go and effectively make some changes to my code, if existing tests fail, then I know that essentially that most recent edit is the source of that problem. And that's how I get defect localization. It is defect localization based on the most recent change that I made to the code. And that's fundamentally, those two lines are what test-driven development is. There's an overall definition. If you go to the C2 wiki, this definition, which deals a lot with the kind of ideas that came out of the XP community in Agile, and you can find some very useful references on there. It has a very good definition of what test-driven development actually is, right? So test-driven development produces developer tests, and sometimes we call them programmer tests. And really, I think as a community, we should get used to using that name over unit tests, because unit tests have all this baggage about unit testing with them, right? So in test-driven development, I'm producing developer or programmer tests, right? And it's a process of discovery. It's where essentially I keep writing new tests and I then add more implementation details. And that most recent edit is effectively the thing that's in flux. And as a result of that, I will figure out whether or not basically I've broken my code. And what I can then do is make a decision. I can either, and this is one of the kind of real, hardcore XP community would advocate, is I revert that change when I see it break things and try again. Whatever I was doing there isn't the right approach. It will break existing behaviors. Or, and I tend to be pragmatic and do this, but spin up that debugger, right? People don't like that because it slows you down, it breaks your focus and your concentration, but in many cases, it's just a simple or stupid mistake that I can move. And I would move on from the debugger if that doesn't quickly tell me what's going on. In some cases, you just know. You see the thing go red and you know, right? And we don't use mock objects to isolate the class under test, right? And it's not really classes, we'll come to that in a minute. But I don't use mock objects. Now, there is a place for a mock, and that's that essentially we want to be able to run tests quickly. And as a result of that, we want to be able to run them in parallel. To run them in parallel, there are certain constraints. Well, one of them is that we don't want to have essentially what we call a shared fixture. So a shared fixture is anything where two tests are talking to some kind of state, like a database or the file system or something that's basically static, where essentially the running of one test could input the results from another test. And those are things that we want to essentially replace with a mock. So when we talk about isolation in TDD, we talk about isolating one test from another, not talk about isolating one thing under test from another. And the purpose of mocking, as described originally in kind of Kent's TDD book, was to solve that problem of, hey, I have this thing that essentially is shared state, and that's going to be a problem for my tests because I effectively have to make sure that they don't interfere with each other. Usually we find that's I/O. And we also find that if we tend to basically replace our I/O in our testing, it solves a couple of other problems that we may want to basically use a mock for. Speed. If I'm talking to something that's I/O, like for example, a third-party service or essentially a database, will tend to slow my test down. And we want fast feedback, right? I want the developer to be able to essentially almost seamlessly, finish writing their implementation, so their test, hit test, and they can see the results. I don't want to break their rhythm, right? And fragility. Quite often where I talk to I/O, it may fail for network reasons, like the tests are much more fragile. Okay. So again, I may want to essentially replace with a mock there. But the reasons for using mocking are isolation, speed, or fragility. It's not to do with basically isolating the SUT. That's not the purpose of TDD. We're writing developer and programmer tests. We are not doing unit testing. Okay. Next fallacy I want to talk about is that the trigger for a new test is a new function. And this is this kind of idea that whenever I want to write a function, I should need to have a new test first. Okay. And generally, this is predicated on the idea that a function has a set of preconditions, things that are true beforehand. We exercise the function, and then we can test a set of postconditions, things that are true afterwards. Okay. And the idea then within this kind of model of TDD would be to say, well, that's great, because essentially I can use my setup to basically set the preconditions. I run my code and I've got a set of post conditions, and great, I've got testing around my functions. The only slight problem for us is if I've got this thing that's very granular, what kind of checks the actual overall behavior? I've got these parts, but where does the whole come from? And that leads us to really getting into the world of acceptance testing. All right, we'll talk a little bit about that in a second. And testing becomes basically this idea of confirming the functions that we have. And that leads to ideas like parameterized testing, where we're saying, well, really, I need to test my function under a whole range of possible conditions. And then this idea of acceptance testing. And really, we're moving a bit away from TDD there. We're getting much more into the idea of testing and how I think about regression, right? Okay. And these ideas like acceptance testing that creep in to TDD have as an idea of I need to have an acceptance testing framework, cause us all sorts of problems, and we'll discuss those in more depth later. The other thing I note about this style usually is that my experience is that when I return to my tests, I find it difficult to understand them, right? It may have gone red. When I go and look at the tests that have gone red in this kind of style, I'm like, well, okay, the test is now red because the post conditions are failing on the preconditions, but is that because the behavior's changed and actually I need to fix this test because its post conditions have changed? Or is this that the post conditions remain true and therefore I've got a bug? And part of the problem here is intent. There was this dream that we had that we wouldn't need to write documentation anymore because test-driven development would give us executable specifications. I'd be able to go and look at my tests. They'd be clear examples of how I use my code, and the developer could just go and read my tests and go, great, I know how to use this code, this framework or this library or this code completely correctly from looking at the tests. And that kind of gets mocked now. You'll see out on, out in the Twitterati mocking this idea of executable specifications. Ha ha ha, that didn't really work out, right? But the answer really is that they're doing TDD all wrong, and that's why we don't have that. Because this unit of granularity tells me nothing. I can't contextually understand what this is for. So the principle we want to look at is that the trigger for a new test is a new behavior. So when I look at Kent's book, TDD by example, this is a typical example of the kind of thing that Kent is showing you writing a test against. We need to be able to add amounts in two different currencies and convert the result given a set of exchange rates. Okay. And if I read that with a more modern kind of like perspective, I could say, okay, given that I have a set of exchange rates, when we add amounts in two different currencies, then we convert the result. And many of you, when you look at that, hopefully will go, hey, I recognize that. Isn't that this kind of given, when, then approach, right? That BDD advocates basically recommend. And it's true, right? Even at the point of TDD by example, what we're actually being asked to write is given, when, then statements about behavior that we want to see expressed. That's what TDD is focused on in the examples that were given originally. So I can demonstrate it like this. Given I have a set of exchange rates, when I add two amounts in different currencies together, then I get a result in the first currency. Just a rephrasing of exactly what Kent wrote originally, right? Given the state of the world before the test, when I exercise the behavior under test, then we expect the following changes. And you can structure that in different ways in your code, right? You could use some framework that expresses that directly, but to be honest with you, people like Jared Mazaris have talked about basically the fact that the fourfold test model, your setup of your code is your given, your actual method that does the exercising the test is your when, and then your assert statements are where you verify essentially the then statement. Then you've got a kind of tear down model afterwards. And actor range assert from Bill Wake is really expressing the same thing. But they're all trying to express the same thing, this given, when, then model. And even back in JUnit with its fourfold test model, we were trying to express this same idea, right? So really we are focused very much on behavior. And that's, I think, what led Dan early on in the history of test-driven development to make this statement about, hey, a behavior-driven development is a better name for this, right? Because this idea that basically TDD was a technique for testing, which leads us down this path of unit tests, integration tests, system tests, mocks, is not really correct. TDD is a technique for contract first, exploration of behavior. And so that's why really Dan came up with this idea that behavior-driven development would be a better name, because it shifts your focus from tests to behaviors, which is really what Kent was trying to get at in that given when then statement that he wrote. He just didn't call it given when then, right? So later BDD becomes quite a different thing. I'm not really advocating that you should all start embracing BDD. You know, that's a different kind of platform. I'm really recommending you do TDD right, and that BDD in its original kind of assertion was actually effectively TDD done right. And so we can look at what we should be doing in this way more, right? The next test that you write is the most obvious step. And this is the fundamental process, right, of TDD. I say, I need to write a new test. What's my new test going to do, right? It's going to be the next most obvious step I could make, right? The smallest change towards essentially getting towards the acceptance criteria for the behavior that I'm trying to basically express here. And the behavior that we're trying to express tends to be acceptance criteria on a user story or use case, whatever it is that you're using to implement. So essentially, you know, in my life cycle, I've got some agile process. It's creating user stories or use cases. My product owner nowadays, effectively speak customer, will sit down and give me a set of acceptance criteria. Those acceptance criteria may be phrased as something like given when thens, and say, you know, given this state, when I do this, then I do that. The next test I write is the next smallest change that I can make to basically implement that required behavior. And that may involve me writing a new method on a class. It may involve me writing 2 or 3 classes that are collaborating to exhibit that behavior, right? But it's the smallest possible change that I can make. Often that's a function, because that's the smallest thing, but it may not always be, right? So don't think about the artifact of, hey, I watch people and they seem to be adding functions. Think about what they are doing, and what they're doing is making the next smallest change that they can make. Hence why we get, when you see people practicing TDD, you get this idea of saying, you know, fake it till you make it. I'm going to return null. I'm going to return 0. I'm hard coding my values. And you're a bit like, well, why would you do that? Because that's the smallest change I can make to get that test passing. And it may push me to add new tests to explore the criteria in more depth. That does read the question, right? Hang on a minute. If it's my TDD, that's essentially, if I'm driving my test-driven development practice by looking at behaviors, looking at these given when thens, what is the acceptance testing stuff for? And again, we'll return to that. The other thing that's worth noting is when I get to when I'm practicing red-green refactor, in my green step, I have written sinful code. I've cut and pasted from Stack Overflow, and I put that in to get the algorithm working, because my goal is to understand the algorithmic solution to the problem as fast as possible. When I get to refactoring, I'm going to write clean code. I'm going to improve the quality of the code. And that may mean I say, you know, I'm going to take this section of the code in the green, and I'm going to break it out and make a new class. That's an implementation detail. It's not part of my observable behavior of my contract meeting acceptance criteria. It would be in a module, it wouldn't be exported. If you're using access modifiers like public, private, it would be private. And I don't need to write new tests for those, right? Those refactoring step items are not part of my observable behavior. They're an implementation detail. I can change them when I refactor something. Therefore, I shouldn't couple tests to them, because tests will make my code more rigid, because I have to keep changing all the tests in order to change those details, right? So I don't couple the tests to details. I say, hey, that's okay. That's hidden. That's a private. It's not exported. It's fine. There's no need for you to basically have tests for that. we know that we have coverage of it because refactoring shouldn't be letting us introduce something, because it's a series of safe moves that essentially creates untested paths. The original test tests this code. Otherwise, it's not a refactoring move, right? If I'm just doing a whole scale rewrite that, doing a refactoring move, I may introduce new paths, right? And it's always worth having code coverage tools to check. I haven't introduced new paths, etc. But you don't need to write tests for every single thing you create, right? If you sit there thinking, how do I test my private methods? You don't. Okay. Yeah. And this is just saying to you, effectively, make sure you remember that in order to, if you're not getting a true red-green refactor life cycle, if you're not getting to the point where you really feel the need to do refactoring, then you're probably, because you're doing too much design up front and your tests know too much about implementation details. So we mentioned this a couple of times, and now it's time to kind of address this. There's this fallacy that customers should write acceptance tests. So what was going on here? Customer tests, sometimes called originally functional tests. The idea was we wanted to test basically the functionality of the user story. And the key goal here was that we had some notion that XP used to call an on-site customer, now really tend to consider as being the product owner, someone who was basically, whose expertise around the domain was asking basically for the things the domain needed, okay? And the idea here was that that customer would write the tests. They would go and write tests, but because they were often not a developer, we provide them with some kind of DSL. Early days, things like fit, which basically use a table-driven approach. So I could go and put in values in a table, which is very easy. I think perhaps easier in a DSL in many cases, right? They could go and write those, and then effectively we would then automate them to prove that they worked. But there's a problem with this, right? And the problem effectively is that it requires quite a lot of work from us. Writing effectively these DSL-based acceptance tests requires developers to be able to have a toolkit that parses the best FBrus in the DSL, takes those parameters, figures out how to use that to drive stuff. We tend to end up with this, if this DSL is chaotic, we need to basically tell the user, hey, there's ubiquitous language. You need to basically constrain yourself to talking in this terms in DSL, which feels an awful lot like I'm asking you to write it in a programming language. Didn't we say the problem is you weren't a programmer, right? A lot of effort in those. And if I'm my TDD, if I'm now saying, hey, I'm doing developer and programmer tests, I'm writing contract first, essentially. I'm using the test to explore that contract. And the contract I'm exploring is the behaviors of my system as given by these given when then use cases. If that's TDD, and I can have multiple classes under test in that. If that's TDD, what is this giving me in addition? Now, James Shaw, let's talk about his experiences. James Shaw was one of the authors of Fit, right? So he's got skin in the game. James essentially built one of these early acceptance testing tools. And he stopped using it. And the question is, well, why did James stop using it, right? Why did James, one of the authors of Fit, who'd invested time and effort in building these tools, why did James want to stop using that? And his key problem was that customers don't participate. There's this idea that we're writing a customer test, right? But the customers often don't write it. If what you find is that you're the person as a developer sitting there with your Cucumber-based tool or whatever, effectively, etc., or your Fit-based tool, and you're the one writing the tests in the DSL, what have you actually gained? That was supposed to be your product owner writing those. Do they even view them? Do you sit down with them and they say, oh, great, fantastic. I've really been looking forward to the end of the iteration. So I can sit down with you and we can read through the Cucumber tests together and I'll get lots of value from that in seeing you make them go green, and I'll know that the behavior I wanted is available. Look at the UI. No, I don't want to do that. I really want to focus on this DSL you built for me. That doesn't really happen ever, right? I think I've managed to force people to do that by literally almost strapping them to a chair, but it doesn't really ever happen. And they have enormous cost right? There's a whole semantic dissonance for the developer who's forced to switch between a tool written kind of in their own language that they're using to do development in, which is one of the key goals effectively behind test-driven development. Your X-unit testing framework should be in the same language you're writing in, so you don't have to context switch. But I've got a context switch here over to the DSL. I've often got to define basically, what is this domain-specific language that I'm needing at this point, right? Hugely expensive and doesn't really give you any value. And the problem, I think, is that ATTD has come to exist because when we've created a notion of unit testing as being our test-first practice, what we've ended up with is these small, tiny chunks that we are testing around. So we're forced into the position of needing something like ATTD to check the behavior. But if TDD is being driven from the acceptance criteria, which we've established is the original intent, we can rewrite those clear statements of basically what are we testing this behavior as a given when then clause, then we don't really need ATDD because the TDD is already done that. Kent originally, talked about ATDD and TDD by example, and he said, I think it's problematic because the length of the cycle is too long. And because many of these tests can't go green until all the subparts are written, they spend much of their time red. And if they get spend much of their time red, developers tend to ignore them. Oh, those tests are red. Yeah, that might be somebody else working on something that's not complete yet. And at the end of the iteration, we go, oh, we've got to make it all go green. We crunch. We're not agile anymore. We're effectively crunching a tiny little waterfall process where effectively we fix these all up at the end of the iteration. So what's the principle here? The principle is that customers, product owners, if you like, simply specify the acceptance criteria, those given when then clauses. Right? And James talks about this, talks about basically what his new practice is. He was asked basically, well, if you don't use fit anymore, James, what do you do? And he essentially said, well, I want the customers to illustrate with examples, and the developers will simply use the examples directly in their tests. The examples are a guide for them how to write these tests, right? And if we think about that, that's the model we're proposing for test-driven development, right? We've got these given when then statements, and I'm using those to write the next test. I'm using those to say, what's the smallest change I can get towards completing that requirement, okay? So we're not necessarily directly coding the given when then in, and the frameworks that do that are a little bit problematic because they force you into this model of actually focusing on the given when then rather than the contract of the API under test. So I would tend to always favor XUnit over that nowadays. I went down that route and it's painful. It hides the API. Okay. So they're a guide to us writing the tests, right? The next smallest thing. But what they will give us a lot more is this idea of documenting or self-documenting code. Because now our tests are focused on saying, hey, here's how you call the code to get this behavior. Here's how you call the code to get this behavior. Here's how you get the code and you can determine that when I've called the code with this behavior, this is what the result should be. And suddenly our tests become much more comprehensible. I can now look at my tests and understand when it's red, what behavior have I broken? Okay, great, we were changing that behavior. That's fine, I just need to change the test. Wow, that behavior is really important. I don't want to break that. I've done something wrong. It's in that last edit that I made. Hey, am I going to revert it or am I going to try and debug through that? I think that must be pretty close. It's probably a silly mistake. Let's debug for 5 minutes and then figure out whether that's wrong, right? That's the cycle of TDD, not let's go over and write some tests in Cucumber and then figure out basically lower down in when we write these tests, which are basically mocked out completely around these individual functions that essentially maybe the behavior is incorrect and that whole design needs to be changed when we get to the end of the process, right? The whole process of doing ATDD locks you into a waterfall development model. Okay, the next fallacy I want to look at is it doesn't matter if you test first or test last. The coverage is the same, right? We still got test coverage, and in fact, you see people saying, "Hey, we've done some analysis and we looked at the data around the test coverage. People who did test first and test last, and it turns out it's the same. So it doesn't really matter whether you do test last; it's just as good." right? Okay. So what is this test last? Well, test last says, what I'm going to do is I'm going to go and write some tests for the corresponding units after I finish working on it. It's explicitly a unit testing process. It says effectively, I've already got the code, it's got units, I'm going to test them. And then maybe I'm going to write some integration tests, right? And often I think it's the prevalence of test after in people's approaches towards doing development that has essentially really pushed forward this kind of mockist approach. It's not even really need-driven development that's got us there. Okay. And we have to do a lot of thinking up front in this model, right? We have to explicitly make all of our design decisions before we get feedback on them from our tests. So we lengthen the time between making a design decision and getting feedback on that design decision. We throw Agile out the window and we say, you know what, I just want to write code and test it after. I love waterfall, that's me all over. Okay. We don't want that approach, really, do we? Right? We want to be much more agile. And that's the problem. We've created a really long feedback loop for ourselves. My experience is that essentially this tends to lead to the problem of us writing lots of speculative code that's not actually governed by any given requirement. It makes it difficult for us to know when we are done, and it often leads to rework. Because when we get to the end and we look at this behavior expressed by the TDD statement, we find that we didn't implement the right thing. And then we tend to get into this horrible world where we say, I spent a lot of time and effort on that code. Maybe I can kind of hack it to make it work with the acceptance criteria. And so we end up with poorly designed code because we designed our code ahead of understanding what we were designing it for. Right? And often we're making speculative judgments about what we think will be necessary. And it turns out we don't need to do that. Or our understanding it was bad enough that it costs, we have to rework the whole thing. So we need to stop engaging in this waterfall style process and calling it TDD because it's not, right? TDD is a process effectively of contract first exploration of behaviors of the system, where we say, what's my behavior? What's the smallest thing I could do towards implementing that behavior? Let's effectively get that to pass green by figuring out what the algorithm is. Now let's do redesign around a provable requirement that we have that I need to implement. Okay, so our principle is only write production code in response to a test. Okay. Only write production code responsible to a test, which means we can't write speculative code, right? The only code we've got here is the code that makes that test pass. And the green phase tends to mean we're not writing tons of code. Oh, maybe this is how I'll implement it. We're just doing enough to get that to pass as quickly as possible. When we get to the refactoring step, we're only refactoring code that exists because its purpose is to satisfy a given requirement. Right? I don't have good enough requirements to be able to write that next test, take that next step towards basically implementation. And the problem is about our requirements. It's a prompt for a conversation with the customer. I don't really understand what it is that I'm writing. What is the acceptance criteria you're looking for? And when I do this, I don't really know what the result should look like. Can you tell me about this edge case that seems to be a problem that I can't understand, right? There's a back and forth dialogue about the requirements, and it's dialogue, right? I don't have to get them to sit down and write that. I don't have to say to them, hey, I'd like to know how this works. Can you go and write that DSL in Cucumber for me and explain that? I'll be waiting, right? I just talk to them and say, hey, how is this supposed to work? Right. We're looking at basically saying, well, what is the contract we need to express this behavior? There are two things you're doing with a test first development approach. You are designing as you go, right? You are saying, I'm exploring the contract I need to satisfy this behavior. And as you go, you explore that requirement. And you doing scope control. You are saying, I only want to write enough code to meet that requirement. Two goals, scope control and design. Right. Neither of those are things that test after gives you. Test after will not give you scope control. because you have already made your design in advance of the testing with the acceptance criteria. So you've already committed the sin of creating speculative functionality, right? And it won't give you feedback on your design step by step. You've already made your design. You're getting your feedback a long time later. You're not saying what's the smallest design increment I could make, and what with quick feedback on it. Right. So test after fails as a process that controls design, that moves our design forward, and it fails basically as a process that does scope control for us. It is not the same. And the fact that we get similar amounts of test coverage is irrelevant to our assessment. So if you see people, writing a white paper and saying, I looked at the two and I get the same amount of scope, test coverage, they've kind of missed the point. They're testing for the wrong thing, and they will always therefore get the wrong result. Next fallacy is you want 100% test coverage of your code. And this is an interesting fallacy because I'm going to talk about something Kent said, which is basically TDD follow religiously should result in 100% statement coverage, right? So am I denying what Kent said, seeing as I would think the TDD by example book tells you all you need to know about TDD, right? Well, really all we're saying at this point is if my process is essentially to never write code speculatively, but only write it in response to a requirement, then effectively I will always end up with 100% code coverage, right? Because I say, okay, I've got a requirement. Here's the next smallest step I can move towards that. Here's the implementation for that in green. And when I refactor, I'm just changing the structure and a series of safe moves that don't introduce new paths, etc. And therefore, effectively, it's covered by the original test. So in principle, I couldn't ever not get 100%, right? How have I written this code that isn't covered by my test? Okay. And it's only really something like test after that would introduce this problem. I've speculatively created lots of code when I come to basically an implementation step, because really I'd done my design in my head beforehand. I wasn't doing proper red green refactoring cycle, right? Or an accident where effectively when you do your refactoring, you don't get it right and you introduce a new path or a branch, right? So why do we, even if we're doing proper test-driven development, even if we are actually a test-first team, why might I say it's a fallacy that you have 100% code? And the answer is that actually, I don't believe that all of your code should be tested by a test-driven development approach, right? We focus on what TDD is, which essentially is this idea of saying, effectively, it's developer tests. We write those developer tests in response to basically implementing the next smallest change I can make towards implementing a given behavior that the customer wants in the system. And I may say that there are areas of the system where it doesn't make so much sense for me to do that, right? And so what I may focus on initially, rather than 100% test code, I'll come back to what those areas are in a second, is when I do refactoring, the most useful way to look at coverage is to say, hey, before this refactoring, what is my coverage percentage? After this refactoring, is it still the same? If it's not, then I've probably introduced some untested code branches, all right? So this leads to this principle, not all code should be driven by TDD. Okay. The purpose of TDD is to provide you fast binary feedback on a design that you are creating in order to satisfy a customer requirement. If it's not the fastest way to get useful feedback, then do the other thing that is. All right. So some suggestions. I would avoid test driving visual output, because probably what's happened is a UX designer has given you the design. So I'm not doing exploration of the design of this. I am just implementing that design, right? It is often fragile and it is often slow, and it's often not binary in terms of the feedback. That may be a more suitable place for me to think about a test after strategy for regression. And the quickest way to get feedback may simply be to run my code and look at the UI that I'm creating and do exploratory testing on it. If I'm spiking something or I've got some kind of throwaway code, there's no need for tests around that, right? The spike is getting me feedback. It says, I don't know how to do something and I want to get feedback on it. Hey, I've got this new SDK that I need to understand. How am I going to understand it? Oh, I'll just spike it, right? Now, some folks find it helpful to basically approach those by using some kind of XUnit tool, etc., and that's fine. Go for it if that's your preference, but don't do test-driven development for a spike, right? Integration, right? So what do we mean by integration in this context? So if I have some mocks that provide me with basically support for isolated test, fast test, and avoid fragile tests. So generally around IO issues, where essentially I will find that basically is difficult, then maybe I want to test those after. Because I'll tend to find that I'm just implementing a given specification that already exists. Hey, how do you do this? Or you just fill in these parameters and do this thing, and then basically that just works in this SDK framework. I'm not exploring that design in any way, really. I'm just doing it. And in that case, maybe test after is just as good. I'm testing essentially that really I hook up to that integration okay. Maybe even running it is actually just as good. And I may really only need the regression to say, hey, don't break that now. Okay. And don't ever do basically TDD around third-party code. It's not yours. All right. And so that means you won't necessarily get to 100%, and that's fine. Because really we're talking about a test pyramid, right? And what we have in a test pyramid is we say the further up the pyramid you are, the longer the time to feedback, the more it costs us to write that, and the more fragile those tests are. So we want to focus a lot of our effort down the bottom where I get the fastest feedback on the work that I've done. It's the lowest cost to do that. It's the clearest form of feedback because it's binary, it's red or green, and it's the least fragile. As I go up the scale, it may essentially get harder, but don't write a test using XUnit if it's going to give you longer time to feedback and be more effort and more fragile than doing one of the other things in the pyramid. Okay. If the fastest way to feedback with the lowest effort and fragility is to put the software in front of a customer, do that, right? We're focused and agile in shortening the feedback loop. And TDD is a way of shortening the feedback loop as you make design decisions about the API that you are building in order to implement a given customer's requirement expressed by behavior. And if that's not the quickest way to get that feedback, do something else, right? It's a practice. It is a tool that you can use that will help you in the right context. Use it in the wrong context and it becomes a burden, right? Okay, as we kind of try and close out, I just want to talk a little bit about clean architecture. It's not a whole talk on clean architecture, I do that separately. When we talk about, therefore, TDD and we're saying, hey, I want to think about basically mocks for isolating my tests from each other, for making sure that basically they run fast and making sure they're not fragile. But I think that IO out, is there a good way of supporting that? And really clean architecture is a good way of supporting that. So clean architecture is an idea of this synthesis of a number of existing ideas. Ports and adapters architecture, sometimes called hexagonal architecture, onion, boundaries, controllers, and entities from Jakobson. And I think there are quite a few other examples. In a sense, it's a pattern that's been rediscovered continually, right? And really, it's just a layering strategy, okay? So a layering strategy is just a ways of organizing our modules so that we have like things in the same layer, where we can prevent things like cyclic dependencies. So in the center, we have modules that deal with entities or domain, right? So our domain lives in the center. And entities are things where you have state plus behavior that effectively is coupled to that state. In other words, we tend to think that as a class, an object-oriented world, right? Around that, we have application workflow, which tends to encapsulate our use cases, right? So typically, you might implement these by something like the command pan, etc., where you say effectively, take the following entities, do this work with them, and then basically give me a result back. Okay. And then we have outside that the kind of frameworks which are allowing us to interact with the outside world, with databases, with HTTP, with messaging, right? Often third-party OSS libraries that we're using. And beyond that, we have essentially the actual devices themselves, the web, the actual database, etc. And the key thing to understand about this model is it depends inwards model. What we mean by that is things in the outer layers can depend on things on the inner layers, but you can't depend back outwards. What does that mean in practice? It means that the entity layer is a clean POCO layer. It has no reference to anything IO based. And that makes it very easy for us to avoid those IO concerns being significant in tests. Okay. So this is a kind of like different way of looking at that same diagram. I've got some delivery mechanism. It comes to a boundary layer. Generally, that's basically an SDK. Like, so if you're writing a web application, that's your kind of your controller. I talk to some kind of interactor, service layer, commands, something like that, effective, etc., which talks to my entities. I shouldn't talk to entities directly from the boundary layer, right? And that interactor may itself go and do stuff like go and talk to an entity gateway. So in other words, go and talk to something, data storage to go and get my entities out for me, right? Because essentially I don't talk to my entities directly from my boundary, then essentially I may need this request and response model, DTOs, if you like, right? Okay. When we use this kind of approach, what it means is we tend to want to focus a lot of our test-driven development against these use cases layer. Okay. That's where the behaviors are expressed. That's where essentially we say, hey, I've got this user story, which is really a lightweight use case, and it wants to do this thing that has this acceptance criteria. That lives at that use case layer. So that's where I write my tests. Okay. Sometimes it's worth thinking about XUnit is just another adapter. It's another way of driving my tests in the same way that I might get an HTTP request in and drive that use case from my controller. XUnit is just another way of me doing the same thing, right? You might drop all the way down and avoid use cases and test the actual entities themselves because you need more granularity in what you're observing, right? And this is really what's at the heart of what Kent calls gears in TDD by example. This idea that most of the time I'm driving along in fourth or fifth at the use case layer, but sometimes I want to drop down to the entity layer below because the going gets a bit sticky. So I drop down to first or second, right? And then essentially I can navigate to the entity layer and then kind of come back up. So that model looks a bit like this. I've got some XUnit framework, which drives my test, right? Which has my setup, my exercise, and my teardown inside it, right? I establish my request model in my setup. Okay, what are all the variables that I need to essentially drive this test with? I then pass them to whatever effectively is helping me deal with the entities if I've not done a lower level. So I call my use case. It exercises my entities, which may well effectively emerge from refactoring of my actual use case, right? And then it returns to me some values back, the response model, which I can then check with my assertions. And we may, as part of that test, need to essentially consider how it's going to interact with I/O, this entity gateway, and that's the area where I may choose to use a mock. Okay. We don't TD against other adapters, right? Generally speaking, XUnit and it are at the same level. I don't want to step up up one level to drive those. I don't want to drive my controllers really with XUnit. You're better off making sure those work by simply having some kind of script that drives an end-to-end test that essentially says, you know what, if I go through the controller, I can check basically everything's hooked up together. Because that's mostly what you're doing. You're checking that the HTTP or whatever gets turned into the correct call to your use case layer. And that will usually be sufficient and give you the fast feedback that you need to determine that you've hooked everything up. Writing lots of granular tests at that point may make you feel good, but it probably doesn't actually give you any useful feedback. And that can be as simple as basically, you know, curl and basically JQ driven from a bash script, to be honest with you. Okay. So let's review, but come to the end. Let's review then what we think the fallacies and the principles are. Developers write unit tests is a fallacy, right? Developers don't write unit tests, they write developer tests. The trigger for a new test is a new function, second fallacy. The trigger is effectively the next smallest step I can make towards implementing behavior. Customers write acceptance tests. No, customers define acceptance criteria and our TDD expresses those behaviors. Doesn't matter if you test first or test last, it does. You want scope and design control. And you want 100% test coverage of your code. Now you want to use TDD because where it gives you the fastest feedback on your design decisions. And you want to make sure that in your refactoring step, you don't effectively introduce new paths that are untested currently. The developers write developer tests. The trigger for any test is a new behavior. Customers write acceptance criteria. Only write production code in response to a test. And not all of your code should be driven by TDD. Great. Thank you very much.
Great stuff. Thank you, Ian. If you'd like to stop sharing. And you're back in the room. Thank you very much for that. That was excellent. Some really interesting stuff in there. We have, I think, 2 minutes for questions, and we have a couple of questions come up in Slido. So the top voted question we got is, how do you approach unit testing when you're testing a class with numerous dependencies without mocking? And does this allow for testing code in isolation?
Okay. So the first thing I'd say is, why do I have numerous dependencies, right? So really, the only reason I want to inject a dependency would be a design decision that I've got something that runtime that varies, right? So that's kind of notion of open-close principle. I want to inject this thing because I may have different expressions of it. My class is very consistent. It has kind of this engine, but you give me a policy, and I'm going to execute different policies, right? And that is essentially something that I should be checking by really just saying, hey, I want to basically express this criteria that I've got different policies I can apply, and I want to see the outcome in my contract. Right? The other option could be that effectively I want to inject it because I've got some kind of slow operation like IO, etc. And in that case, effectively, I may well have a wrap around it that I can kind of mock out. But otherwise, I'd question why I have so many dependencies in the first place. That feels like it's a speculative design decision and not one that effectively has been made by a classic kind of TDD approach, right? If it's legacy code, then try and effectively figure out whether you can write proper TDD style tests effectively and just do new in the constructor for many of those dependencies, right? New is really underrated. Use new more is what I'd say.
Great stuff. Nice simple one. Is there a blog for your presentation? Yes, I think a lot of the stuff in there is codebetter.com/Ian Cooper. We put a link to that in the chat. Any other quick resources you want to point people to for that?
No, I mean, no, not really. I probably should do a new set of blog posts now. I've done these kind of fallacies and principles, and I probably may try and do that at some point. The other thing really that I'd always recommend, just go and read Kent's book, TDD by Example, particularly if you've been practicing TDD for a while. Ken had been practicing TDD for probably, I think, about 10 years or so when he wrote that book. And it really is a book for experienced practitioners to understand. It's more like a masterclass. It's probably not a great introduction. It gets downvoted a lot on Amazon for that. But if you've been practicing TDD for a while, go and read it and be amazed at what Kent knew about TDD when he wrote that book, right? It's one that expresses clearly he had a lot of experience at the time he wrote it.
Excellent. And last question, there's a couple more which I'm sure you can follow up on Twitter. Last one we have time for. By mocking out I/O, asks Jimbo, is there a chance that a fundamental area is not being tested with a fast feedback loop? Is this supposedly covered by end-to-end tests?
Yeah, I mean, in theory, end-to-end tests cover that. Look, if it's really a concern, you have to figure out what's the fastest way to get feedback on that area of concern, right? Is basically the fastest way to get feedback, writing a test after test around that specific area. So if we look at, say, Brighter, we have unit tests around kind of most of the core engine. When we talk about transports, things like messaging middleware, they're quite often test after test, which are just confirming that behavior. They run slow. We don't run them all the time. We tend to run them basically as part of our CI/CD process, but they're very much test after kind of approaches. That's why I say use different approaches for different things.
Great stuff. Okay, thank you very much. Thank you for being part of it. We are now going to press all the magic buttons on the stream, and things are going to happen, and people are going to appear. I believe joining us now, we should have Boris from Synopsys will be on the call any second. Let me just check a couple of these details here. That's fine, that's fine. And we have Boris. Are you there? Remove that. The process of running a... Hey, how are you?
Sorry, I missed to hit the mute button.
The process of running a stream like this has been likened to you are entertaining a bunch of people who are sat in their seats watching like a one-person show, and they're not allowed to realize that you're also flying the plane and they're on a plane. So you're simultaneously, engaging with the audience and talking with the guests and everything, and clicking all the buttons and making sure nothing goes wrong. Anyway, yes, hey, Boris, how are you? And welcome to NDC Manchester.
Yeah, thank you very much. Happy to be here.
And thank you so Boris is from Synopsys, who are one of our partners, the people who help make all of this possible, and mean we can give it all away on the internet to all of you watching for free. Boris, tell us a little bit more about Synopsys. What are you doing at the moment that's exciting?
Yeah, so I'm the senior sales engineer from Synopsys, and I often get the question, what does Synopsys do? And I usually answer that we, amongst other things, help software companies also to develop secure, high-quality software fast. What does this mean? Well, as we all know, effective application security is not all about just installing tools. It's about ensuring that people, processes, and technology in all are aligned to address security risks at all stages of the application lifecycle. And Synopsys offers the most comprehensive solution portfolio for building integrity, security, and quality into your SDLC and the supply chain. And therefore, we offer solutions that help you manage security and quality risks comprehensively across your organization throughout the application lifecycle. Now, I know that this is a little bit marketing-y, but to say it simply, the shift left has been a theme for several years now, right? There we help the developers lift the weight of the secure development of their shoulders. However, by combining the benefits of developers with the security and legal personnel also, we evolved into the shift everywhere concept and created an ecosystem that helps companies to develop secure, high quality software fast. But don't let me keep you away from the great content on the NDC Manchester. Just to be sure, please visit our sponsorship page and enter our competition to win a pair of AirPods Pros.
Fantastic. Thank you, Boris. So yeah, Synopsys, that's Synopsys with two Ys, Synopsys, like Synopsys plus systems, kind of mashed together, I believe, is where it came from?
Well, it has its meaning, yeah.
So yeah, check them out. They got a booth over at expo.ndcmanchester.com. So head on over there. They are giving away a pair of... so we were talking earlier, is it AirPod Pros or AirPods Pro?
AirPods Pro.
AirPods Pro. A pair of AirPods Pro to one lucky winner. So leave your details there. We'll be drawing that later. They'll be in touch. Thank you very much for joining us, Boris. Thank you again, Synopsys, for supporting NDC Manchester. Right, I believe that we have joining us now live by internet and undersea cable and satellites and all kinds of amazing technology. We should have here on the line any second. I will now juggle some buttons. First of all, I'm going to switch back to that. So you can see me as I juggle buttons over here. There we go. We have Martin Thwaites. Let me pin Martin. Hello, Martin. How are you doing?
Manchester, where the weather is Manchester weather.
And I believe we also have joining us on the call any second now, although currently without video. Let's see. Gemma, can you hear us?
Hello.
Hello. Let's see if we can find your video. Gemma, there you are. Magic.
Surprise
right. And a surprise junior developer joining us for this part of the stream. So let's push that button. Look at this. I'm going to push all the buttons today. Fantastic. Look at that. So, Martin is, for those of you who've not met them, Martin is kind of the reason NDC Manchester exists. He's been involved in NDC events for years in all kinds of ways in London and Oslo and stuff, and is based in Manchester. And the conversation started, what was it, Martin, 2 years ago now?
I think it's probably about 3 or 4, actually, when I was banging down the door of the NDC organisers saying that Manchester is awesome and we have an awesome community, so come and do it up here. It's taken a while, and obviously last year we were going to do it live, but circumstances. It's been a long road to get it here, but yeah.
So here we are, virtually, and next year we will be there in person. Absolutely, 100%. Nothing can possibly go wrong. And Gemma, so I first met you, Gem, in NDC Oslo, I think 2 or 3 years ago. And since then, we've done a bunch of events together in and around Manchester, and you were doing and are doing all kinds of things to do with the Manchester tech scene and Hack Manchester. Tell us a little bit about all that.
Sorry, I just had my child taken away.
The handover process.
Yeah, so it was really good to come along to NDC Oslo. I was sharing some of my ideas around turning user stories into comics. It was really nice to meet all the cool people. We went on a nice trip, didn't we? on a barge looking for shrimp or eating.
Oh, the shrimp cruise. Yeah, one of the things we haven't managed to replicate.
Yeah, unfortunately, trying to do a shrimp sort of cruise around Manchester would involve going on the canal and getting some trolleys, I think, wouldn't it be, Martin?
yeah, picking those up from not going to work.
So
a couple of years ago, they tried to bring in the mobikes into Manchester, and they all ended up in the canal. So in Manchester, it was really nice to have you come and help compare the Hack Manchester award show. So Hack Manchester is a 25-hour coding competition, and I've got a little ferret running around in the background. Northern AF. We had a 25-hour coding competition because that's when the clocks go back.
It was that weekend, wasn't it? I wrote because that was we did. So Jess White and Morton Broccoli, who are also friends of DDD, they did friends of NDC. They did a DDD in Nottingham the day before. And then we did a pubconf in Nottingham, and it was like a great, just all these kind of events. You know, tech in the UK is often perceived as being very London-centric. A lot of things, everything in the UK, show business, politics, everything tends to congregate around London. But it doesn't need to be. And there are these amazing tech communities all over the country. And it was Nottingham on Saturday and then Hack Manchester happening the same weekend. That was quite by Monday, a lot of people were very tired.
Very, very tired. That weekend was epic.
So what's been going on? Obviously, one of the interesting things about the last 12 months is that geography, in theory, doesn't matter as much as it used to because a lot of stuff is online. But I'm still seeing a lot of kind of, loyalty to regional meetups and community things. How have you seen that playing out in terms of what's happening around Manchester and the events that take place up there?
So last year, about 2 weeks before the pandemic, I went off sick with burnout for about 3 months. So I was kind of off the scene, and I came back to work for 3 months, and then I went off on maternity leave, as you saw with the little tiny human that greeted us before. So I've not been going to all the events. However, in Manchester we've got a couple of really quite active Slack groups. So one is the event organisers, which I kind of look after, and there's Manchester Tech. So that's still been going quite strong, I think. And Martin, you're on that one more than me. But with the tech event organisers, we've got a calendar of events, kind of dipping into and keeping an eye on what's been going on. So XP Manchester has still been meeting up. They've been doing still monthly events all online. Northwest Ruby User Group actually had JB Rainsberger, who's over in the States, come and talk at one of their evening events not so long ago. Python Northwest has still definitely been going strong. We've got Code and Stuff, which I think is it's a really good little group that's teaching people who are interested in coding how to code with a view to them getting jobs. What else has been going on, Martin? Can you think of any other events?
There's loads of stuff, and I think the difference is within Manchester that it's such a tight-knit community. We've got there's 2 user groups or 2 Slack groups that we're talking about there, and it congregates this community, and it's very different to that. You say London-centric. The London tech scene and the Manchester tech scene are very, very different. We're incredibly close-knit. The people that go on the Manchester Tech Slack, which I advise everybody to go on to, there's lots of awesome conversations that happen on there. Yes, and I've got it up there, and that yes, we are shouting you out. Yes, but we are so different. We've got .NET North, which is the northern one, which we've got lots of things just in and around Manchester as well. It doesn't have to be just the boundaries of Manchester. We've got Liverpool, we've got Nottingham isn't too far away, we've got Sheffield, we've got Leeds, we've got Hull, we've got Sunderland. There's all those communities that sort of they are very close knit up in the north, and a lot of those have been doing the online events, and you've still got this core set of people that go to .NET North. They might go to .NET Chef and a few others because it's easy, but I am seeing that a lot of people are sticking to those kind of user groups instead of going, yeah, well, there's one off in the US that's on at I don't know, 8 o'clock in an evening, but they're still sticking with these ones that are in the northern areas, the ones that they're used to. It's very different.
For the folks on the stream who are watching who aren't familiar with the geography of the United Kingdom, if you've seen Game of Thrones, it is exactly like that. That is basically how it works. But no, it's been really interesting seeing the way, you know, these communities have almost sort of seen it as a challenge. You know, the whole geography, it was a convenient thing, but it was also kind of separated. You know, you mentioned there talking about the London tech scene. London doesn't have a tech scene. London has about 100 tech scenes, all fighting over the same venues and the same attention span and the same sponsorship budgets and those kinds of things, which, you know, makes it a really vibrant city. But I do, you know, very much get the sense with the events I've done up there, you know, you'll go to a meetup and you'll see familiar faces, even if the technology is like, oh, I didn't know you did JavaScript, or I didn't know you were interested in Python and these kinds of things. Is that something you think is going to continue happening as we do more things online?
I think what's interesting in Manchester, so as you say, with London's big, Manchester's like one of the boroughs in London. Whereas you've got, like you say, lots of competing ones. So, you know, you can walk across Manchester in about half an hour, 40 minutes, which is where you start to see people even just walking through the city. You get somebody going, "Hi, I spotted you from this user group just if you're going for your lunch." So I think that's going to continue. I think what's going to be really interesting with post-pandemic is the fact that people aren't going to be going back to the offices. I think that's happening with more and more of the companies, certainly with ours anyway. But I think people are still craving that interaction. Everybody is, you know, I've been seeing you, Dylan, desperate for going out for a pint and for going to a gig, and I'm totally with you. I'm really looking forward to even just going out to like baby groups or pushing the baby along the prom and, you know, meeting up with family.
Just being near people, you know.
Yeah, no, I think we've definitely got that. Something that I'd been contemplating running a few years ago is like going for a little walk, getting people together, going through Manchester for a little walk, and I think there's like a park bench, an agile park bench event that goes on in Manchester. I think that Emily Webber runs. Sorry, in London, that Emily Webber runs. And again, it's weather dependent and Manchester. But, you know, something like that might be really nice to start getting people out and seeing each other and giving them a reason to go back into the city centre. But I think we're still going to see face-to-face ones. The benefit that people are finding with the remote ones is for people who are, you know, got little ones or got caring responsibilities like me, and as you have as well, Martin. It's making it a lot more accessible. Actually, the scene. It's not about you having to like stay after work and get some food and, you know, not putting the kids to bed and things like that. So I think it's actually going to help the scene from my point of view, anyway.
I think it's got two things to it. So it has got this idea that, like you say, that I have children, and getting out to a meetup for 6 o'clock and not being back till 10 o'clock and all of that kind of stuff, it does wear on you over time. So, you know, I've seen a lot of, when I've been going to all the online meetups, especially around Manchester, you say that there's a core set of people going. There's also this other set of people that are from Manchester that are going to these local meetups that I've not seen before. And it's brought in a massively diverse crowd, which has been really game changing, because you don't get the people with the kids, the people with responsibilities, and it doesn't have to be, you know, young children to look after. It might be the taxi service that you run to take your kids to every one of their meets that they go to. But it's widened this community out, which I think has been really interesting. But I have still seen that these people are coming. They're not people who are coming from the southeast or people from, I don't know, Scotland or places like that are still same time zone. It's been people local to Manchester, so they've seen this Manchester meetup and go, all right, yeah, I can attend that one. And I don't know what the mindset is, but I do feel like people from Manchester and a lot of the northern towns, it's an identity thing. You know, that I am from Manchester. And I don't see the same in London, that people have that London identity.
And nobody's
people
from London.
A Mancunian identity.
Nobody's actually from here.
It's a bit like supporters of Manchester United. None of them are from Manchester. What's really funny, actually, just on that, when you see job applications coming through in Manchester, everyone's very, very careful not to say whether they're red or blue.
Because I mean, Manchester United is one of the most internationally recognisable brands. Like
So
there
City
are,
now, though.
yeah. There are, well, I think United probably. I'm not going to go there. You're not getting.
What's balls? Look at us. Look at us.
So interesting little anecdote. While me and Jacob were trying to find venues for where we might host NDC Manchester, the idea of running it at Old Trafford did come up. I've never seen an idea being dismissed so quickly, which was quite interesting. But you say about Manchester, and me and Jacob, we walked around Manchester. We walked around it in a day, very slowly, checking out loads of different venues. But we were able to check out pretty much every sizable venue within the centre of Manchester within a day. Even having lunch and some coffees in between. That's just how sort of the centre of Manchester is. But we do go a bit further. You've got Stockport, you've got going up as far as Bolton and that kind of stuff, which is still inside of this Manchester tech scene.
So I did notice
it's so tight knit.
Sorry, Jen, go on.
I was going to say, yeah. So one of my hopes for post-pandemic is that the small towns that are sort of around Manchester, which have kind of, I think they've been falling victim to what's happened around London. So everything sort of around the periphery kind of gets sucked, all the life and soul gets sucked into London. That's kind of been happening in Manchester. I'm from Preston, and Preston actually seems to be having a new revival. And I'm hoping places like Bolton, Blackburn, Ramsbottom. I don't know if you've heard of this term, but Silicon Rammy.
Silicon Rammy.
Yeah.
You heard it here first, NDC. Silicon Rammy. It's going to be the big thing.
It's been around for ages. I'm really hoping that people are able to go back into the towns. And again, if there's remote events, it means that they aren't needing to stay in, and consider the commute back and getting stuck on falling asleep on a train, which I think's happened quite often. But we've got events around, like you say, in Liverpool. We've got ones in Cheshire. So I think we've also got people who are originally from round here who will also want to kind of come to these events to have that bit of nostalgia, because Martin says everyone's really proud to be from the north in your little town, little cities.
So
if we could separate, we probably would, but we'll not go there.
One interesting thing, so Ian Cooper, who was on earlier talking about TDD, he and I sort of helped out organising the London.net group for many years now, and one of the things that we are anticipating is the traditional model, like you just said there, Martin. You go to work, and then you go to a meetup, and then you go and have some food and beers, and you end up that's your entire evening. And we're wondering, when people are not working in offices anymore, a lot of companies are going fully remote. They looked at how much they were going to have to pay for empty offices for the next 6 months and went, no, it's fine. That's it. We're remote now. So we have all these people who are working at home. And, I can't see people who have been working at home then traveling into the middle of a city to go to a meetup at 6 p.m. Because that used to be convenient when you were at work. And I'm wondering if we're going to get like satellite meetups happening where it's more geographic than it has been before. It's the people who are like, 5-10 minute journey from the venue, talking about whatever's interesting, maybe even doing it later in the evening. Work all day, put the kids to bed, have your dinner, and then you're like, well, we'll start at 8 o'clock and we'll go through until the pubs kick us out or whatever. Do you think that's something that might be happening?
It was something that it started off like that, though, didn't it? So, I remember the whole Manchester tech scene started off with Geek Up, it was called. And then we've had all the splinter groups because it became so big, and then Geek Up wasn't quite needed anymore. And I started one up in Preston. So again, Preston's about 40 minutes away from the city centre, from Manchester. But also, I think it's quite easy to get into town. Again, we call it town rather than the city. Whereas with London, it's quite it's quite an effort, and it's obviously very expensive to live there. But we've all
travelled down there. I consider it an ordeal, not effort.
Yes, they're the London. And I think we also need to remember we are still going to see a lot of people still working in the offices or in the city centre, in the co-working spaces, because not everyone's able to work from home. And I think we need to start really thinking more about that diversity of people who haven't got a spare room, or it's an ordeal, or somebody who's a bit younger, and can you imagine sharing the dining room at your parents' house? working from there. So we're still going to have a core group of people that need to have an office. Whether that's the local shopping centres that are starting to become derelict and they start to open up, so like you say, these satellite places that are outside. But I think people are still going to make a bit of a moment of it, and it could even be start doing more day events as well, so that people can make a bit of an event about it. Come into town, meet up with some people, and make it more of just a an after work bit of a social.
I think some of the conversations that I've been having have been around that value exchange, because it needs to be a very little value exchange when you're already in the city, you're already in town. I'll just go there and I'll tack on an extra 2 hours to the end of my day.
And there's pizza.
And there's pizza. So the value exchange of the quality of the talk, the amount of talks that might be there, the diversity of what those talks might be. Am I going to travel all the way into Manchester for a 1 hour talk from somebody who I can go and look at it on YouTube? There's maybe not as much there. But when we look at, say, we'll do it at 3 o'clock in the afternoon, and we'll do 2 1 hour talks in there, and it'll be some really interesting talks. Yeah, absolutely, I'm there. I'll spend the morning in the office, and then I'll do that in the afternoon, and I'll make a bit of a day of it, like Gemma says. I think there's going to be a lot of trying to work out what that value exchange is, but also how do you do some sort of hybrid events? I know me and you, Dylan, have talked quite a lot about what the sort of future of conferencing and meetups is going to be. Is there going to be this idea of, I'm going to travel into Manchester and I'm going to sit in Spaceport, or I'm going to sit in any of the.
Spaceport? Are you from 6 years ago?
What is Spaceport for the folks watching on the stream?
Spaceport was a co-working space from about 5-6 years ago. We've moved. Times have moved on, Martin.
But am I going to go in there and I'm going to sit and I'm going to watch somebody stream from America onto a projector just so I can go there and sit with some people and have some pizza? And I'm probably not. But I am going to travel there if they're going to come in and I'm going to be in person with it. And maybe we will stream those things. And I think it's going to be really interesting to see how the Manchester tech community does that, as opposed to some of the other tech communities, which are potentially more remote. You've got some of these ones where they don't have as many people as Manchester has, where we're quite dense in the amount of people that we've got in a small amount of area. The amount of companies that are landing here is also going to be quite interesting. What are they going to do if they land in Manchester? Do they consider themselves a Manchester tech business because their head office is in Manchester, but all their developers are from around the country? And it's going to be really interesting as to how it really changes how we treat meetups.
So we have a question in Slido from Neil Barnwell. Hey Neil, how you doing? Neil says, I've always thought it was the Midlands that seemed to struggle, bracket smart devs notwithstanding. It's a long way to London or Manchester for the evening. What do you think? You think we need to do NDC Midlands as well? So
so I lived in Nottingham for a while, so I actually know Jess. Well, the company she was working at, she came to at Manchester and that. And I would go to evening events. It would be a bit of a trek, but I would go to an evening event in Manchester from Nottingham. And we'd also try and get over to Birmingham. There's actually quite a good tech scene going over in Birmingham. Jesslyn Rose would be a good person for saying what's going on, but I think they've got a little group. Bristol's got loads, and that then starts going to the southwest. It depends where you mean in the Midlands. It is quite narrow though. It's just not got very good connections. So, for Manchester, we've actually got a good train that'll take you to Leeds, so you can go to an event in Leeds for the evening, or like you say, go to Liverpool. So
I think there's also a bit more of a culture around the north around driving. In London, it's, well, if I can't get the tube there or I can't get the train there in like half an hour, it doesn't exist. Whereas in Manchester, we'll quite happily drive. For me, I'm in Oldham. Shout out to the Oldham tech community, by the way. Sorry, Richard on the Manchester text, like I said, I need to. So
all right.
But we'll travel 40 minutes in the car to a meetup because there's a lot more parking and things like that, and I don't want to have to be pulled into a train and things like that. And I think that's something that doesn't exist inside of London, but does exist outside of London. Whether that is, allows us to go down to Milton Keynes, and I do keep track of .NET.
So we have David on the YouTube chat saying Midlands, try Newcastle. We got Andy on Slido saying, how about NDC Glasgow? Manchester's a bit far down south. There is clearly an appetite. Something I've often thought would be interesting would be kind of putting a small conference together and taking it on tour.
On a train. Right, I had a great idea once. Right, listen to this. We've got a really good little train that's over. It goes down the sort of East Lancashire, and it stops off, and each stop you can go to a different pub. I was like, imagine having a talk on the train, and then you get off and you go to the pub, and there's some more stuff goes on, and then you go back on the train, have another talk, and you can decide which carriage for which talk. I was like, that's such a good idea.
And because we have 5G and Starlink, we can live stream the whole thing, so that people who don't want to be on the train. One of the things we've definitely seen with NDC in the last year is we've seen people joining the online events for whom attending in person would probably never have been an option for all kinds of reasons, visas and travel and caring responsibilities and getting time off work, all these kinds of things. Which, Martin, tied in interestingly to what you said about, the future of conferences and events. So I definitely think that whatever happens, we've validated this idea that there are people out there who will tune in from home and they will participate. And, I think one of the big challenges for, us as event organizers and speakers is how do you do something so that the people who tune in on the day get more than just watching it on YouTube? So all of you out there, you can tell us how we're doing right now, because, and the folks watching this on the replay tomorrow will be like, I want to ask my questions, but I can't. So Richard says in the chat that we couldn't do a conference on a train because the tunnels would cause problems with the Wi-Fi.
Small details.
We can fix that. We just need those Pringles tube Wi-Fi repeaters at either end of the tunnel.
Imagine doing one in London to Glasgow or London to Edinburgh.
I did London.
I think one of the reasons why I was pushing for NDC Manchester is because I do believe that we need to diversify from London. We need a separate thing. One of the things I've been talking to people in the US about, because they don't really get this idea, and I think we've discussed it a few times around, you'll be able to say the term better, or is it something like a year is a long time, or
in America, 100 years is a long time, and in the UK, 100 miles is a long way.
And that's really something that being Northern myself, I do feel like that. Going to Hull, which is an hour and a half on the train, doesn't feel as far as London, which is only a half an hour further.
Yeah.
Because it just feels like there's so much more that goes with it. I'll more than happily do that, and that's why I believe that sort of Manchester sucked up quite a few different areas from Glasgow. I know it's sort of 4 hours or something. It's not exactly a short distance, but it goes as far as sort of Nottingham and potentially Milton Keynes. I don't know, but Nottingham is an hour and 20 minutes on the train, and it's a lot easier. So I wanted that idea of something that isn't London, and obviously being from Manchester, that was the only choice.
What's the famous joke that they asked people in Birmingham, what is the UK's second city, and they all said Birmingham, and they asked people in Glasgow, what's the UK's second city, they said Glasgow, they asked people in Manchester, and they said London.
Yeah,
and only one of those is right, just to but that's why I've been pushing for this idea, and it was devastating for me that we didn't get to do it in person. We had the iconic venue of Science and Industry Museum.
So let's just talk a little bit. We got a couple of minutes left. Let's say a little bit about the venue, because we were supposed to be in MOSI, the Museum of Science and Industry, which is this phenomenal venue in Manchester. Tell us a little bit about some of the events that you've organised there, Gem.
So we have Hack Manchester, or we had Hack Manchester. We decided to close that down last year because of the pandemic and things like that. It's an amazing place where you've got. I think we had Stephenson's rocket there last year, a couple of years ago. We've got Baby, the first computer in the corner. If everyone gets a Dirty Dancing joke.
They put Baby in the corner. I know, can't believe it.
I know. So we have the actual overnight event. It's part of the Science Festival as well, upstairs in the conference centre, and we have people there all night. Unfortunately, you can't walk around the museum in the middle of the night. And then we have the big after show downstairs. We say we've got Baby there. You've got there's an aeroplane. Say we had Stephenson's rocket.
Guy playing some music on the stage.
Yeah, guy plays music on stage. I have magically appearing glasses of wine. That's been a great one we've run there. But it's a fantastic venue, and the food there is brilliant. I've been to Agile Manchester there as well, and we had some people doing massages whilst you were between talks. That was amazing.
I think we'll have to have a chat with Jacob about that. That's definitely something to go on the list. But you know, we were looking at what venues we could do, and there were some options. But Manchester Science and Industry Museum is Manchester. You know, it was just when we walked in there, you could see that it wasn't just a conference venue. It personifies Manchester. It's brick walls. It's built in spite of what it is.
It's an old industrial warehouse, isn't it? So
yes, it's used to be on the old train station.
Yeah.
Which incidentally is where we were actually going to do the main conference, which was in what's called the 1830 warehouse, which is 3 floors of big beams and brick walls and low ceilings and high ceilings, and it was just when me and Jacob walked in, it was just this has to be it. This has to be where we do it.
They also have another building there that's full of airplanes. That's a nice big glass and steel structure.
And they have the astronaut experience as well, don't they? Which is a nice VR experience in there. But we're an industrial town. That's our roots, and it just personifies what we are. We're the worker bee. That's our massive the logo for us. It just like I say, it's our identity. There's national identity and there's local identity, and you know, when you speak to people who are from Manchester, that is who we are. So
I just need to press a button. Hold on a second.
One thing I didn't mention before, we said about different kinds of events. It was the Manchester Girl Geeks 100th tea party on Sunday. So I started off the Manchester Girl Geek dinners years and years ago, and it's turned into these little tea parties. And what they've been doing is they've been doing things like, it always happens at a weekend, but they've been doing like Pokemon, Pokemon Go meetups, and doing like litter picking and things like that. So that might be another thing that another direction the meetups start going in. But also around the venue, Museum of Science and Industry, beautiful places to walk. We've got Castlefield, we've got down by the canal.
We'll be there next year. NDC Manchester at Mosi, in person, with a train and massages and Starlink and Wi-Fi. It's all going to happen, probably. We guarantee to do at least one of the things on that list. Right. Thank you both very much for your time. Folks watching on YouTube are getting some reports of crackly audio. We are going to take a break. We are going to plug and unplug and reboot and bash some things with a stick and see if we can get everything fixed.
If people want to, Manchester Tech Slack, jump on there. If you're not from Manchester, we kind of accept other people. But there's that there. You know, you can go on Tech Northwest calendar to find out what events we've got. Which Gemma helps from.
Tech Events Northwest, and you'll find a calendar and a link to both the Slack groups.
Fantastic. Thank you both. We'll be back in a few minutes. We've got Irina Scurtu joining us to talk all about gRPC in .NET. Before that, here is a word from our supporters.
At iVendi, we build technology that makes it easier for dealers to sell and consumers to buy vehicles.
So what iVendi does is we build a platform that facilitates online retailing. This means that we basically make it easier for people to buy cars and for dealers to sell them. We do this from end to end, so the full journey from consumers coming to the site right through to the finance applications that go through. So to facilitate that, we have really important relationships with banks, with vehicle manufacturers and with vehicle retailers themselves. The tech stack we use is mainly AWS, and we use C#.NET as our predominant backend language, and we use a little bit of Azure as well. We deploy most of the stuff in containers using Kubernetes on EKS, and we're a big fan of event sourcing here. That helps us to separate the domains out into separate areas, which allows us to keep those domains nice and segregated, and also facilitates the auditing, which is a big part of us working in a regulated environment.
I chose iVendi mainly because of the people. They're very welcoming, they're really knowledgeable and seem really passionate about the technology and the quality of the products that they're creating.
Welcome to Margo. We're an airport-centric travel company owned by MAC, the country's largest airport group. Most importantly, we're a globally unique digital tech business based right here in Manchester. We operate as an innovation hub, a truly agile e-commerce business driven by data and the latest tech to provide airports across the world with a unique blend of products, technologies and services for their passengers. We have become synonymous with airport customer e-commerce platforms, which we're constantly evolving. If you plan to fly again in the near future, you may well use our system without realising that it's actually a Mago product. We're a business for someone who wants to create and do something a bit different. For the techies, we have a fail-fast CI/CD approach using .NET Core at the back, Vue and React at the front, and AWS cloud hosting. We expect to grow our team over the coming year, so please keep an eye on our Mago LinkedIn page for the latest jobs. Thank you.
Okay, everybody, welcome back. How are you all doing out there? We are going to be running the first of our NDC Manchester quizzes. We have a couple of small quizzes we are going to be running over the course of today to make this an event that isn't just like watching a YouTube stream while they're recording it. We want this to be interactive. We want to give away some prizes. We have a free ticket to NDC Manchester next year, which, as we've just said, we are planning and hoping will be real, and it will be at Mosi, taking place on the ground with real people in real rooms, because we miss that. The stuttering and crackling has gone. Thank you, Richard. That's amazing. Whoever's running the poll, stop running the poll. I am in control here. Don't touch that button. Thank you very much. So we are going to run through, take a couple of minutes to get some folks connected. The first prize winner is going to win a ticket to NDC Manchester. 3 runners-up are going to get a limited edition. So any of you who've been to our NDC events in previous years, the NDC hoodie is a much sought-after collector's item. There are people out there who have collected the whole set. The last year, we have not been doing NDC hoodies because of logistics with shipping and all this kind of stuff. But for Manchester, we're going to run some special edition printed just for the winners. Only ones in the world. So enter our competitions for a chance to win one of those. We'll give it another few seconds for folks to get lined up and connected and everything, and then we are going to be pitting our wits against 5 fiendish questions about computer programming. So, you all ready? Now then, there is a latency of about 3 or 4 seconds between what happens here and when you see it on YouTube. So if you are playing along on the quiz, it is vitally important that you look at the Slido screen, not at the screen that is there on the wall behind me, because that screen is going to be 4 seconds below, and you get points for faster answers. So open up Slido on your phone or get it on a web browser. That's where we need your attention. That's where the reactions are going to count. If you're just watching along at home, watch along at home. Enjoy it. Let's see who wins. So, starting the quiz. Question 1. What was the C# language originally called? Was it C++? Was it D? Was it Cool? Or was it Visual Pascal? 7, 6, 5, 4, 3, 2, 1. Let's see how we did. The correct answer was Cool. Which stood for the Common Object-Oriented Language, which was a sort of working title prototype. Anders Heilsberg, who designed Pascal, he was the designer of a lot of the stuff that was in the first version of C#. So the Visual Pascal connection is there. That wasn't the name. D is a real language, which was called D because it came after C. Now, there's an interesting... the word C, or the programming language C, came after B. And B was called B because B was a condensed version of BCPL, and BCPL was the something common programming language. I can't remember what the B stands for. But then it became CPL, which was just the common programming language, or the Cambridge programming language, or Christopher's programming language. So there's a rumor floating around on the web that the C in C stands for Christopher, which is sort of slightly true. And C++, actually the sharp in C# is 4 plus signs. C++++, and you arrange the pluses together, and that's where you get the sharp from, and in music, C# is 1 higher than C. So the correct answer is Cool, Common Object-Oriented Language, and the winner after that is Richard Pearson. Correct answer in 7 seconds. Nice going, Richard. Let's have a look at the next question. So which one of these is not a real programming language? Is it J#, F#, B#, or Q#? One of those is not a real programming language. Which one is it? I was doing, if any of you were doing the Advent of Code puzzles that they do, I did those last year, and they have a questions. Each question So no one thinks F# is not a real programming language. That's a strong show of support for F#. F# and J# and Q# are all real things. They are all real programming languages created by Microsoft. J# is not around so much anymore. J# was Microsoft's Visual, I believe it was bytecode compatible with Java at one point, and it shipped, if anyone is old enough to remember Visual Interdev. We're talking that kind of pedigree. You know, there was Visual Basic, Visual Interdev, and there was Visual J#, and then .NET came along and, of course, fixed all the problems, and now we don't have any controversy about programming languages anymore. Let's have a look at the leaderboard. Q#, of course, is the Microsoft's quantum programming language, which is extremely awesome. And B# is a band I saw in a ski resort in France about 3 or 4 years ago, who were also excellent. So if you get a chance to see the B#, check them out. Mikhail and Tom are both on the lead. Fastest answers there, 22 seconds each. Let's have a look at another question. Which programming language was created by Cynthia Solomon? Was it Perl, Logo, Haskell, or Rockstar? Let's see the live results on that. And the correct answer is, of course, Logo. Cynthia created Logo as part of an educational programming project. Logo is it's a dialect of Lisp in a lot of ways. A lot of people who've worked with Logo just remember it as being, you know, move the turtle around the screen and draw lines and things. Logo is actually a pure functional language with an awful lot of very, very cool stuff in it. Perl was invented by Larry Wall. Haskell is Simon Peyton Jones, I believe. And I think, if I'm remembering this correctly, the team who put that together are now working on Lambda support in Microsoft Excel. So if anybody ever says Excel is not a programming language, you can point out that it is a pure functional programming language with no side effects. It has a rapid evaluation loop. It has an interactive prototyping environment, and it has Lambda support created by the same people who invented Haskell. And Rockstar, there is... why would anyone invent a programming language called Rockstar? That would just mean that all the Rockstar developer ads on LinkedIn became meaningless. But I did. It's at codewithrockstar.com. You can check that out. Let's have a look at the leaderboard. Tom has sneaked into the lead. Let's have a look at... There are 5 questions in each of these quizzes, by the way. The next question: which of these languages is the oldest? Which of these languages is the oldest? Now, I just need to check my working for this one, because I had this all lined up, and then I was looking at some resources last night, and something popped up that said, maybe, perhaps, my information on this was out of date. Let me just check my notes here. This, as we said, this is the fine art of running a live show and flying the plane at the same time. And the answer is yes, there we go. The answer, by a nose, believe it or not, is Python. Python is the oldest of those languages. Python was first released in February 1991. Visual Basic was May 1991, and then JavaScript and Java were released in very rapid succession in 1995. So the oldest one of those languages is Python. There's an interesting discussion goes on sometimes about what if Python had been the language that ended up being embedded in web browsers? Because, you know, it was JavaScript is based on Scheme. Brendan developed it based on the Scheme syntax. And then the legend has it that marketing influence from Sun Microsystems did some deal with Netscape and said, no, the language has to look like Java, otherwise no one's going to do it. So we could have had Scheme and Lisp in a browser. We got JavaScript in a browser. We could have had Python in a browser. And the question I think is interesting there is actually 2 questions. One is, if Python ran in browsers, what would the browsers look like now? And 2, if Python ran in browsers, what would Python look like now? But yes, Python is the oldest one of those languages. Tom is holding on to the lead. Let's have a look at the last question in this round. According to the TIOBE March 2021 survey, which of these languages is the most popular? Go, Ruby, Rust, or Visual Basic? Mark says, do I get a prize for being last in the quiz? I think we can probably work something out. Which of these languages is most popular? It is Visual Basic. Visual Basic, for all of the excitement and community. So the Tyobe Index is based on doing massive surveys of content published on the web. And VB, when it comes to people sharing code and publishing stuff online and documentation and stuff, VB is still more popular than all of the others. Now, VB has history. You know, there is a track record here. Visual Basic has been around for a long time. People have been writing systems in it since forever, and a lot of those systems are still running. And, you know, popularity is not just about new things and greenfield projects. Popularity is about how much code is actually out there running on this thing. And yeah, VB, Visual Basic, is more popular than Go, Ruby, and Rust. Sorry, Hacker News. The statistics do not lie. And that means that at the end of that quiz, the winner is Neil Barnwell. Neil, we will be in touch by email, assuming you put the right email address into Slido there. We are going to be in touch. We are going to send you out your ticket for NDC Manchester next year. Tom, Mikhail, Douglas, Richard, we will get in touch with you to arrange some limited edition NDC Manchester hoodies. We will be doing some more quizzes over the course of the day, but right now we are going to press some buttons and we are going to switch over and we are going to welcome, live by the power of the internet, Irina Scurtu is joining us from Romania, I believe.
Yep, that's right. Hello, everyone. That's one of the things that I enjoy about being on a pandemic. We use online to travel everywhere, but I'm kind of tired of working from home and presenting at online conferences.
See, I think what... Go on, sorry.
I really love Manchester. I had a customer there and I traveled a lot to Manchester, and it's simply the best beautiful town in the whole world for me.
It is our great pleasure to welcome you to Manchester virtually. What are you talking to us about today, Irina?
So today I'm going to talk and try to convince you to use gRPC if you're not doing REST properly. I mean, we all go to and say that we implement REST APIs, but we kind of do not respect all the condition that REST has. And why not look at gRPC? It's much nicer and faster.
Okay, just going to stop you a second. It looks like we got some crackling on the audio, which suggests that one of the cables here is misbehaving. Just bear with me 1 second. I'm going to see if we can fix that up before we kick off your talk. We'll be right back in 1 second, so let me punch that one there. Oh, that's the cable. That's patching into there. That should be fine. That should be fine. That should be fine. And, okay, Irina, could you just talk to us, give us some words, and we'll see what the audio signal is coming through on the other end.
Yes, so I will try to convince you that it's a good idea to embrace gRPC in .NET. I know there was a workshop yesterday about gRPC with Mark Rendle, and I'm sure if you participated or heard about it, you'll know a lot of things about gRPC now. Yeah. But for other people that weren't part of that workshop, maybe I'm going to try to convince them. I will ask them at the end if I convince them that gRPC is good enough.
Fantastic. We are going to start. There's some folks reporting crackling audio. We are probably going to have to look at that in the next break. It is clearly some wire here that has got crossed and isn't pointing where it's supposed to be crossing. We'll try and get that fixed. But in the meantime, please put your hands together and welcome to the NDC stage, talking about embracing gRPC in .NET, Irina Scurtu.
Hello, everyone. I'm hoping that my slides are visible. So first of all, who am I? I'm from Romania, from a city called Iași. I'm a software architect at a company named Endava that is UK based. I organize a user group, I teach .NET, and I blog from time to time, but not as often as I could. And today I'm going to try to convince you that using gRPC is a very good idea, and it brings us a lot of benefits. But first of all, we cannot talk about modern technologies under our tool belt without remembering the times. I mean, the monolith times. I remember that I enjoyed working on monoliths because everything was there. It was a single code base in a single language, but I didn't care at that time about scaling. Scaling was somehow hard, not impossible, but hard and costs a lot of money. it was a bad user experience for some users, but for us as developers, I remember when I was a junior developer, I had a big solution that took a lot of time to build. And I remember that I just pressed the build keyword and I just went out and grabbed a coffee and sat with my colleagues because that long it took to build a solution. So the fact is, with the monolith, everything was there. If you needed something, you went there, you looked at the code, you instantiated some code, or if you were lucky enough to have a DI system, you injected the things there and everything worked. Like, poof, look, it works. You didn't need to worry about, I don't know, Kubernetes or microservices or whatever other services that you need to drag over in your machine in order for them to work, or in Docker. And it was very easy. You had a chunk of code that you shove it into production. And when the release came, it was all or nothing. I mean, either it worked or it didn't. If you had the single instance of the production server. So I remember coding in web forms and also in ASP.NET MVC, and everything was somehow in there. You had the front end, you had the back end, all in a single unit. And you had one database or maybe several databases. But you know, as soon as the year passed by, the paradigms are changing, and they tend also to come back from time to time. But ASP.NET MVC, front end and back end, it was so nice as an infrastructure back then when you compared it to web forms. And it was nice and an easy experience for junior developers to learn. But nowadays, I see a lot of companies and projects that are splitting that self-contained onion architecture into the front-end application and back-end application with whatever databases they use. And the front-end is usually coded by the front-end developers, React, Vue, or whatever JS framework that appears. It's taken care of. We as .NET developers, we do not care about those. We are coding APIs and we are doing microservices, and pretty much life is easier. But we need to understand that the future is distributed because the data is growing, the user demands also growing, and we need to adapt to the modern times. And when we need to process a lot of data, modern times means that you need to go distributed, or else you kind of need to spend a lot of money to scale that big chunk of code. So now the modern applications are either like this, have a front-end app that consume a lot of backends, a lot of APIs, and those APIs have databases or maybe have some other backends that they integrate with, or the other part when you have micro frontends. If you're lucky enough to work with micro frontends, somehow life is easier, but the paradigms are the same. You have front end and the back end. And nowadays, because we need to serve our business and our customers, you'll see architectures like this, not very good architectures, but you somehow need to communicate with different technologies. And you might have a .NET Core application that communicates with the Go API, Node.js, and the third-party API, and you might have a Swift app, and so on and so forth. And you need to integrate, and you need to find common ground between all these technologies. And you might say, hey, we already have a common ground. We have a common language that every technology understands, JSON for that means. We have REST for everything, right? Let's face it, when we say we have an API, we kind of tend to say that we have REST APIs. But if we dig deeper into our APIs, we might find out that REST as a concept is not there in our APIs. And we simply have JSON over HTTP or something like that. So nowadays we have clients and we have servers, and every time these two entities talk with each other, and they talk with each other a lot, there is a process that is called content negotiation that takes place. And this content negotiation happens absolutely every time when you issue a request. It's somehow behind the scenes. Web API does this for us. But content negotiation is about format of the request, what is the payload, How do you handle retries or errors? How do you handle authentication? And first, what happens if the model changes? If the client expects something from the server, then it's not sent. Or if the server expects a specific format of the request from the client side, what happens? If you have the client application and the server app in the same team or in your house, then it's easier. You go and talk with the devs and you say, hey, add this field, or hey, remove this field, or change the format or the data type. But what if you do not have something like this and you're not able to talk with the team that integrates with your backend? So the client app is developed somewhere else. And now we might say, okay, what's the point with this? What's wrong with REST? Because it works, it does the job. We have so many projects, so many apps and businesses that have REST or RESTful or REST-ish APIs. Now, I might say that the problem with the REST is that there is a constant chit chat between the teams. Okay, you'll say that we have processes, we have agile and business analysts and all kinds of jobs and tools that help us with this. But having REST APIs kind of forced us to communicate. And I'm not against communication in the teams, but sometimes that communication, it's a hustle and it makes our work very tedious because maybe we do not have modern tools to make checks, or maybe we do not have tests. And then I want you to have a short look at what a remote procedure calls might look or might be. So RPC, it's there for a long time. I think from the 60s or 70s or something like that. It's not something new, but as I already told you, some concepts tend to reappear in our lives periodically. They disappear and then reappear. So RPC, if we were to talk about a remote procedure call in its entirety as a term, I want you to look at this code. I hope it's big enough. We have an order, we have a call from a service somewhere, create order, and it's passed on a request. And then we need to interrogate the payment status, and then we check if the payment status is sorry about what happened with my words, is successful, and then we need to arrange the shipping for it. If you look at this code, it pretty much looks like it's in the same context, it's in the same app, it's service. These are services that are in the same application or belong to the same abstraction, even if they're in different bounded contexts. But if you look at this, it's very easy to see that there is no network involved. There is no network call. At least at the first glance, this is what you'll see. Okay, this is just code calls, method calls, and that's it. There is no traveling over the network to get something. And if we were to look at this specific code over the network, might look like this. So we have the payment status and the processing of the payment. It does nothing else than to call a method that lives in another system over the network somewhere. And the deal is that RPC will make the code look local. And when it does that, it will be prone to errors. For a junior developer, for example, when it starts with RPC, remote procedure calls in the code, he won't think about performance or how much data he brings over the network or passes over to the calling party. It's code there. It looks like programmatic, and they will use the methods there. So the goal of the RPC is to make network communication transparent. So pretty much it's like you have a distributed system that behaves like a monolith when you look at it. When you're in the code, it will behave like a monolith, and it won't be that obvious to you that you're doing with each method call, you're doing a network call. So what's the deal with gRPC? Okay, we understood the concept of RPC, but gRPC started in 2001 as being the Google Stubbiah project. A few years after it, gRPC has been open sourced. And then 10, 11 years After that, gRPC had its first version. And since 2019, we are enjoying working with gRPC with .NET Core. So basically, gRPC is the newer version of RPC, or the most modern implementation. And it's nothing more than a contract. It has contract-based, you'll do the contract and you'll implement the contract and you'll use that. And using gRPC will basically force you not to have code references. I've seen a lot of projects where people are trying to pass data from one service to another service by doing HTTP requests and using HTTP clients. And they usually pass those HTTP clients in NuGet packages. And the problem with that is that they tend to grow. They tend to shove logic in there. That logic is also distributed into those NuGet packages. And it tends to be like a spaghetti there with NuGet package references. But with gRPC, you'll have no code references. The only thing that you'll pass around will be that file that we're going to talk about. Another thing that is very cool about gRPC is that it's inherently faster because it uses HTTP2, so it's modern, and it has a super efficient protobuf serialization, which ends us having a smaller payload. And another cool thing is that it's available in many languages, so it will allow you to integrate with all these technologies like Go, Node.js, or C++, why not? And we'll do some code generation for you. We sometimes are lazy and we rely on code generation. So gRPC will do nothing more than to introduce something in between your client and your server. And in this context, when I'm saying client, I'm saying another server app, API. And the common ground between them is this .proto file that has a specific format. And with this format allows us to do a lot of things. For example, the proto file needs to have a look at in detail. How it looks. First of all, it's a .proto file. It's up to you how you name that. At the top, you need to say what is the syntax that you're using. Proto syntax is something specific and from Google. I will hand you over some references to that. You will define here the option, the packages that they will generate. And then you'll have to go and define. So this is the interface definition. You'll say, hey, my service is called Fibo. I'm hoping to get the mouse over to this. My service is called Fibo, and inside it, I have a method or an endpoint somehow that is called compute Fibonacci that has an input and also returns a Fibonacci result. And this is the RPC service that we're trying to expose somehow. And further down below, we have the request and the response format, which are nothing than message definitions. So in here, we're gonna have request number as being the quote unquote request of our gRPC call. And inside it, we'll have a property name, number, and of type int32. Don't be surprised that 1 is not an assignment. It's actually the order of the field in that specific message. It has the binary representation and the binary serialization. So 1, 2, 3 will be the order of your properties in there. So pretty much this is what you'll need to do in order to define like an interface in C#. You have the interface. This is the contract that you'll need to implement. So you expose this and pass this around. So gRPC as types has a lot of, let's say, ways of communicating out of the box. Some call them modes or method types, or you choose what you use, modes or method types, or there might be also other ways of naming this. So we have unary, which is pretty much the request response that we somehow know from HTTP. We have server streaming, client streaming, and bidirectional streaming. And I will take them independently and talk about each other. So unary, what means to have a unary call? Unary call in gRPC is like what we already know in HTTP, client server request response. So there is a client that issues a request, the server receives that request and sends a response. And depending on what it's expecting in the response, there will also be a status code in there, but I will show you in the demo more about this. How it looks in terms of definition in the proto file, it looks something like this. You have like what is the input and you have what is the return. And in here, it's basically a mistake. This shouldn't have been here. So you have one thing in, one thing out. This is the unary call, and that's why it's called unary. Server streaming, it's on the same principle. You have the client that issues the request, the server receives the requests, and in turn, doesn't answer with one thing. It answers with many things as response. So it's one thing in, several out. Client streaming, it's pretty much the reverse. You will have the client that issues a request. So you cannot have the server sending something to the client without previously the client issuing a communication. So the client will issue communication with several things in, and the server will process those and answer with just one thing. Okay, so many in, just one out. Bidirectional, well, it's a combination of those two. You'll have several things in and several things out. And when it comes to implementation in C#, the important things are the stream keywords that you're adding near the input fields or the return fields. So you'll have something like this. If you add stream as an input, you'll have client. So the client sends a stream of things. And if you add stream in the return part, you'll have returning a stream of things, in this case, Fibonacci result. So pretty much this is it. You'll need to create something and to expose that something using a system. So let's see a bit about code. So let me maximize this. Hoping this will be just big enough. So how do you create a gRPC project? So first of all, you go to new project, and you'll see there is already a template. It's gRPC service that when you go ahead, give it a name and so on. And if you click create and everything goes smooth, it will ask you, hey, what do you want? You want a gRPC service, and what are the frameworks that you have available? And clicking next will lead you to the project. So what you'll find is that is nothing else, nothing more than a project that has the startup CS, program CS, and the app settings JSON that we already know of. But compared to Web API, it will have no controllers or something like that. But instead, it will have a Protos folder and a services folder. In these, if we were to look at these, in the Protos part, you'll have grid photo, Proto, which is the default one. So dummy code that to get you started to help you understand what's going on in here. So the service is called Greeter, and it's unary because it doesn't have the stream in here, the keyword, or in here. So it's a simple request. And another thing that you have is the Greeter service, which is nothing else, nothing more than the implementation of that interface that you specified in the proto file. Of course, the Greeter service, or whatever service you will add in here, it can be used with dependency injection. You can inject things in there like loggers or contexts or repositories or whatever you need. But in the actual functionality part of the service, you'll have these with the name that is specified in the proto file. So the logic that you add in here, it's up to you. You'll see I have very simple examples, but the most important part that I want you to have a look at is this greeter base. This greeter base, if we were to inspect it, it's something that is very strange and it's code generated. We didn't do pretty much anything to implement this. It just exposes some definitions. You see these are hello request, hello reply, the messages that we're specifying in the proto files, and methods names and so on. You do not need to look at those because every other aspect of the project you already know. If you work with Web API and .NET or ASP MVC core, you'll know how to handle things because you'll have the middleware already added for you, and the rest is it's kind of history we are familiar with. But let's have a look at some actual code. So a closed Visual Studio, yay. So I will need to open it again. We will play in the console pretty much, but I will show you code if my computer decides to actually load the solution. So what I have in here, I'm going to zoom it a little bit. Come on, zoom a bit. Okay, so what I have in here is a suite of console apps. I have the unary part, I have the server streaming, client streaming, and the bidirectional. These are nothing more than console apps. And I have the server that implements the gRPC part, and the console apps will be the clients. So let's have a look at the server. And first of all, I'm going to show you the Protos file, because it's only one in this case. Okay, open. I hope I'm not lucky enough to have my computer crash right now. Okay, so using the same approach, I have the greeter service. I have the same hello request that is default in there, is the unary one. But what you'll see is the other three methods implemented. Server stream with the hello request will return a stream of hello reply. Client stream streams several things in hello requests, and it'll get one thing back. Bidirectional, adding the stream keyword near the input and near the return part. Here, nothing fancy. It's a name, it's a message as a property. But in the service part, I want you to show you line by line. The say hello you're already familiar with. I'm receiving something in. So the deal is like, okay, you have those methods that you're defining in the RPC service, the proto file. And then when you go ahead and implement them, you'll have one parameter that is already known and exposed by you. But the second parameter is mandatory, and it will be the server call context. And the server call context is very similar to HTTP context that we already know from classical HTTP web API. This will allow you to extract things from the call and from the context, just exactly as we used to in web API. So if you want to extract something from the context, this is your go-to place. You have the context in there and you can extract things from there. Another thing, for example, in the server stream, I'm going to expand this is when the server streams, it means that it receives one thing. So it receives the hello request, and then you have two additional parameters. You have the server stream writer that will represent the response stream that it will be sent back, and also the context parameter. This you cannot get rid of. It's very important. And in terms of actual demo, what I will show you is that a simple I have a for loop that goes from 0 to a specific number, and it does nothing more than either to send the replies, either to send and receive input somehow. And on the server side, this is the implementation, right? And I'm going to go ahead and show you the Unary part. That is the console app. And I'm going to tell you that this console app has no reference to the server app, as you would do with HTTP clients. You have a reference or pass along a NuGet package. And if you do not believe me, I'm going to show you this. So under the packages, you'll see the gRPC and the protobuf and the gRPC tools, which are needed. But that's it. No other reference to no other project in here. And what you'll do in order to instantiate and call the gRPC server, it will be to create a channel, because this is how it works. First, you have the concept of the channel, where you pass the address, pretty much of the server that it lives there. And then you will have some credential related stuff. But I do not want to add any authentication in here. And I added this channel credentials insecure. After that, you'll have available a greeter client that is already there for you, and you'll pass on the channel. And so far, this is very familiar. HTTP clients, if you ever work with them, it's pretty much the same. And what will happen is that you will need to instantiate a request, and that request comes from the proto file. And what you'll do is just call the method. Client, say hello, pass on the request. And if you have options to pass along with that call, you'll instantiate that and add it in here. So say hello. There is no reference to the server or any package that contains the actual implementation. What happens is that you know the where, you know where to call, and also you have the proto file that is available to you in the project. This is very important. If you look at the project file, you'll see that there is a specific thing added in here. So I added an item group that points to the grid proto file. So the proto file is the common ground between my server and my client app, the Unary console app. And in here, this is location that is accessible at the project level, and that proto file maybe can be passed through a CI/CD mechanism or so on. But you need to make sure that you have access to this, because that is your way of sharing data and sharing the contract. And what I also specified in here is that this is a client. So gRPC services, this is a client. So it behaves like a client. On the other way around, on the server side, if we were to edit the project file, we'll have somehow similar thing, an item group, but this time gRPC services has the server as value of the gRPC services property. So this is the major difference between the two. And the grid proto is accessible because it is in the same folder. Also, you'll need to make sure that you copy the proto file when you deploy or something like that. So I have in here like this. In the left-hand side, you'll have the server that's gonna wait and it's gonna run. We're gonna start this over. It's gonna build a bit. And on the right-hand side, we're gonna have the Unary part. And what you'll see in here is that it's simply an app that listens on a specific port that I overridden. And the Unary part will issue calls, one call, and we'll get something back. And what it sent. So in the request, it sent NDC Manchester. The call was received here on the server side. You'll see that there is an application gRPC MIME type, and it took that many milliseconds. And the request type is post over HTTP2. So request was received, and in turn, we received a hello NDC Manchester as a response. So this is a classic way, hello request response. Okay, we're gonna leave the server running, and I'm gonna show you the client streaming part. Let's see, client streaming. Okay, the server listen, it's up. remember that it's still an endpoint. It still needs to be up in order for it to receive calls. As on the left-hand side, you see a lot of things getting in that are coming from the client, and the client sends stuff. What's the number? Oh, okay. And in return, as a response, it got that number because that's the max value for my I that I added the loop for. So what it called is another method called greeter client stream, and it took that many milliseconds. So this is, imagine how cool it is to upload images or, I don't know, big chunks of data, into splitting it into separate things and just getting a confirmation back. Hey, I got all your chunks of data for upload, for example. Server streaming, it's somehow similar because it will send one thing, but we'll get a lot of things back. So you have a smaller number as an I value, hello 9099, okay? But on the server side, it's one thing that got in. Instead, for the client, the server part, it was streamed a lot of things. And also, I will show you that there is no concept of like headers, as we know, but we have something that is called trailers that we can mimic headers with. And the last part is the bidirectional one. Okay, so I'm gonna run this bidirectional. What happened is on the server side, we're seeing like just one thing in, and on the client part, you see it sent 9 things, 10 things, in fact, and received back the same 10 things. So it's bidirectional. But you need to keep in mind that the client needs to initiate the communication. You cannot, like a signaler, you cannot just push something to the client without the client ever wanting that. So let's have a look a bit on the project part. So Unary is very simple request response, but on the server streaming, somehow things are getting complicated maybe. So the same things, you have the channel, you create the client, and then use that client to call the method that you expose. You'll have one request in, and then you're gonna await for each reply. So when you're replying, you'll read from the response stream because those are the many things that you need to read. And then you need to write those into the console or whatever you need to do. And another thing that I want to show you is that you have the possibility of using a parameter that is called deadline. I mean, if you do not get a response in a specific time or something like that, you just say, hey, this timed out. You cannot wait anymore. So you add the parameter deadline and you specify milliseconds or cancellation token or whatever, but you'll be able to like abort that. Okay, trailers, get trailers. It's a method that is already there. The trailer part is a dictionary that you'll be able to add with your replies and requests. So you have no header, the traditional one to add, but you can add my value pairs in there in order to help you, I don't know, distinguish different things. Okay, let's see. In the client streaming, is the other way around. You have your client stream, and then you write in the request stream. So you send many things in, and you wait for it to complete, and then you wait the one response that you know that you'll get back. Another thing that is worth mentioning is that you can work with exceptions in RPC, but that those exceptions will be RPC exceptions, and you'll be able to filter them by status codes, but that status code, it's not the same as HTTP status codes. These are more related to RPC. And you'll see here, if I will be able to zoom in, and I'm not. So you'll see aborted, already exists, canceled, data lost, and so on, which are specific to gRPC, and that's it, not the traditional that we know from HTTP. So you'll be able to distinguish different things by using specific status codes. And bidirectional, it's a combination of those two. Okay, so you open the channel communication, and then you will write into the response stream, and then read into the request stream. And the same, you can catch exception and filter them by specific status codes that are gRPC related. Okay, what I also wanted to show you is the trailer part. So the trailer, or the fake headers, basically, are nothing else than metadata that comes along with the request, the gRPC call. It's of type metadata entry, and you add just value, a key and value, and it's up to you what you add in here. And you add it in the context, because the context is the one that knows a lot of things about the calls, and you simply can add it in there. But it's not the traditional way of using headers as we know in HTTP API. And coming back to the slides, gRPC has a lot of strengths, and we need to look at this. I know that it's a comparison with REST and not with WCF, as it usually does. REST is resource focused, and RPC is action-based. It's more programmatic. And also, being more programmatic, it embraces its semantic. And also, in REST, we tend to have loose coupling, as much as loose coupling that we can have. In RPC, you definitely have a tighter coupling. You have that proto file, and with that proto file, you are coupling your application. And in terms of serializations, one is text-based and one is binary-based. So right now, having the gRPC stub, it will just allow you to have different technologies, because gRPC is universal. When it comes to performance, gRPC is like 80% and something smaller than the rest response. This is on an example that I had. It's a lot of improvement in here. And as developers, we need to take care of our users and the data that we're passing over the network. And it's very fast and it's super performant. Polyglot environments, if you have such a scenario in your business, it's very suitable for it. It's super lightweight and it's easy to work with as long as you get to know it. It's super, super useful for point-to-point communication. So I would advise you to try it when you have HTTP clients. Go ahead and use gRPC because it's much easier and much faster. Being contract-based, having smaller payloads, and using HTTP2 out of the box, and also supporting different streaming types, I think is very powerful because it can allow you it can open a lot of worlds for you. But also we need to mention a few downsides. You'll have temporal coupling. It's not like in messaging. You'll have the need of the systems both to be up. Maybe it's not obvious, but if you need to call a server, that server needs to be up in order to respond to your gRPC calls. Also, because it's so programmatic and it's so cool as an approach, as in programmatic style, you might forget that there's a network involved and the data and the calls that you're making are traveling over the network. And another downside is that the payload is not human readable and you cannot like just use Postman and look at what you get back and understand what's wrong. You need to use different tools, and also you'll need to do better testing because better testing will prevent you from doing mistakes in terms of what you add in the payloads and so on. Also, it will force you to focus on CI/CD or on a mechanism that you'll automate your sharing of the proto files. You cannot copy those by hand on the server. You need to make sure that the proto file, that is the contract, is available to the apps that are using it. And in summary, it has 4 modes, decouples code, because decouples code in terms of not having so many nugget packages to share and to reference, and it's a good part. But also having another tool in our tool belt makes us think about the future of web APIs. If it's programmatic, there will be no more hunting for documentation. There will be no swaggers and everything to understand how an API works. You will just have to look at the proto file and look at the code to understand things. And there also will be no misinterpretation of status codes. We have 63 of them. And I bet we kind of use, I don't know, maybe 10 or, okay, 7 of them. And also using the proto files, there will be no more data parse errors if you do not have testing, and take care of those. When the contract changes, all the other apps that are using the proto files are forced to change. And this way the errors are minimized. So we need to bear in mind that distributed systems are about trade-offs. And even if we have all kinds of modern tools in our tool belt, we need to pick right and pick the right ones for business and for our project, not just pick the most modern ones, because maybe the most modern ones, it's not suitable for you. As next steps, I would strongly suggest you to have a look at gRPC Web. It works like a charm with Blazor also. And it's 1 year since it is very stable. HTTP 2, it has a lot of differences compared to HTTP 1. It's way faster and the data transmission is way different, and you also need to have a look at that. And if you're interested in protocol buffers and the syntax and the types that they're exposing, have a look at developers.google.com. And if you love gRPC, if you love curl, there is a gRPC curl, and you'll be able to do curl requests for gRPC. And also, Mike Rendle's book, gRPC for WCF developers. If you need to dig deeper into gRPC, you'll find it very useful. I know that I did, and I know that the comparison is usually with WCF, but I want people to have a look at their APIs and to understand that, hey, if I'm not doing REST properly, maybe gRPC is a solution for me. So thanks for listening and for being here.
Hey, Irina, thank you. Right, we're just trying out some slightly different audio, folks, on the stream. While Irina was espousing the benefits of gRPC, I've rewired a couple of things. You should now have 2 people talking and no crackling. We may have the technology. Irina, that was excellent. And gRPC is such an exciting technology, particularly the, being able to plug different languages and platforms into one another and do all that kind of stuff. We have a couple of questions have come through in Slido while you were talking there. So we've got, let me just take a little look over here and see what we got here. So top voted one is, actually top voted one was from me, but I'm going to ask my own question because it got voted up. When you talk about the message structure where you have to put the positions of the elements, what happens if you remove something? What happens to the numbers?
Oh, if you want, I might say bad things right now, but it's very easy to make it backwards compatible and forward compatible, gRPC, but there is a lot of theory around that, and that's why I advise Mike Rendle's book.
Okay.
There, he talks about that in there, it's supposedly, I've never done it in production yet, but if you remove that, I think it will break. So you have 2, 3, and you skip a number. I bet it will break.
Any question where the answer is read Mark Rendle's book? That's a pretty good answer.
Yeah,
we'll
right?
go with that. So Dan asks, does gRPC typically replace REST in an existing system, or can it be used in tandem with existing REST requests?
It can be used in tandem with REST requests, but what I'm trying to advise people is that if you're not doing REST properly and maybe REST is not suitable for you, maybe gRPC is, and you can have a look and try it. It can work in parallel, I mean, system to system, for sure, gRPC can work. REST should be like more for public-facing APIs. This is public, this is the client app, and that's it. But API to API, cool, it would work like a charm.
So gRPC, would you say that's a good idea? If you control both ends of the pipe, then it's a good idea. But if the client is somebody else's software, somebody else's company, then REST is better for supporting public APIs because of
yeah.
And that actually ties on to another question about security and authentication. What are the options in gRPC for securing and authenticating your APIs?
I don't know how to answer to this because I haven't looked at it. I know it has, but yet again, the book, it has a section. It has a section in it. I was playing more with it because I really found that is beneficial. I mean, okay, you have client app, JavaScript apps, and an API. REST is good. I mean, REST won't disappear, but server-to-server calls, I think it can be replaced. You have pretty much no reason to do, I don't know, REST.
Excellent.
Cool.
Vincent says, could you replace a server-to-client signal R stream with a gRPC stream?
It depends. Not necessarily. Because in gRPC, the client is the one that usually initiates the request. I mean, you cannot say, hey, whatever the clients are connected to me, just here's the message, like you do in SignalR. In gRPC, you need those clients to contact you first, and then you'll be able to reply to them.
Cool, thank you. Chris says, can you keep connections open using bidirectional to get periodic information like progress on long-running tasks?
That's very good. Yes, you can keep the connection open, but I don't really know for how long. I will try this after the call because it's very it never crossed my mind.
And Dan says, when you're streaming in gRPC with multiple requests made from either server or client, does it leverage network sockets or are they individual requests? Similar kind of question, I guess, about keeping connections open.
Yeah, so it doesn't work. It uses HTTP2, and because of how HTTP2 is done, it's one request.
Cool. All right. Just noting, we got a couple of comments on the audio. So Milos says mixing two streams. We'll fix that up. There's a whole bunch of different mics, and there were isolated audio systems. We switched to a different one. If it's still crackling, I genuinely have no idea why it would be doing that. But let's keep going. So we've answered that one. Do you have any development or production examples on how proto files are shared or could be shared between applications?
Oh, that's a very good question. Maybe with, I don't know, the simplest thing that I can think about is just copying when deploying, you know? And with CI/CD adding a different step in your team city build or something like that. You just need to take that file and to make sure it's near the client, the server app that you're using.
All right.
Proto files are there for a long period. It weren't for .NET, but they're there.
I noticed you said gRPC was open sourced in 2004 and then in 2015 or something. So it's like 11 years between open source and actually going, no, we think 1.0 now. You think this is fine? Final question. gRPC uses less bandwidth than JSON, but what about latency? Would you also expect a lower latency?
Not necessarily. I don't think the network latency has a lot of things to do with how many data you are transporting. It's just network. Yeah. So you just need to bear in mind that if you transport a lot of data, the network latency might be there, but if you transport a small piece of data, also the network latency might be there. So it's about consuming the customer's data. Yeah. Imagine what happens if you are in the US on a mobile network.
Presumably also, a consideration there is if you need something to happen quickly, is the data format you're using optimized for being able to do that?
Yeah. Exactly.
You know, zero latency or very, very low latency is no good if you're sending 100 megabyte payload files. Those kinds of things. So, we have one more question, which is Dennis. I mentioned that I've seen a previous presentation where you mentioned messaging is ideal for microservice communication. Where would you use one over the other? So I guess this is a messaging versus gRPC question.
Yeah. In a lot of technologies that we're currently seeing or developing with, we're seeing the versus part. It shouldn't be like versus, it should be like more case by case approach. And we know that we have all these tools. We need to pick the right tool for the job. I mean, in some cases, gRPC might work better even than HTTP client calls, classical requests. But in bigger apps, go to messaging, because the messaging part, it comes with a lot of benefits, not one or the other. It's taking and improving the architecture step by step. I mean, okay, HTTP clients, replace them maybe with gRPC, and as next step, maybe go to messaging, but do it gradually.
Cool. We have, I think, a question and then an answer. So Hachi said in the YouTube chat, how many client connections gRPC can handle? And Dustin said, depends on your web server stack. Otherwise, it's just normal HTTP2. Would you agree with that? Is that...
Versus Go? I do not know.
No, I think the Go question is a different question. Yeah, compare performance-wise. You got any experience comparing gRPC and .NET to Go?
No. I know Kestrel is very, very nice.
I mean, sorry, go on.
Go ahead. And the Tech Empower benchmarks and the latest ones, I think, yet again, .NET is up and running with Kestrel on serialization and text and everything.
What I'd say to that is it's so easy to build clients in .NET and in Go just by running the protocol buffer compiler. Try it for yourself. Try it out.
Yep.
See what happens, and then you don't have to take anyone's word for it. So, okay, we are going to bring on our next speaker. Thank you very much, Irina, for being part of NDC Manchester. Up next, in a few minutes, we are going to have Steve Sanderson is joining us to talk about Blazor. Let me just click the buttons and change the layouts. And hello, Steve. Can you hear us?
Yes, I can hear you.
Magic, and we can hear you, which is always a very promising sign. How are you doing?
I'm very good, thank you. How are you?
Yeah, all right. We've been juggling technology and streams and quizzes and talks and prizes and generally having the most fun you can have on a live YouTube stream. So
Sounds great.
So you're talking to us about Blazor today, I believe.
I am, yes. It's the thing that I've been mostly talking about for quite some time now. Yes, a lot of people seem to be interested in this, and there's lots of cool stuff to say, so yeah.
And Blazor's something you were kind of instrumental in making it happen, I believe, as well.
Yeah, that's right. Way back in 2017 or something, I think it was, it did come out of a demo for an NDC talk way back then. And
is it true that it was, I wonder if I can compile C# to WebAssembly, and it sort of snowballed from there a little bit?
That's absolutely it. Yeah. Well, I mean, I could see that WebAssembly was looming on the horizon as a significant force in the way that web development would evolve. And so I, of course, as a .NET developer, very much wanted .NET to be part of that from the beginning. And so, yeah, we were able to be one of the first to build a really substantial application stack on WebAssembly.
Fantastic. We have a couple of minutes before the scheduled time. What else have you been working on recently? What's interesting that's happening in your world now we all have all this time on our hands?
Oh yeah, loads of time. Yeah. No, I've mostly been working on ASP.NET stuff for quite some time. So there's lots of new features that come into Blazor in .NET 6 that I've been involved in doing lots of prototypes and designs for. There's also a demand from developers to be able to target native applications as well. So I've been looking at ways that we can extend the UI rendering to Windows and Mac and maybe to iOS and Android as well, with a variety of different rendering mechanisms. So yeah, those have been my main work focuses lately. And hopefully I'll be able to show some of that stuff in the talk.
Fantastic.
Just today.
All right. Well, we're a little ahead of schedule, but it's YouTube. We're live. People who miss it can watch it back tomorrow. Let's get started. We will, if you want to start sharing your screen, we'll switch the preset across, which I believe will also clean up the audio. It looks like it's just this one camera angle, which is causing the chop. Why that's happening, I have no idea, but it will go away in a second. So let's put the focus on you. Welcome to NDC Manchester, Blazor in 2021, Steve Sanderson.
Thank you. All right then. So yeah, let's kick this thing off. So if anybody, for anybody who didn't see the intro just now, and if you're joining us, my name is Steve, and I do work at Microsoft. I'm on the ASP.NET team, and I have a particular focus on Blazor. I have done for the last few years, and that's what I'll be talking to you about today. Now, I know that many of the people who are watching this will already know in some detail what Blazor is. And good news for you is this talk is not an absolute beginner's talk. I'm going to largely assume that most of the viewers know some of the basic ideas of what Blazor is, and we'll focus more on what's coming next and more advanced things. But just for anyone who's absolutely new to this, you should probably watch a different video. But hey, Blazor is a UI framework for .NET that mainly targets web-based rendering. So it allows you to build the kind of rich, interactive UIs that you would historically have built with a JavaScript framework like React or Angular, and allows you to write that with .NET code. And it follows a similar sort of component-oriented programming model that is common in most web application development these days. And we'll be looking at some of the code that illustrates that later in this talk. But the main focus of this talk is not to introduce those basic concepts. It's to tell you about the overall state of where we are with Blazor on .NET 5 and where we're going in .NET 6. I'll be demonstrating some features that we will be shipping in .NET 6. Some of them are quite early prototypes, and I'll show you some cool stuff that you can do on .NET 5 as well. So the overall state for Blazor is that things are going very well as a technology, as a project. Blazor is one of the fastest growing parts of .NET at the moment. And we've got a large community that's given us lots of feedback. And it's that feedback that's largely guiding our plans for .NET 6. So most of the stuff I'm going to show you today is stuff that's directly come out of things that people have requested. So let's have a look at some of those things. Now I'm going to start by turning off my video just because I want to maximize the performance of my machine here to make sure these demos go better. And let's think about what's going to be in this talk. So as I've mentioned, I will be talking about some of the things that you can do in Blazor on .NET 5 already, some of the slightly more advanced things that not everybody knows about. But another major focus will be talking about things that are in the pipeline for .NET 6. And like I said, some of those will be just prototypes. And in fact, we will start with one of those things just now. So the first thing I want to be able to demonstrate to you is a feature of .NET 6 called Hot Reload. And this is something that developers have asked us for a lot, and we are very excited to be able to include. So you may know this from other technology stacks. The idea is that this is about making your developer experience more pleasant and more fluid. The idea is that when you make changes to your application and you save those changes, you just want to see them show up in your browser straight away. You don't want to wait to recompile your application. You don't want to Alt-Tab to the browser. You don't want to reload the page. You don't want to do any of that stuff. You just want your changes to show up by some magic. And that is something that we put a huge amount of work in for .NET 6. And this is not specific to Blazor. This is a general .NET 6 feature that will target various different UI stacks. But the Blazor team has been very heavily involved in designing how this should work to make sure that it works really well with Blazor. And I'm going to show you that just now. But just to warn you, what I'm showing you is not the real implementation. It's actually going to be a prototype. And the prototype will almost certainly crash, probably several times. And when that happens, we'll just not worry about it. We'll pretend it didn't happen and carry on. But the good news is that the real implementation for Hot Reload is really close to being ready to show to our community. It's just not quite ready enough for me to show you today. So we will use the prototype and it's going to crash probably. All right, so let's have a look at this. And I'm going to show you this in the context of two different applications. The first one may be a little boring if you know .NET, if you know Blazor already. Excuse me. But just for anyone who's totally new to Blazor, this is the thing that happens when you create a new Blazor project. You get this standard starting point application that you see over here on the right. It's a kind of dashboard kind of application. It's got a few different pages. It's got this page with a counter that counts how many times you click a button, and it's got this page that demonstrates how you can fetch some data from a database or a backend server and render it in your page. Okay, so that's pretty familiar if you've seen any Blazor stuff before. I will show you a different application in a few minutes, but let's just start with this one. So let's see some of the code that's in there. We'll start with this index component, because like I said, Blazor is a way of writing your rich application UI with .NET code rather than having to use JavaScript for everything. And so actually probably a better example would be this counter component here. Remember, it counts the number of times you click, and it does that by having a mixture of some HTML markup and some C# logic here. So the C# logic is just incrementing a variable every time you click, and then that gets rendered into the UI. So pretty simple stuff. The homepage here, index, is another example of that. Now, let's have a go at editing this, and we'll see if the hot reload thing does something good. So let's change this to NDC Manchester, okay? And I'm going to hit the save button up here in the IDE. And because of hot reload, I did not have to recompile my application, didn't have to switch back to my browser. It just showed up in the browser within about a second. So I'm going to hit save again on that, and you'll see it just shows up, and that's pretty nice. Now, I'm not limited to making changes to HTML markup. I can change other things too. For example, I will change this parameter that I'm passing to a Blazor component like that. And when I save that, you'll see that will, of course, just show up. And I can do more advanced things still. So let's say I want to add a new component to this page. You'll remember the counter that I had earlier. I can use that as a component like this, and I'm going to hit save now. And that will just pop up into my UI straight away. And it's not just static markup, it's the real live thing. So I can click that, and the count actually increases. And here's the best bit. Watch what happens when I add another counter to the page. I'm going to hit save on that now. And of course, another counter shows up. But the important thing is we didn't lose the state in the first counter. This in-memory state is retained. We're not throwing away your application and restarting it. We're patching your changes into the existing running application while it's there, so that they just apply while you're coding without you losing the state. And that's really valuable and powerful for reasons that you will see later in this talk. And also, we're not limited to just making changes to a single file. I could switch over to this counter component here and start changing some stuff here. So let's change some markup. I'm going to put another copy of the current count, just because I can, not for any good reason really. I'll hit save on that, and of course that's going to show up and it will start working in the way you expect. I could also make changes to the procedural logic that I've got inside my code block here. So let's say I want it to go up by units of 100 instead of just 1. Okay, so now next time I click this button, you'll see that, did I save that? It will increase by hundreds instead of single units like that. Again, retaining the state of the application that we had. Okay, so that's working very nicely. You might be thinking, okay, that's good as long as all the code that you enter is valid. What happens when I make a mistake? I'm just going to lose everything, presumably. Well, let's see what happens. I'm going to deliberately introduce a mistake into my code. Let's say I didn't realize what this variable is actually called, and I think it's called count, even though it's not. It's called current count. So what happens when I hit save on that invalid code now? Well, what happens is I get a nice little message just showing up in the browser, telling me what the problem is, exactly which line and column it is. And of course, that's consistent with what the IDE is telling me, with the red squigglies in the same place. So I can then fix my code and hit save, and the error will go away, and my application is still running. It's been running the whole time. We didn't lose any state. It's still there even when I make mistakes and correct them. So that is pretty nice as a developer experience. Now, there are some kind of changes that we can't patch into the live application. And so we have a certain bit of fallback logic that occurs in that case. So with the prototype, one type of change that I can't make is class initializers like this. So if I hit save on that, the prototype doesn't know how to patch that in. So you see the screen has been grayed out. It's doing a fast rebuild, and then it's going to restart my application automatically. So you'll see that the change has been applied, but we did lose the state on this occasion. So this particular limitation and not being able to make this change is actually a specific limitation of the prototype. The real thing can make that change. But even with the real thing, there are certain types of changes that can't be patched in. And in those cases, we'll go through this fast app restart process. Okay, so that is the beginnings of hot reload support. But like I said, I want to show you this in the context of a more interesting application, because I know that many people have seen this boring project template like a million times by now, and you're probably, well, if you're still awake, well done. We will switch over to a more interesting application just now. So let me show you what I want the end result of this application to be, and then we will build some parts of it step by step. So this is the end point, the kind of one I prepared earlier target here, which I'm just going to bring up in this separate little window. It's called Blazor Recording Studios, and you see that it's a kind of booking application for a fictional recording studio. So we can see which artists are booked in on which day, and the idea is that something like a receptionist would use this, so they can see who's booked in, and when people phone up to book a slot, they can add a new entry in, or they can edit the existing entries. So for example, they can click on an entry, they can delete stuff, and you'll see we've got validation, and they can even do nice things like drag and drop, so they can just move around the bookings like that. Okay, so that's what we want to build, but we haven't got that yet, or we'll pretend that we haven't got it, and we will build some of that, making use of some of the hot reload functionality. So the starting point we'll take is what we've got here, where it just says to do. We've got a header, but we haven't really got anything else. So let's start adding some stuff into our application. And I'm going to do the rest of the demos in VS Code. So I did the first demo in Visual Studio, and you saw that hot reload worked really well there. And I want you to see that the experience is also very good in VS Code. Now, like I said, I'm sure that it's going to crash many times, but we just won't worry about that. Okay, so let's make sense of what the code of this application looks like. I want to start by showing you the main layout here. You can see that the main layout of the application is it's got a header bar component at the top, which has got the title and the buttons and so on, and then it's got a body, and the contents of the body varies according to which page you're on. So if I switch onto the about page, I get a different contents, and if I come back, I get this to-do message again. And the main page here is what comes from a file called index.razor, or actually I think I called it main, what did I call it? Completely forgotten. Let's have a look at my pages. Oh, it's called home.razor. Okay, great. So here's my home page. All right. And you can see the contents of that should hopefully look recognizable down here. It's just HTML, and it's got that message in it. I've also got this stuff up at the top where I'm displaying this date picker button. That's this little thing here, but don't worry about that for now. We'll come back to that later. First, let's just check that our hot reload is working correctly. So if I change this text, then hopefully that's going to just show up straight away in my browser as I do it. So I want to build that list of bookings grids. Do you remember what I just showed you a minute ago? We've got that long list of dates, and for each one, we'll display the bookings that are on that date. And I'm going to do that using a for each loop. So I'm going to say for each date in, no, var date in dates. Okay, so the dates is an array that I've set up here of the next 200 dates starting from today. Okay, so we're going to loop over the next 200 dates, and I'm just going to start by printing out the current date. So assuming that hot reload works, then that's just going to drop all this hideous stuff into the UI there. It's hard to make sense of. So let's put a paragraph tag in so we can see that a little bit more clearly. All right, so we've got our list of dates in there, okay? And now I can use usual C# code to change how that looks. Oh, I've killed the IntelliSense, so I'm just going to bring that back up. Right, so let's have to long date string. Okay, hit save on that, and we'll get the dates coming up. Very good. But I don't just want to display the names of the dates. I want to display a grid that contains all of the bookings. And I've actually started creating a component for that already, which is called bookings grid. Okay, so let's just put in a copy of that right there. So when I save that, my prototype crashes, which is not surprising. I warned you that this was going to happen. So I'm just going to restart it. And then hopefully we will be able to make slightly better progress. So I apologize for this, and you can just trust me that the real implementation is not just going to crash every 2 minutes like it probably will in this demo. Okay, so when that comes back up, hopefully we'll see the bookings grid being displayed. Come on back. I know you're there. Okay, it's back. All right. So you can see that for every single one, it's just saying January the 1st, and that is because I haven't passed the date into it yet. So we'll say we'll pass the current date as a parameter into the bookings grid, and then all being well, that is going to update in the UI when the hot reload thing finally wakes up. There we go. All right. So it's now passing a separate date into each instance. And in fact, while we're here, I'm just going to pass the other parameters that I need to pass into my bookings grid. So I'm passing a list of rooms that you can book, which I fetch from a database, and a callback that can occur when you make an edit. Okay, so now let's go and have a look at the contents of this bookings grid. So another cool thing that you might not know, if you hover and do a control click on a tag name, it will take you directly to that particular component. And you can see that the contents of my bookings grid are basically, we're just displaying the current date. So that's what's there. And I could add more stuff to that like that. And then hopefully that little message is going to start showing up in the UI. And it does. Okay. So let's now display a list of the dates and of the times and slots that are available for booking on a given date. And of course, you don't want to wait for me to type this stuff out. So I am just going to put in the initial bookings grid like this. All right, so I'm looping over all the rooms that are available for booking. And for each one of them, once again, it's crashed. We won't worry about it. For each one of them, we are going to display the name of the room that you can book, and then underneath that we're going to display the rows for each of the things for each of the bookings. Okay, so just so that we don't have to keep waiting for this to restart each time it crashes, I'm going to perhaps skip this little bit ahead slightly, and I'm going to just quickly drop in all of the code that's going to display for each of the days. So you can see we're displaying the rooms that are available for booking, and then underneath that we're going to have a loop over all the hours that are available, and we'll display the name of the hour. So let's see what's going on here. And hopefully that will update. Maybe I shouldn't be demonstrating prototype stuff this early. It's not going super well right now. I'm just going to drop in a bit more code that finishes this section of the demo off so that we can move on to some bit that won't continually fail like this. So what I'm doing now is I'm saying that for each of the rooms, I'm going to find any bookings that are available in that room, and then I'm going to display all the slots that are available and the bookings that are in there. I'm just going to restart this because I'm tired of waiting for this to fail. Okay. All right, so hopefully this makes sense to you. We're looping over all of the hours, and for each hour we'll loop over all the rooms, and then within that we'll find any bookings that are available in the current slot, and we'll display the entry for that. And if this thing comes back up, then we will be able to see that showing up in the browser. So here it comes. About now. There we go. All right, finally. Right, I think we're through the worst of the random crashing, and hopefully the rest of the demos are going to work fine now. All right, so we have been able to build this bit of the UI using what would have been a very fluid experience if the hot reload prototype had been working correctly. But let's move on and talk about a slightly different feature, which is scoped CSS. And it ties in with hot reload a little bit. So how do we create the styling for our Blazor components? Well, the way that you would have done it traditionally on .NET 3 is basically just create one giant CSS file and dump all of your stuff in there. And that's not such a friendly developer experience. So a thing that we added as an improvement in .NET 5 is the ability to create separate CSS files for each one of your components. And I can show you that in here. If we have a look, you'll see that for each one of my components, I can optionally add a razor.css file, which will contain the styles that are specific to that component. So that's good in that one, you've got an ability to distribute your styles over multiple files. But the other good thing about it is that these are isolated styles. So the framework guarantees to ensure that the styles from each file only affect that component. They don't affect any other, even if they've got the same CSS class names in them. So as an example of that, if I look at the bookings grid file, you'll see that the CSS in there has got really simple class names like name, reason, and slot, and so on. And I don't have to worry about those clashing with other CSS files because, like I said, these are isolated CSS files. The framework guarantees to make them not clash by means of a fancy rewriting thing that it does at compile time. So let's have a go at editing this a little bit, shall we? I'm going to have a look at the style file for my main layout, which is quite simple. You'll see that it defines some properties that apply to all the other CSS files. And let's try changing this theme color, shall we? Let's see how we have a nice red theme. And I'm going to press save. And because of hot reload, instantly those changes will just show up in the browser. And I can see that the red theme looks absolutely disgusting. So let's try something else. Purple, that's kind of rock and roll, isn't it? So let's try that. And that also looks hideous. So I'm going to switch back to the yellow that we had before. But anyway, the point of this is just to show you that I can make these changes and they will be applied live via hot reload. Now, another example of why this is valuable is to do with the state preservation. So let me show you an example of why this matters. Let's say I want to work on the validation feature in my application. So I'm going to create a validation error like this. Okay, so I'm glad that's good. I'm glad that the validation error has come up. But what's bad about this is that the styling is kind of disgusting. Like I hate this horrible red box. It looks completely wrong. This is just the default styling that Blazor uses for invalid text boxes. Now, if I wanted to fix that traditionally, I would go to my CSS and change it, but then I would also have to recompile my application, switch back to the browser, reload the page, find the item that I was editing, click on it, open the editor, recreate the validation error, and only then would I see whether my CSS change had actually worked in the right way. That's highly inefficient, but thankfully with hot reload, we don't have to go through all that anymore. So I can now have this validation error on the screen here. I can go to my scoped CSS file that affects the form fields, and I'll add a little bit of CSS to it. So I'm going to create some CSS that applies to invalid things, and I'm just going to say I want the outline to be none. And then when I hit save on that, you'll see the outline instantly disappears. I didn't have to click through the UI to get back into this state again. Let's say I do want the border color to be red to highlight the fact that it's invalid, but you know that border is only on the bottom, so that looks a lot better. And because this is such a fluid experience, I can now incrementally try out like different sizings for things step by step until I'm exactly happy with it, and I didn't have to wait through any recompile processes while I was doing that. So that's scoped CSS and how it can be tied in with the hot reload system. Okay, so let's move on and talk about another thing. And I'm going to show you another thing that's in .NET 5 that not everyone has started using yet. And it's a performance feature called virtualization. And this is UI virtualization, where we only render certain parts of the UI that are actually visible to the user. So why would this make a difference? Let's have a look at what's going on in the application as it is already. So as you can hopefully see, there's quite a lot of stuff on the screen. As I scroll, there's absolutely tons of stuff that's there in the browser. So how much data have we sent to the browser, and how many database queries did we have to do in order to do that? Well, let's have a look at the initial HTML that's in this page right now. The HTML is absolutely giant. It goes on for thousands of lines, and the browser struggles to even render that much HTML source code, and it seems to have just kind of hung at the moment. I'm slightly concerned the browser is going to crash because there's just so much stuff in there. And another way to visualize how much stuff is in there is to count the number of DOM elements. So if I do that, I'm going to do a query selector to count all of the elements in the page, and you'll see there's nearly 10,000 elements in there, and that's really pushing up against the limits of what's going to perform well in a browser. So why is that? Why is it sending so much stuff to the browser? Well, let's go back to this home page and look at the logic that we created there earlier. Okay, so you will see that what it's doing, because we did this ourselves, is it loops over all the dates in the next 200 days, and for every single one of them, it creates a booking grid. And each one of those bookings grids itself does a separate call to get data from the database, and then it's just going to send all of that stuff down to the client. So we're basically querying the entire database and sending it all into the browser, which is just outrageously inefficient. I don't like that at all. So what can we do about that? Well, in .NET 3, you had to write your own application logic if you wanted to do something more efficient than that. But with .NET 5, we have a feature called virtualization, which I'm going to use right now. I'm going to go into my bookings grid, and I'm going to add a reference to the virtualization component. In fact, I'm just going to drop in the one that I've already got in my snippets, because I've got a few parameters that I want to pass to that. So waiting for VS Code to catch up here, which is being strangely slow. All right, I'll type it out myself. VS Code has got super confused and almost completely died right now. And my hot reload prototype has died one more time. So let's restart that. Seem to have pretty much lost this completely. I'm going to restart VS Code completely because the prototype that I'm doing looks like it's utterly killed it, which is fun. Love showing prototypes. Let's bring that back up. Okay, get that going again. Right then, so where were we? Okay, so we want to wrap our bookings grid in the virtualized component, which is going to be around here somewhere. Come on, VS Code, you can do this. This is really abnormal. Might be the sheer overhead of running screen share or something, but I don't think I've ever seen it actually fail to even load the snippets. I will copy them manually. This is cool. So, all right, so this is what I wanted VS Code to insert, a copy of the virtualized component, which is wired up to loop over all the dates that are available in the next 200 days. And for each one of them, it's going to render the bookings grid, but only the ones that are actually on the screen at the moment instead of all of them. So let's see what the effect of doing that actually is. So when my application comes up now, hopefully, it behaves exactly the same as far as the end user is concerned. They can still see all the stuff. They can still scroll as far as they want. But if we look at the initial markup that we're sending down to the browser, it's still the same because it didn't apply the changes yet. Cool. What it's going to do is it's going to only render the specific stuff that is available that is visible on the screen at the moment. And then we will not have to do database queries for all the other stuff. They will just be fetched on demand while we are walking through the UI. Okay, so let's see if this is ready to appear yet. Should be about now. Okay, so if we look at the initial markup now, you'll see it's way smaller than before. It's only 40 lines rather than many thousands of lines. If we look at the number of DOM elements that's in the page, it's now only 408 compared with the 10,000 that we had before. But the end user experience is still just indistinguishable. You know, I can still scroll to any point that I want. It will just fetch, render, and display all of this stuff on demand as the user is scrolling. Okay, so that's the virtualization feature. All right, next thing that we will look at, we will have a look at the ability to dynamically load JavaScript. So why would you do that? The whole point of Blazor is to be able to write as much of your application UI logic in .NET code and try not to have to use so much JavaScript. But if you are rendering stuff into a browser, inevitably there will still be times when you want to make calls into JavaScript. It might be because you're using native browser JavaScript APIs that aren't available in .NET, or it might be because you're using third-party JavaScript components. And I'm going to show you examples of both of those just now. So if we go back to the application, I'm going to show you an example of using a native browser API. And it's this date picker up here. So you'll see if I pick a specific date from here, like May the 1st, it will jump directly to May the 1st, as you'd expect. Okay. And the way it actually did that is it moved the browser scroll bar for me to the correct position. And then the virtualization component kicks in to fetch and render the right data. But how do we move the browser scroll bar from .NET code? There isn't a .NET API for that. We need to call JavaScript. Well, the way you would do that traditionally on .NET 3 is that you would have to load all the JavaScript libraries you want to use up front by adding script tags into the host page. And then you would have to make all of them available in the global scope, like as global variables. And then you would be able to call them from .NET. And that's fine, it works. But we've got a better way of doing it with .NET 5, where we can load JavaScript dynamically on demand and we don't have to pollute the global scope. I can show you that down here. So here is what happens when you pick a date from that date picker. We call this .NET method scroll to date, and it's going to find out which entry it is that you wanted to go to, and then it's going to dynamically load some JavaScript that it can use to get there. Now, it only actually has to load it once up front, because one time, because it gets cached after that, but it is dynamic on the first time, so it's kind of like lazy loading. And what we're doing is we're saying to the .NET code, we want you to invoke some JavaScript asynchronously and get back a reference to a JavaScript object. The JavaScript object will be the result of doing a dynamic import for a file called scroller.js. Now, if you didn't know, JavaScript has had the ability for several years now to do these dynamic imports using the import keyword, where it fetches modules, and modules can export specific functions and they can import other modules and so on, and the browser resolves all that. And that's what we're doing here. So what is this scroller.js file? Well, I'll show you. It's very simple. All it does is it exports a simple JavaScript function, which takes the element that we want to scroll and what proportion of the way through we want it to scroll, and then it just does JavaScript stuff. And we can call that export here. When we've loaded the module, we can call the scroll to, we can pass a reference to the DOM element we want it to scroll, and then how far we want it to scroll. And that's exactly how this thing worked just now. So now we know about this technique, let's have a go at using it ourselves to implement drag and drop. All right, so drag and drop sounds kind of advanced, but it's not really. It's quite easy to do. So let's see. What's the scenario? Let's change this a little bit. I want my name to be in here because I like to be involved in things. So let's say that I've got a booking at 9 a.m. today, and I phone up the studio and say, hey, I've got a booking today, but I really want to be in the new Studio 2 because it's way cooler. Can you please move me? The receptionist will look and say, well, we do have Jay-Z booked in at that time, but honestly, Steve, you're a way more important customer, so obviously we're going to bump Jay-Z out and let you move in. And they want to be able to just kind of drag and drop this thing across there, but they can't yet because we haven't got drag and drop implemented. Now, let's use a little bit of JavaScript to get drag and drop support. And we're going to do that using the same technique that we did before, where we'll dynamically load a JavaScript library. And I'm going to do that by dropping in a little bit of stuff I've prepared. So we will use the same technique to import a file called calendardrag.js, and then we're going to call this method enable drag drop on it. Now, as well as passing a reference to a DOM element, we also need to pass a reference to a JavaScript, to a .NET object on this occasion, because after the user has dropped, we need JavaScript to make a call back into .NET and say, hey, you need to do something because the user's just done a drag drop. So how can JavaScript call .NET? Well, we can do that by passing a reference to this object. We can use .NET object reference create to get a reference to this, and then I can send that into JavaScript. Okay, now you're probably wondering what's in this calendardrag.js file. So let's have a look in that. And it's slightly more involved than the other one that we just had a minute ago, but it uses this third-party library called Draggable to make things draggable and droppable. So we configure it in a few ways. We say these kinds of things can be dragged, they can be dropped into these kinds of elements. We configure it in various other ways. And when the user finishes dropping, we'll check, did we get past a component instance? That's the .NET object. If we did, we'll make a method call to it in order to have it actually perform the drop. Okay, so let's see if that actually works. So I need my changes to be applied, and I do not trust this prototype one little bit anymore because it's been going wrong all the time today. But let's see, is it working yet? It is not. I'm going to have to restart it one more time. All right, so once that is back, we will be able to move our objects around, and hopefully they will actually get saved in the database when they are dropped there. So hopefully you can see that it's quite convenient to be able to import JavaScript modules like this, and the JavaScript module can export whatever functions it want, and then we can easily invoke them from .NET code. All right, so here that comes back up, and now I can move Jay-Z down there, I can move Steve across there, and hopefully that change has really taken effect. So if I reload the page, you can see that the state is correct. It's really over there. All right, so what else should we talk about? Let's talk about another .NET 6 feature, error boundaries. So what happens when there is an unhandled exception in your application? Well, the way things work on .NET 5 is that if there's an unhandled exception, then we automatically shut down the connection for that particular user. And that's quite important for stability and security, because if an unhandled error has occurred, then we don't know what state your application has been left in. We don't know what state the framework itself has been left in. And so we, in order to protect the security of your server, have to stop that user doing any further interactions within the context of that connection. And that's fine. It's fairly similar to how, say, MVC deals with errors. But some developers have said they really want a more fine-grained way of dealing with errors. They want a way of localizing errors to a particular part of the UI so that they can provide a more of a custom experience for responding to errors. And I'm going to show you an example of how we can do this right now. So I want to have an unhandled error. So to do that, I'm going to find a particular data item and I'm going to pretend it causes a problem. So if we look along, then we can see that, okay, so there's a booking here on April 5th by Madonna. And I'm going to say that whenever we see this record by Madonna, let's just imagine it triggers an exception for some reason. Like, I don't know why, but we'll just pretend there's something bad about that data and it causes a problem. And to simulate that, I will drop in a little bit of code to my rendering logic here. So I'll say, if there's a booking with the name of Madonna, then we are going to trigger an unhandled exception. Okay, so I've saved that and you'll see an unhandled exception has occurred. All right, now if I come back and reload, then when I'm at the top of the page, you'll see there's no exception. Because of virtualization, we haven't loaded Madonna yet. But as we start scrolling, eventually we'll have to load the Madonna record. And at that point, the unhandled exception occurs. All right, and when the unhandled exception occurs, we can't interact with this application anymore. I'm clicking on these things and nothing happens. I'm clicking on this hamburger menu, nothing happens, just because the whole connection has been shut down in order to protect the server's stability. Okay, but using error boundaries, we can change how this works. So I'm going to go to my home screen here, and I'm going to put an error boundary around this whole page. Okay, so let's put error boundary around this. And I'll drop the endpoint in there. Okay, so I'll save that change and then I'll come back and I will hit reload and we will just take a gamble on whether the hot reload prototype has actually done that properly. It looks like it maybe has. All right, good, it has. Right, so now when I'm at the top of the page, there's no error, but as I start scrolling down, then at some point we'll load the Madonna record, and at that point, instead of shutting down the entire connection, we just shut down this part of the UI. So this subtree within the UI is now gone. There is no bookings list anymore, but the rest of the application is still there. This button works, I can navigate away, I can navigate back, and everything continues working, except if we see the bad data, at which point we shut down that part of the UI. So we can change this to do even more fine-grained error handling if we want to. For example, let's say I'll remove the error boundary from here and I'll have a different error boundary inside my virtualized component. So all this stuff composes together nicely. So now every single bookings grid is its own separate error boundary. So when that reloads, then I will be able to see a slight change of behavior in the application. Right, so now this time when I scroll down, instead of shutting down the whole page, hopefully we'll just see a single entry in the list has been replaced with this error message. Okay, so that particular day can't be seen anymore, but the rest of the day are all there and everything is still fully functional. So what's the point of all this and how should you use error boundaries? Well, should you put an error boundary around every single component in your application so that every single thing can fail independently? Will that make it more robust? Well, I would say that's probably not something you should do. What you as a developer need to do is design a user experience that makes sense in some way. It doesn't really make sense for an individual button to shut down on its own because it might be that the user can't productively use the rest of the page when that button's gone. So as a developer, you need to design a system where things shut down in a way that makes sense to the user. So maybe you should have per page error handling. Maybe there's a certain type of component that, like it's a third-party component and you know it fails sometimes and you can't stop that. So you're just going to put a boundary around that one thing. It's up to you. The point of it is that you as a developer get to control that now and you control the exact granularity of error handling within your application. Okay, so there's many other things that we're planning for .NET 6 that I won't have time to talk to you about. The biggest one is probably ahead of time compilation. So that is another performance feature, and that's specifically for running on WebAssembly. So with .NET 5, when you're running on WebAssembly, your .NET code is running on an interpreter within the WebAssembly world. And that is fast enough for many kinds of applications. It's fast enough to build very large, sophisticated UIs. You can have grids with thousands of rows or whatever. The interpreter's fast enough for that. That's great. But it's not fast enough for intense CPU-specific code. So if you were trying to do something like image processing or machine learning or something like that, that wouldn't really be a very good idea on the interpreter. But with AOT compilation, we can translate your .NET code ahead of time into pure native WebAssembly bytecode, which then gets JIT compiled by the browser, and it can run at something much closer to native speed within the browser. And at that point, you genuinely can do image processing or machine learning or whatever you like inside the browser. So that's a really exciting feature, and we're very close to being able to show that. That's we're going to have the first version of that you can use in the .NET 6 Preview 3 release, which is coming in a few weeks. I just couldn't show you today because it's not quite ready enough. Okay, the other biggest feature that we're including in .NET 6 is support for desktop applications, and we're particularly focused on Windows and Mac for that, because that's what most of our developers have told us they're interested in doing. And I've actually shown you that already, although I didn't mention it. So when I started up this application from my taskbar before, and it popped up in a little window on its own, that's actually a native Windows application. It's using web-based rendering, and it's obviously sharing code with the rest of my Blazor Recording Studios application. The point of this is that if you need to create a Windows or Mac application and reuse your existing Blazor and web development skills, then you can do that. It's quite a lot like building an Electron application, but without having to bundle a browser or node into your application. So that's something that a lot of customers have told us that they want to be able to do. And it's not running on WebAssembly. It's not running on server. It is running natively on the operating system. So you can access the local file system and do whatever else you want to with the operating system there. Okay, so last few things. We've got some advantages to the improvements to the component programming model, such as the ability to do pause and resume and transfer state between server and client. Can't really get into too much details about that because I'm running out of time. And we've got various improvements to the component programming model. So for example, you can define your own custom events and custom event arguments now. That's a new thing. You can mark parameters as being required on certain components. And we've got this advanced feature where child components can automatically inherit generic types from their parents. And that's useful when you're creating a suite of related components. For example, if you've got a grid with columns inside it, or tabs, or like a tab set with tabs inside them, and you want to have generic types flowing down there. It's a bit more of an advanced feature. But the overall point is that the programming model is getting more sophisticated in .NET 6, and specifically that we're filling in the gaps that developers have told us that they most care about. So that's all I'm going to have time to show you just now. If you want to get started with Blazor, and you're new to this, then go to blazor.net. You'll find guides on what to download. You'll see some introductory tutorials and all kinds of useful information. And if you want the code from this talk, the Blazor Recording Studio app, then you can go to the URL that you can see there, and you can try it out yourself. Now, the download there does not include the hot reload prototype, which, given how it's performed today, you probably aren't going to feel too much of a loss of. But if you're very excited about hot reload, then the great news is that the real implementation of that is extremely close to being ready, and we are planning to include the first version of that in the .NET 6 preview release, which is coming in just a few weeks. So that's very exciting. I'm looking forward to being able to show that for real. So that's all I have time to show you now, and I'm going to hand back over to Dylan, and we'll see if we've got any questions, and I'll put my face back up on the screen now. Okay, so back to you, Dylan.
Fantastic. Thank you, Steve. There are comments in the YouTube chat saying that you just won NDC.
Okay.
There was some really, really excellent stuff in that. Really, really great talk. There are a couple of questions. There is now a flurry of questions. We have a couple in Slido that have been upvoted. So Neil Barnwell wants to know, is it possible /practical /idiomatic/common to take an MVVM style approach to Blazor apps for those things that aren't purely about rendering the UI?
So with MVVM, one of the core ideas is being able to trigger updates of things from your view models. So you would create a set of view models that have got things like iNotify property changed and things like that on them. You can absolutely wire that into Blazor. It's not very difficult. I keep thinking I should write a blog post about this. You can absolutely just subscribe to the notify property changed events and use that to trigger updates inside Blazor. And in terms of how you distribute the logic of your application across models and view models and your UI components, that's completely up to you. Blazor has no opinion about that. You can structure your code in any way you want for that kind of thing. So yeah.
Fantastic. Question which just says, thanks for doing this. We appreciate seeing the prototype. What's the
Cool.
There you go.
It didn't crash as much before when I practiced this. It crashed like twice or something.
It is
Today, it's like every change made it
one
crash.
of the lovely things about audiences like this one is we've all had to demo code in front of people, and we all know what it's like when it crashes. But seeing work in progress from someone who's actually working on the next iteration of Blazor is a really, really interesting insight into the sort of don't touch that, that's a rough edge, this doesn't work, this will be different, but look what it can do anyway.
Yeah. But the real hot reload thing is so awesome. Now, I genuinely got the kind of like full end-to-end experience of it from some of the other engineers in our group last night about 7 p.m. and that was the first time that I've experienced the full end-to-end of it, and so that's why it was too late for me to show you that today. And it is so fast. I could not believe how fast it was. Like, you press the save button and before your finger even starts moving back up, it's already updated in the UI. Now, I've seen hot reload on other technologies like Flutter and in Webpack and so on, and they tend to take about 1 second, 2 seconds to update. The one we've got coming is so fast. It's so fast, we're thinking of doing it in real time while you're typing. I'm really impressed with it.
Fantastic. Question, can you deploy Blazor apps to Android and iOS?
So if you want to use there's so many different ways you could do that, right? So one way you could do it is you could create a PWA, which is going to run inside the normal browser, and you can be installed onto the home screen and can run on WebAssembly. Another way you could do it is you could take a WebAssembly app and wrap it up in something like Cordova, and you could drop that into the Google Play Store or the iOS App Store if you want to. Another way you can do it is you could use the technologies that are coming in .NET 6, which would I just showed you a native Windows app just now. Now, that's built on something called .NET MAUI, which is the multi-platform application user interface stack, which is new in .NET 6, and that supports Windows, Mac, iOS, and Android. So although we're not massively focused on iOS and Android for web rendering scenarios, we're not doing anything to stop you. So you could absolutely deploy to the App Store that way. And then finally, if you didn't want to do web-based rendering at all, you wanted to render native Android UI elements with not HTML using the Blazor programming model. We have an experimental project called Blazor Mobile Bindings, or Mobile Blazor Bindings. No one knows because it's such a terrible name. We can't remember what order the words go in. If you look that up, then you will see a way of creating native UI elements for iOS and Android and other UI platforms. But that's just experimental.
Fantastic. Question from Ivan Biera. Will Sass and Less be supported in scoped CSS?
Sass and Less, yeah. So you can already do Sass and Less for Scope CSS as long as you do the work to make it work yourself. So now that's a bit of a terrible answer. Yes, you can do it. Just write the code yourself. Draw the rest of the owl. That whole thing. So it's not that bad though. So imagine that you add a little bit of MS Build stuff that says each time the application builds, I'm going to shell out to whatever it is that converts Less into CSS or Sass into CSS. And as long as that happens before the .NET compile happens, then the whole thing's just going to work. Because as far as .NET is concerned, we see that there's a CSS file, we'll bundle it with the normal scoped stuff. So yeah, you can absolutely do it yourself. You have to write a little bit of build logic. We're not really planning to create a feature for that ourselves because the state of JavaScript build systems is constantly churning, and we've been burned with that in the past. We kind of would rather have tutorials and blog posts and documentation on how to do it than making it a native feature.
I gotta say, I might get some shade for saying this on the internet, but SAS and less are now too important to be entrusted to JavaScript build systems.
Right, yeah.
No, I love them. I think they're fantastic, and I've used them in various ways in .NET. The question in the YouTube chat, can we manipulate, I think the question is saying, can we manipulate the DOM in C# so that we can eliminate JavaScript completely?
Right, so Blazor's programming model is not oriented around the idea that you're just going to do like get element by ID and set text content and things like that. You can. We're not stopping you from doing it. But Blazor is like other SPA frameworks in that in order to do efficient UI updates, it needs to be in control of the UI. It needs to know what the state of the UI was before in order that the diffing algorithm knows how to update stuff. So if you just start messing with the DOM directly, then Blazor won't know that you've done that, and the diffing algorithm may not be able to update your UI anymore. That's not a limitation specific to Blazor. The same thing happens in React, in Vue, in Angular, in all of these kind of diff-based UI frameworks. They all want you to not mess with the DOM directly. But still, we're not stopping you from doing it. You can use JavaScript interop to do that directly. If you want to, you can create your own library of C# helper functions that contain all wrappers for all the JavaScript things like getElement by ID and set CSS class name and all that kind of stuff. You can do it. I don't particularly recommend it because then you'll lose some of the benefits of the diff-based update system. But, you know, have fun if you want to do it.
It is, I think, worth saying the front-end web development community as a whole has spent a lot of time trying to get away from things like getElement by ID, and React is another very good example of the declarative model. You don't tell the browser how to do it, you tell it what you want, and you let the algorithms figure it out.
Yep.
Fantastic stuff. Yes, thank you so much, Steve, for joining us. There's some really, really exciting, interesting stuff. I'm looking at it going, I have to host a conference for the rest of the day, and I want to go away and start playing with that stuff now.
Cool.
So that was really, really cool. Thank you so much for joining us. We are going to take a short break here from some of our sponsors now. Let me switch back. There we go. Right, that's it. That's nice. That's lovely. Hello, hello, hello. Yeah, there are some 3D transformation filters in OBS, which we've used to set up some of the virtual studio angles. And it appears that some of them make the audio go choppy if two people are talking. Which is one, and they only do it on YouTube. They don't do it on the monitoring loop. There are so many just fascinating things about the whole streaming setup. You know, the amount of technology that has to work for this is phenomenal. Let's get our next speaker in. So I'm going to welcome here to the NDC studio. Just looking at the comments in the chat, the most used term of 2020. You're on mute. You're on mute. Can you hear me? Let's do this. I'm not a cat. Can we do this for real? Hello, Heather. How are you doing?
Hello. I'm doing very well. It's so nice to be back at an NDC event.
Nice to see you. Welcome. Let me just sort out the things and switch the angle here, and there we go. We are live on the internet. So in a few moments, you are going to be talking to us about the care and feeding of developers, which is cool. It's a talk that I've seen before. It's one that I like very much. What else is going on in your world, Heather?
Oh, goodness. Well, I'm here in Kansas City, as you can see by the skyline behind me. And I've been doing so many different kinds of things for my work because, you know, I work for Okta. And on my own, I actually just bought a house here. So it's a really big deal to finally have my own big studio kind of area. So I'm looking forward to everybody giving me suggestions of how they built out their studio, in the comments section somewhere, or you can always ping me on Twitter. But I am very excited about finally being a first-time homeowner. I never thought it would happen, but luckily being in tech allowed it to happen.
So if you'd said to me 2 years ago that the main reason I wanted to own a house is so I could actually paint the walls green, I would have thought you were joking. But now I'm like, if I owned this place, I literally would be painting the walls, and that would be my green screen setup. So.
Oh, absolutely. Because I don't know if anybody knows this, but I'm an avid Beat Saber player, and I kind of want to do the green screen of me playing while you watch what I'm actually hitting behind me. And in order to do that kind of setup, you really need like a full wall to floor experience for that. So I see a lot of painting in my future.
Lee says in the chat, are the Chiefs going to get to the Super Bowl this year? Are they going to get the Super Bowl back?
You know, I have a lot of faith in our hometown teams. I mean, who wouldn't? I'm actually not a sports ball person at all. So, but when you live here, it is impossible not to want to root for the people who are coming from behind. We've had lots of ups and downs as a team in the city, but I have faith.
Because there's that thing is like, even if you don't care about sports, if the hometown team are winning, everyone's happy and it's just a nice place to be. So I've noticed this a couple of times. Right, we have about 5 minutes. We are going to hear very quickly from some of our sponsors while we get Heather's stream set up and ready to go and everything. I just want to give a shout out to Insight Investments. Some of our sponsors are over on the expo. Some of our sponsors are going to be hearing from them in a second when we run the reel. Insight Investments, big supporters of NDC, lovely people, and they said, no, it's fine, just give us a shout out. So thank you, Insight Investments. We really, really appreciate your support. Thank you for being part of it. Here's a quick word from our sponsors. We will be back in a few minutes. Right.
At iVendi, we build technology that makes it easier for dealers to sell and consumers to buy vehicles.
So what iVendi does is we build a platform that facilitates online retailing. This means that we basically make it easier for people to buy cars and for dealers to sell them. We do this from end to end, so the full journey from people, consumers coming to the site right through to the finance applications that go through. So to facilitate that, we have really important relationships with banks, with vehicle manufacturers and with vehicle retailers themselves. The tech stack we use is mainly AWS, and we use C#.NET as our predominant backend language. And we use a little bit of Azure as well. We deploy most of the stuff in containers using Kubernetes on EKS. And we're a big fan of event sourcing here. That helps us to separate the domains out into separate areas, which allows us to keep those domains nice and segregated, and also facilitates the auditing, which is a big part of us working in a regulated environment.
I chose iVendi mainly because of the people. They're very welcoming, they're really knowledgeable and seem really passionate about the technology and the quality of the products that they're creating.
Welcome to Margo. We're an airport-centric travel company owned by MAC, the country's largest airport group. Most importantly, we're a globally unique digital tech business based right here in Manchester. We operate as an innovation hub, a truly agile e-commerce business driven by data and the latest tech to provide airports across the world with a unique blend of products, technologies and services for their passengers. We have become synonymous with airport customer e-commerce platforms, which we're constantly evolving. If you plan to fly again in the near future, you may well use our system without realising that it's actually a Mago product. We're a business for someone who wants to create and do something a bit different. For the techies, we have a fail-fast CI/CD approach using .NET Core at the back, Vue and React at the front, and AWS cloud hosting. We expect to grow our team over the coming year, so please keep an eye on our Mago LinkedIn page for the latest jobs. Thank you.
So we're going to talk a little bit about what it's like to take care of our engineers. Now, I know it's not something that everybody is necessarily used to bringing up, but if you ever have any sort of aspirations for becoming a lead, a manager, or even a CTO, this is stuff that everybody needs to talk about and know. So the first thing I want you to think about is how you got here. Let's say you are at the top of your game, you know, code just flows through you as if by breathing, you know, and you've climbed your way up in the programming world. So it starts to somewhat make sense now after the long journey you've had that you are happy and tranquil in what you can provide. But do you actually remember how you felt when it all began? Let's talk about you. I can safely assume that you are competent and worthy of being here. You have paid your dues and worked your way up through your skill set. So when I first started down this road, I think I didn't really have an appreciation, at least at the 5-year mark, for how far I'd actually come. In the beginning, I was fairly frustrated. Do you remember that frustration of trying to figure out a new concept without any context to build on whatsoever? The hours that you would spend trying to decipher what programming even was, and sometimes I personally began to wonder if I had enough space in my brain to figure it all out. A very wise woman once told me, "Heather, darling, not one of us was born into this world naturally coding." And sometimes I think we forget that when we talk about natural talent in this space. Please remember that you were the person on your team that you struggle with at every stage of your growth. So before you become a little bit too impatient on Stack Overflow with somebody asking a stupid question, consider that you asked a lot of stupid questions in the beginning. Do you remember how you felt when you figured it out? I remember the first time that I did anything with a console app, right? I think it was a Magic 8-Ball program. It was the first thing that we got to build in our boot camp. And I remember when I got it working, I felt like I was a wizard. And that's not an exaggeration. I literally jumped up and I was like, yes! And everybody in the class kind of turned and looked at me. And I'm still kind of the weirdo in the group now, but I want you to try and think back to that first day. It's usually a lasting impression on why we even started programming in the first place. So now you're a junior developer And you are excited because you figure something out and you think this career could be for you. So after you work for a little while, just discovering the new things, let's say you become a coworker on a team of software engineers, right? Now that's a little different because before, your coping skills was all about how you personally learned things and how you personally produced things. But once you're on a team, you have to learn how to communicate to others, and you instantaneously started discovering that, hey, you know, maybe I know a little bit more than this one to my left, a little less than this one to my right. And you have to learn how to become valuable. This is kind of when you're in that, middle ground of figuring out how much value you can really provide a company. This is the middle level developer, the mid-level developer. Now, some of the things that you thought your life would be like is not at all resembling some of the movies that you've watched. I remember I always thought, you know, I want to be a lot more like Neo in the Matrix than, you know, somebody who feels like they were stranded on an island trying to figure out how to make fire. But this is a good chunk of your valuable years to companies because you aren't paid a whole lot yet, but you provide a lot more value than somebody who's completely learning. So you've done this for a little while, and now you're starting to feel pretty good about some things. You got some opinions. You like to chime in on social media about how you feel about certain frameworks coming out or certain ways apps are built. And you're feeling pretty good. You don't have to wonder if somebody is a senior developer because it's like a vegan or a CrossFit person. They will tell you. Unfortunately, a lot of people in this space like to talk about themselves that way to kind of prove themselves. Sometimes the way they will prove themselves is to kind of bully others, sometimes without knowing it. But mostly it's just to justify, you know, their job or where they are and their value in the community. All of this is due to insecurity. And as a leader and somebody who's an aspiring leader, it's important for you to understand that seniors may feel, or senior level developers may feel like they are your peers. And in certain instances, they could have some knowledge that might be on par with you. But where they are in their career is very different from where you are. And it's important to understand that this is kind of where a lot of separation occurs. Some seniors are the ones who seem overly confident and are not afraid to say that you're wrong and they are right. But that, again, is a lot due to insecurity. That's how they experience it. Other seniors may feel completely differently. They may have been given this role as a senior, but they feel like they don't deserve it. And that's a little bit more on par with my experience going up through the ranks into becoming a senior developer. So for me, I didn't actually feel senior, and I was just given that title because I didn't feel I had worked 20 years in the industry. But that isn't always the way that it works when it comes to how companies decide to hire people. Some of it is due to just a specific area of knowledge that you have a lot of. And some of it has to do with how much you dealt with different kinds of scenarios for their company specifically. So they are just more familiar with you than other developers, therefore they give you that senior title. Every background of a senior developer is a little bit different, but I want to get us all on the same footing, okay? I felt a little bit like an imposter before, and maybe you do too. I didn't feel like I deserved that, and some people felt they absolutely deserved that. Something to just keep in mind is that success is a lousy teacher, and it seduces smart people into thinking that they can't lose at this. Kind of like the stock market over the last year. A lot of people felt like, oh, I just kind of show up for a job and occasionally sound really opinionated in a team meeting, and sometimes just slam a bunch of pull requests. I must be a great senior developer. But the fact is that results are the only thing that matters in your career. But in order for results to even happen, that requires specific behavior on your part as a dev. So humans are not robots, and we cannot be programmed very easily. Humans have a lot of emotions which dictate their behavior. And while I was very proud to say that, oh, I'm a logical person, because, you know, I'm a technology and I believe in science and deduction and the scientific method, it doesn't mean that I don't have any emotion that controls the way that I behave and the way that I receive information, depending on my mindset at the time. So what we're going to do today is get a handle on how to recognize what motivates people on your team, but also kind of what blocks their ability to deliver results, and understand how to actually be productive with your team. In order to get the best people together, the best team members, you have to kind of ironically get farther away from what makes them a good developer and closer to what makes them a very unique human. And that is the way that you win. So congratulations. After being a senior for many years, you are promoted. You are now the team lead. You are now the team manager. You are now the director of software engineering, or CTO. Congratulations. But remember that people buy into the leader before they buy into the vision. And leadership is a muscle. I have to tell you a little bit of a story here when it comes to building muscle. I don't really have anything right now. COVID has not been kind to my gym going tactics, but I will tell you a story about when I started going to the gym. So I had lots of aspirations and my heart was in the right place. And so I decided, instead of doing things myself, I would go to a gym instructor. And so they started me off in the beginning, gave me some weights to do. I started doing that and they warned me, you're going to be sore the next day, maybe the next 2 or 3, because your muscles are learning. So I did that, felt good the first day. I was really excited to get started, and there was pain almost immediately, like the next day. People tell you that it's going to hurt later, but until you experience it, you really don't have an idea how much it will. And so, especially if you're using them somewhat properly, you're going to feel a soreness. It shouldn't be pain, but it should be a soreness. Then, I went back a day or 2 later to get started. I'm like, I'm still sore. And like, I know, but we got to continue to work a little bit so that eventually it becomes not sore. Well, fast forward to 2 months later, it was still sore for me every single time that I went to go do some weightlifting with him. Now, I was using a barbell, which is like just kind of like what this kid has, like right over here, right? And I started kind of arguing with my instructor, and I said, I feel like this is not for me, because I don't feel like I'm stronger. I feel like I'm always weak and I'm always sore the next day, and I don't feel like I'm getting anywhere. And unbeknownst to me, on this bar, he had over time put on a little more weight each time he added the weight to my bar. But he didn't tell me that because they were, on the floor and I was sitting there waiting. So he had changed it to what I lifted in the beginning, but it still looked the same, right? It still kind of looked the same because he was just sliding weights on. And he's like, try it again. And so I sat down and I lifted it again, and it was pretty easy. It was a lot lighter. And he said, come talk to me tomorrow. So I came back the next day and I wasn't sore. And to me, this was just kind of a silly thing to show me. But it proved a point that I had come really far, but I didn't know it because I was always taking on a little bit more weight, a little bit more than my muscles could handle. And because of that, I never saw the growth that I had. And it's pretty much the same thing when you start becoming a leader in tech. If, you know, as you start, you might be able to master a couple of things, but they're always adding another thing, always another crisis, always another person, always another situation, always another thing breaking in your code that your team has to handle. But if you were to take all that away and just do some basic things that you did in the first month or two you were a leader, I bet it wouldn't feel so bad. So keep in mind that leadership is a muscle and you have to exercise it. When you feel safe, the natural reaction is trust and cooperation. But when we don't fear our leaders, then we will combine our talents to face the challenges coming from outside of our team. What do developers want from leaders? I asked my friend group, and then I started asking at conferences, what do you want from your leaders? They want leaders that make them feel safe. And they may not use the word safe, but that is exactly what they meant. They wanted to feel like they weren't going to be worried. They used phrases like, I don't want to be worried about my job. I don't want to be worried about how my, whether or not I'm going to be included. I don't want to worry about whether or not my work is going to understand if I have family obligations. I don't want to worry. Worrying makes people feel unsafe. So they want leaders that make them feel safer. You don't need to baby people, but you do need to not make it seem like the threat. They want somebody who's safe, who makes it safe for them to fail. Let's say if they do something new that they've never done, or just a little bit of a stretch goal, right? Let's say that something happens that you have to turn something in 24 hours and the stakes are high, but you don't have the person who knows how to do that particular thing there. However, you do have the person that they normally work with. So that person just gives it a go. They need to feel like even if they fail at that they're not going to lose their job and that you understand where they are with it. Part of that requires both of you to communicate, but it's important that they feel that it's safe to fail and they can confide in you and that you believe in them. And it's important that their perspective is that you believe in them. It is important that you reiterate or you come up with new ways of communicating that to them. They also want leaders that have vision and a higher purpose for their work. So make sure that you provide educational opportunities. People want to have a purpose for being, above and beyond what they punch in and do in their everyday work. So they want a leader who can inspire others to the calling and find a part in it. So we want to grow beyond ourselves. A good example of this is somebody who's just dealing with being the leader for a project or a company that they don't really believe in. They probably should find something someplace else. However, it's possible that where you work and live, you might not have options for a whole lot of companies to work for. So it's important as a leader that if the work is not cool, in other words, it might be boring to you, that you find another mission. And I worked for somebody who found the mission to be how clean their code could be, or how much we could automate away from the team, or finding more elegant solutions for looking ahead to version changes on different ecosystems, different libraries. And it became kind of a fun mission for us to always just have excellence in what we were doing, even if what we were building wasn't inventing a brand new type of application or industry. And developers want flexibility and people who are empathetic during their personal challenges. My gosh, haven't we had a very challenging past 12 months? If you have hard times in your family, would you consider firing your family members? I mean, maybe. That sounds like a personal problem. Think twice about what's really going on with your developers and never sacrifice people to save the numbers. I hate that term. Sacrifice the numbers to save the people. They will notice and they will reciprocate. I want you to ask yourself, if you're a leader and you're watching this right now, does anything that you have stand out as a weakness or strength on the list of things that I've gone over so far about what developers want from their leaders. Make it a personal goal to fix that. And please understand that no matter how cool it is at the company you work for, a good leader is worth gold to a team. And if you leave that company, a lot of times people will follow you and go to wherever you go next, because they know that they felt like you believed in them. They felt safe to make mistakes and learn from them, that you're flexible and empathetic, and that you give them something to strive for. Regardless of whatever you guys are building, it's the way you're building it and how you communicate as a team and how you challenge each other to keep going. Consider this list when reflecting on how much you're bringing to your own team as a leader. There's no hard and fast rules. You need to put people before profits. And that is my end statement there. I know it's difficult, especially if you run a tight ship where you are a startup or you are a business that's just very tight. Let's say you work for a government agency that just has the money that they have. But if you put the people before the profits, 9 times out of 10, the leaders above you will respect that leadership ability and will work with you on it. First thing I want you to do is think about how you need to listen. A leader doesn't need to have the first word, the last word, or even most of the words. The state of the team will often be made very clear to you when you listen and digest what each of your developers have to say, and not necessarily always jump to take action on it. Many times, developers just need to vent and do not necessarily expect you to fix all of their problems. They just need to be heard. Always let the employee go first in a one-on-one meeting. And after processing what they have said, if an action is required, then do it last. Demonstrate active listening by repeating what you heard so they have an opportunity to correct it if it was misunderstood. For example, you can say, all right, so what I'm hearing from you is that you need X, Y, Z. And is that, did I hear you? Did I words other? Yeah. Did I understand what, the thoughts that you have to share with me today? It sounds a little strange to just repeat, but it really helps because then I feel like I was listened to. It's a very easy thing to just add into your bag of skills as a leader. Respect. You will have differences, and that is okay. This one needs to be emphasized. It's awesome that your team is different than you. Start with respecting those differences instead of the temptation of telling them they are wrong. There is a reason a developer thinks the way they think and do what they do. If you start with respecting what they bring to the table, and it's a lot easier to work through those issues. This, of course, extends to things that they cannot help, like the way they were born, the country or city that they live in, perhaps the wealth class that they are in. There's a lot that they can't necessarily help that absolutely impacts the way that they process information. So just because you came to a conclusion in a different way doesn't make them wrong. It just means that they've thought through things differently. So please respect that. And instead of saying, no, you wouldn't do that because XYZ, just say, oh, that's interesting. And ask them maybe how they would solve this problem to get to a goal. Encourage. This one is a tough one because not everyone is a natural born cheerleader. I'm a natural born cheerleader, but that's just because I kind of didn't have a lot of that growing up. So I want to make sure that I encourage people a lot more than what I got. But remember, you don't have to be a natural encourager. This is a muscle you're building. Remember, you're building muscles, right? Being a successful encourager means believing in the ability that the developer has to overcome especially when they don't believe that themselves. So that means you have to see the potential in them and share it often. In order for them to push through the hard stuff, you have to have someone in your court. This is huge. I would not be where I am today if it weren't for a leader in my life, in my working life, encouraging me to go for things that I felt was beyond reach. Some of it was public speaking, but some of it was just going into a sector I had no experience in and being afraid that my failure was the failure of not only myself, but all women because of just how I was born. And it just kind of terrified me out of even trying. And that might be something that you've experienced in your own life, that, hey, just because I'm a minority, maybe by race or by gender, it could be that you're a minority of the people in your family to think the way you do. That I'm certainly that way. So it's possible that you already have all this history with your family and your friends where nobody is a developer, nobody's doing what you're doing. That is a huge thing for a developer to experience, constantly pushing through their home life. Please don't be part of making it difficult for them. Be the encourager, be the, not just, oh, I'm sure you're going to do better. Encourage them in a very specific way. If you notice that they don't need encouragement in one way, but maybe in another, try focusing on it. It just shows that you are paying attention to their specific needs. Recognition. Recognize. This is a big part for a leader. Ranked higher in importance on the list than even compensation. Employees in every single field are often starved of recognition, that they did a good job at something. Even if they know internally that they did, if nobody talks about it at all in your company, it can make you feel like you're just kind of floating there, and you'll probably be the first one axed if they have a budget cut. So we spend on average as much time with our coworkers as our family, and that can be exhausting if you don't feel that your effort is being appreciated or acknowledged when you have gone above and beyond, especially. So find something often, weekly, daily, if possible, to tell your dev team members individually what you appreciate about what they did, even if it's just how fast they did a pull request. It's not just about thanking them for doing something to help you out. It's about just recognizing the value that they bring. Ooh, empower. Apparently I wasn't very good with that slide, huh? Delegation is key here to make sure that your team steps up to the plate and truly feels like you trust them to do the right thing. Every person will have a different level of confidence here, and many need continuous reminders that they have permission to go with their guts and solve a problem or create an idea. So this puts them on a more level playing field with you and gives them a glimpse into what it kind of feels like to make a decision, which is part of your job. So the next step is where you identify your leaders that are going to come up after you or alongside you. This is where you identify them, empower them, and let them shine, and to where it just becomes very natural for them to move into that promotion or that position. So just to recap, a technical leader will listen, respect, encourage, recognize, and empower. Don't you feel like you're at a TED Talk now? I actually watched a lot of those when I was trying to learn how to do this with a dev team. Let's talk about the Parthenon. I had the privilege of being able to go to Greece and see this in person. But let's talk about what this is as an architectural marvel that has fascinated builders for centuries. So when you look at it, even in its state of disrepair, it appears to have perfectly straight identical columns that hold it up. But this is an optical illusion. In order for it to appear straight at a distance, each disc that stacks upon one another tapers ever so slightly inward and gets slightly smaller towards the top, making the order that they are stacked in very important to reach that appearance. Not only is each column disk section tapering smaller and slanted, they are also compensating for where they are placed on the very slightly irregular foundation, which they didn't have as nice ways of making everything straight with them. Therefore, each one of these columns requires millimeters of difference to make all of them join the roof at the exact same height. That makes every single column disk in the Parthenon completely unique. What appears to be a section that you can easily swap out becomes a particular challenge to find the right fit. And this is how amazing development teams are actually built. You cannot just swap out a mid-level developer for another mid-level developer and expect it to fit just perfectly. There is unique attention required for that individual in order to give them a place that is right for their talents and their mindset. So celebrate their differences and notice how they each can support the overall team goal for what you've built in the area that needs a little more this or a little more that. A great leader to me is someone who almost becomes unnecessary. They help each person wake up the aspects of themselves that they already naturally had as children. Which brings me to the care of junior developers. Everything you need to know, you used to know when you were a kid. It's important that you show them how to do things by demonstrating tasks and staying nearby to guide them as they begin. Let them make mistakes and remind them that it happens and encourage them to get up and try again. The care of mid-level developers, of course, is going to be different in how you approach them. Support coworker pairing as they now contribute more to projects with consistent results, and generate confidence in your mid-level developers by encouraging vocalizing ideas and asking them what they think first before you ask the senior developers. That's how you grow them. That's how you awaken that spark. So let's talk about the care of senior developers, senior level developers. Allow time for experimentation and autonomous tasks, and then ask them to bring new ideas. They've been there and done that, and they've seen a lot of things, and they have a lot of experience. So part of what keeps them just awake and in the moment is not doing the same thing over and over. Let them do a little bit of exploration. Have them teaching the concepts that they learned to the other developers regularly and showcasing the research that they discovered that could change some of the dynamics of what you're building. Let's talk about personality types. So it's not just about understanding how to approach somebody where they are in their career, it's who they are in their career. So let's talk about the feeding of the introvert. That's me. I'm an introvert. And the way that I was definitely nurtured and fed into being able to talk to you is that I needed to have some alone time to recharge. I don't do really well in a lot of team things all the time. I sometimes just kind of need to go off on my own and be able to think individually. This personality perhaps, doesn't thrive as much by being around lots of people all the time. But they have often a lot of value to add when it comes to really ruminating on the why of things. Introverts tend to really think a lot about that. The extrovert, of course, is different. An extrovert might need that interaction with people. Right now, my extroverts, I feel bad for you because a lot of us are just away from people. And sometimes doing Zoom calls does help. But oftentimes they feel the most alive when they get to be around other human beings. That's where they get their energy from. So keep in mind for their developers that you have that are extroverts, because they do exist, it's important that you also do some team, outings and things away. But it's also important to them that perhaps they go into an office or they get to travel as part of their job and see lots of people. how to take care of an optimist. Well, these are the fun ones, right? Their personality is great. You always know who they are on the team because they're like, yeah, we can totally do this in 2 weeks when it really is 4 weeks worth of work. It's like, but I know we can. Yeah, we can totally do this. And they're always happier about whatever it is they have to conquer. And it's good to have somebody like this on your dev team in terms of personality, because oftentimes we get bogged down by how much work we've got to do. But this person always kind of makes us feel like we got this. And they're always welcome in a dev team. But it's important to have a pessimist too. They find the blind spots in the situation that others did not notice. That's pretty important. A pessimist needs to make sure that we have done all of our due diligence, that we haven't missed something. So part of how you feed them is making sure that they are part of vetting out the process about how it could fail. Just instead of taking a deep breath and wondering, when is this person going to just shoot down this new library that we want to add, or this new way we want to do our team? Why don't you just ask them to provide feedback ahead of time? Then that means they feel that their opinions are valuable. The feeding of the sensitive developer. So this is often people that you might not even be aware of are sensitive. Sometimes you might be a combination of a couple of these. The sensitive developer is definitely a personality type that pays a lot of attention to how everybody is doing and how everybody's feeling. They tend to be just a little bit more aware. And so this is the person on the team who might come to you saying, hey, I think the team is kind of feeling this way. Maybe we can do something about it. Or it might be about a specific individual. This is not a complaint. This is truly somebody who has cause for concern. Or they may come to you not with any specific person in mind, but just a direction in which the team is going. They're probably the ones who mention, hey, maybe we should send, a care package to somebody who's out sick. They're the ones who are thinking about the human aspect of the team. How do you feed a bold person? You don't need to feed a bold person. They feed themselves. They're just like, here I am. This is what I want. This is what I'm going to do. And it's breathtaking to watch them work. We need bold people. Without bold people, we would be milling around, not making decisions, and not really having a strong direction to go. So bold people are the great ones for helping execute a really good vision that you have for your team. Getting their buy-in is really important because they often have a very loud voice, not necessarily with decibels, although it could be that, but they have a very opinionated voice that definitely strikes out. So it's good to get their buy-in for some of the things you are doing. Again, bringing them in early. But the visionary. These dev team members are so valuable. Somebody who sees the big picture and not just the individual lines of code that you're doing. Someone who truly understands where you're going with it and asks really big picture questions. A visionary developer is somebody who allows your team to dream a little bit about how much better things can be. And it's important to have a little bit of infusion in this, because this is somebody who will bring up things that you probably never thought were possible, because they aren't constrained necessarily by the status quo. They're always looking at brand new ways of doing things. Of course, I'd be remiss without mentioning the downhearted types of developers on your team. This is not a personality type, and I tricked you a little bit with that. It could be any one of us, and it could be any one of us at any point in our lives. So whether it's a moment in time that happens to every person, or this is someone who chronically suffers from a medical diagnosis, this is something that a development leader will run into. You will run into this. It's important to take the time to acknowledge mental health challenges. This person might have a different name every day of the week, and it might be you. You know, there's a lot of things that I have personally struggled with, and not just this year, but many, many times over the years, just because of where I'm coming from in life, but also just the way my mind works. So the most valuable leaders I've had in my life were the ones that allowed me to take the time that I needed for things. They didn't try to diagnose me. They didn't try to tell me what to do. They respected and supported. You respect and support. If they come to you with a lot of information that you are not educated and equipped to handle, please reach out to your, your HR person about maybe getting them in contact with just some resources for them, so they can go in front of somebody who is educated about how they can maybe change how they're feeling, or how they can at least cope with what they're doing. Remember, you are not a doctor, so don't pretend to be one, and don't tell them, oh, I just did this to get over my slump. It doesn't work like that for some of us. So it's important that you understand that your job is to support them and to get them in touch with the person who can get them resources. So let's talk about how to treat your team as a whole. The way to hack a human being is to notice and study their humanity. So pay attention and listen. One of the most common desires among developers is a manager who will recognize their abilities and trust that they'll get their work done. Let them do their job. Allow developers to do their jobs. Please do not, as tempting as it is, micromanage your team. If you don't feel like things are going to get done unless you're inserted in the middle of it constantly, you need to really take a good look in the mirror and ask yourself, is it because I need to feel necessary and like I affected this? Or is it because I have the wrong team members that I cannot trust? Is that something you can change? Maybe. Oftentimes, most of us can do this job. We either aren't properly motivated or we aren't equipped with the right kind of processes put in place. And both of those things are things you can affect. Allow developers to write code. They love doing it. You just need to find a way for developers to do this in a way that benefits the company. Make sure that you handle the non-development work needs. Yes, you're the one who should handle the meetings and the demands from the top down. You should be a filter and not just a pass-through for all of the demands that your company has for your team. Be moderately responsive to your developers and be reachable. This one, I didn't think I'd have to mention, but now that it's happened to me a couple times in the past, I feel like I probably should throw it up here. If somebody is really stuck and they have a deadline, which I have not met one developer professionally that doesn't have a deadline, timely responses are important. Give them guidelines and boundaries of like, hey, after 5 o'clock, nobody works, or after this time, I don't work. But you can always do an emergency scenario saying, hey, if the entire website goes down, you have the permission to pick up the phone and call me, and things like that. Make sure you just kind of outline, an escalation level of any sort of communication and follow up with it. Make regular one-on-ones a priority. This is hard. Have you ever sat across from a developer and you're just not like a people person, but you're the lead or you're the manager and you're like, hey, so what's up? So what's going on? Hey, I just need you to be faster at the pull request you're due. Thanks, good talk. And that was the extent of your meeting. That's not a great one-on-one, and then they oftentimes don't want to come back to it. So make sure that one-on-ones are quality, but also a priority. So if you have to leave, let's say you're sick or you have a meeting that you cannot get out of, it's very, very important. Then cancel the one-on-one, but immediately reschedule it or just move it to a time when you know that you can do it. If you just cancel it and you never create another meeting, then the developer thinks the one-on-one is not important to you. And that speaks volumes. Emphasize quality code over quantity or velocity. I promise you that if people are doing the right things, they will get faster at it or you will learn ways to automate it to make it be faster. If you tell people, no, it doesn't matter, we just need to throw this up there, you will get burned every single time. I've never had that go well in history, especially when it comes to client expectations. So it's important that you do quality over quantity, and you communicate that all the way up the chain if you need to get deadlines moved, or to get the list of the minimum features of a piece of software out within a reasonable time. And avoid asking them to task switch. So like being on multiple projects and too many interruptive meetings. In fact, really effective ways I've seen this happen is I only do meetings on Mondays and Thursdays, or hey, we do meetings only after 4 or before 10 or whatever it is. You can decide to block things off on your calendar and do that on behalf of your team, and saying, hey, this is what my team will do, just so that they have more time to allow their mind to solve the problems that they're given as part of their job, and not have to constantly jump into meetings. And be that shield for your team when challenges arise. Do not throw an individual developer under the bus. You will regret it, because not only will that person feel like they can't really trust you anymore, even if they did do it, even if they were the ones who did break the thing, not only will they feel a severance because you said, oh, well, this person made the mistake. You should take responsibility for the entire thing as the development leader, full stop. If you throw someone else under the bus, not only does that person feel like they can't trust you, the rest of the development team sees you doing that, and they know that you won't have their back either. So please avoid that. Trust your team's judgment. You may need to step into make decisions or priority calls, but this will be on the information provided by your team. If you get this right, you should have a good, autonomous, and self-directed team. And my friend Stephen Hotz said that, and I just loved it. So some takeaways for those of us who are learning how to take care of our engineers. Developers are self-sacrificial. They're not good at making sure they're okay before throwing themselves headfirst into problem solving and the exhaustion and tension that follows. But you still need to give away control of every single little thing and create opportunities for others to grow. It is a balance. It's your job now to make sure that the people behind the programming have what they need to be successful and balanced. Drive for autonomy and mastery and purpose. Allow your team to fail. Through failure, we learn, and we learn pretty well, and it's quite a memorable experience. Teach others and emphasize that you are learning as well. So don't feel like you have to be the one with the answer and you have to come up with one. If you don't know, for the love of all things, please say, I don't know. Let's figure it out. Or I guess I'm going to have to research that. Nobody will lose respect for you, because none of us were born coding, and we all had to learn, and Google is our friend. It's okay to not know everything. It's also okay to be a new leader and say, hey, I'm new at this. I'd love feedback from you. And people they'll open up to you about what they personally need. Be a gate opener, not a gate keeper. Go forth today and learn about new tech and better ways to code. Those skills are necessary, but take care to learn how to truly nurture a team by adding human skills to your agenda as well. With a group of confident, cohesive developers and a box of Legos, you can accomplish literally anything together. Now go build your Parthenon and stay curious.
Thank you very much for sharing that. So we have.
You are muted, Dylan.
I'm muted. I'm muted for you. I'm not muted for YouTube, but you can't hear me. That's all right. There we go. The joys of so many mute buttons. So it's been really interesting. I don't know if you're keeping an eye on the YouTube chat while you're talking there, because like you sort of said at the beginning, it's not the kind of talk that people have questions, but it's a kind of talk that inspires people to share things. You know, we've got somebody's just said in the chat, Dave Wong says he's just been fired for not coding fast enough. What would your reaction to that be? I mean, everyone else in the chat is like, yeah, you're better off without them. Good companies don't fire people for doing that. But, you know, have you come across a situation like that?
Oh, of course. I personally got fired for the same thing. So, like, don't worry about it. It happened. Remember, not all companies are just and fair. And it's very important to be involved with friends outside of your workplace, because that way you get a wider sense of what is acceptable at large in the industry. Therefore, these people are already giving you feedback that's saying, oh, you shouldn't probably be there. There's something wrong with that. That means that, you know, if you don't feel like you're coding fast enough, you have to ask yourself, do you want quality or do you want quantity? Now, if you're not giving either, then maybe you pick one, right? I would suggest picking quality, because your brain, like once you do some things a certain amount of time, it creates those neural pathways that will automatically go faster as you're doing something. So just pick a thing that you want to be really good at, or let's pretend it's just a library that you want to kind of be known for within your team anyway. And just learn a lot about that. And then you'll be faster about the decision making and getting a code sample and stuff like that. It's not really about sitting here with a timer. I know that there are competitions for that kind of thing. But those are not the people I want working on my project, because I'd rather have somebody who's thoughtful about what they're building.
Lena has a question in the chat. Says, my manager is doing tech decisions for the developers. How can I calm him down?
Oh my goodness, really? Well, it depends, right? So that's a trust issue, right? They think that, oh, my developers aren't smart enough, I'm just going to decide things. It could be that person was a developer once and they were never taught how to be a good leader. That is often the case, and they don't mean anything by it. They just don't know the right thing to do. So it's important that since you have this knowledge, you go to them and say, hey, I think your team wants to be involved with this. And that's part of how, you know, we want to grow as a team. So please include us in this, because we have some thoughts. And I don't know a lot of people out there who wouldn't be like, oh yes, please help me with all the work I have to do, all the decisions I have to make. If they still push back, again, I would question whether that person just has never had any training on how to be a manager, which is okay if it's you, you know, or if they really are just kind of jerks. And if that's the case, then you need to find somewhere else to be. You're probably not the only one who feels this way. So instead of just complaining, be proactive.
You ever hear the thing that even the worst job in the world can teach you one very valuable lesson, which is what a bad job looks like?
Yes. And what a good one looks like. I'd be interested to hear people express what is an attribute of like the best manager they've ever had, or maybe they've always had bad ones, but think if you have had a good manager, why were they good? What was it about them that was good? Is it because that they were a protege of Elon Musk? Like, what was it? It's leadership often has nothing to do with technical ability. So you have to understand that, guess what? You are pivoting to a completely different skill set. Yeah, sometimes you can get paid more, but that's because you have more headaches and it's more delicate because you're dealing with humans.
Just watching some more conversation in the chat. Elena says, what can you do when your manager makes a decision? Says the team can make it independently as long as it's the same as the rest of the company. So.
You know, again, might not be the right place, but you can always say, hey, this is how it makes us feel. And I think we need to get on the same page somehow, or you're going to lose people. I mean, that's what I would say. It's really, really difficult, especially when they think they know more than their team. I don't think that's the job of a leader at all. You need to be a servant leader. You need to be one who's like willing to get in the trenches with your team, but also don't tell them like this. It's really difficult. Yeah. It's a skill, and not everybody who has gone from being a dev to a manager has it.
And it's also, you know, I've always found leadership and management, if you're a coder and you're not as good as you think you are, you can practice by yourself. The compiler is infinitely patient and you don't have to put it on GitHub until it's right. It comes to managing people, you can't do that. The only way to get better at it is to mess up in public until you work out what you did wrong. And that's hard.
Yeah, but intent matters in that. Whereas as a developer, your intent doesn't matter at all. It's just, did you produce or not? Yeah. Did you check that code in or not? When you're a manager, your intention matters. Even if you screw up, be like, it's obvious if you care about your team because you behave that way. And even if you made the wrong decision, you own up to it, people forgive very quickly. They're like, okay, but I know this sounds terrible, but you know, they say, oh, leaders are not just nice people, but that's true, but they also don't blame others for their own mistakes and try to pretend like, I don't want to show weakness. Ugh. There's two different leaders that I think about. I think about Steve Jobs and I think about the difference between him and what Elon is doing now is he doesn't put down members of his team if they make a mistake in public. Like he's not like, oh, they were stupid and they did this thing. He's never done that. Whereas Steve Jobs has absolutely done that to everybody on his team before. So you don't feel it's different. They're both brilliant. They were brilliant people with vision, but it's just a little bit different. And they're all kind of quirky, you know. You don't have to be like a sweet angel. You just need to be respectful and realize you're probably actually taking on more responsibility than you need. You can probably allow other people on your team to take it on, and it shows that you have faith in them.
Fantastic. So we're going to get our next speaker in. Then I'm going to run another quiz prize draw. Thanks very much for taking the time to talk to us today, Heather. Let me click that button there. The layouts are going to go a little weird for a few seconds here because that's how the internet works. So there we go. Janani is in the call. Let me just switch that back to... there it is, and I can add another pin, and there we go. Hey, Janani, how you doing?
Hello,
Good
doing
to see
great.
you. So, we're going to have a very brief interlude now before we hand over. What is it you're going to be talking to us about today?
Today, I'm going to be talking about building friendliness into server-side applications.
Friendliness into server-side applications, which is a topic very close to my heart because there's not enough friendliness in a lot of back-end code. But before we do that, we are going to give away some more fabulous prizes. So... everybody who is watching on the stream, head over to slido.com, put in the registration code NDCMCR, NDC Manchester. We are going to run another quiz. This quiz, same as last time, 5 questions, multiple choice. Watch your screens, because that's where the fast things are going to happen. That's the thing that we need to be looking at here. And I'm going to kick this one off. We are going to do a quiz here about a technology by the numbers. So, the wonderful world of tech that we all work in is full of statistics and figures and measurements and metrics and all these kinds of things. And we are going to see. Now, this is one of those fun quizzes where I'm not expecting anyone to know the exact answers. It's it's multiple choice, and we've put in a couple that are deliberately wrong in each case. And again, we are giving away the first prize winner is gonna get a ticket to NDC Manchester 2020, or to an NDC conference near you if Manchester is not geographically convenient, or you can tune in and watch online, because the future of conferences is very definitely hybrid. It is people in person and it's content being streamed so that everybody can be part of that. And the runners-up are going to win a special limited edition NDC Manchester hoodie. So, we're looking good. I see 55, 57 people. I'm going to keep talking as long as that number keeps going up. Don't forget, by the way, to like the stream and subscribe to the NDC Conferences YouTube channel. We are always putting up videos from our events and promos and all kinds of other stuff. One of the things, all these events we do, all the talks get recorded and they are put up on YouTube for free. If you subscribe, you get notified when new stuff goes up. Great speakers, great content, really good insights. All right, 61, 63, 64. We're going to keep going till we get to 65. Got two more. Two more takers? Can we get 65 people? We got 63 on the stream now. There's someone out there going frantically, I need to get into this, I need to register in this. Looks like 64. We got one more. Austin says, how many of you use MacBooks at work? 66. All right, that is enough. We are going to start the quiz. So, let's kick things off here. What is 1 ether worth in British pounds as of today? Ether is, of course, the currency unit of the Ethereum cryptocurrency, which has got a lot of press lately for reasons that I shan't go into. What is 1 ETH worth in British pounds? It is. Most of you think it's 1,150. It is 1,150. Give or take a little bit of a fluctuation. Let's have a look at the winners after that question. Dan Scott in the lead, 5 seconds to get that right. Simon, Rob, Esben, Chris. Let's have a look at the next question. How many websites are there? There's a company called Netcraft, and every month Netcraft run a massive survey where they do HTTP probes for basically every DNS record and see how many of them are responding to an HTTP GET request. How many websites did they find as of the beginning of March 2021? How many websites do you think there are? The correct answer is 1.2 billion. Which is quite a lot of websites, and most of them are still running PHP and jQuery, which is nice. Let's have a look at the leaderboard, see how that's changed. Dan Scott is holding on to the lead there. Vincent, John, Thomas, Esben, let's have a look at another question here. In what year did the number of mobile devices, so we're talking devices with a data connection, exceed the number of people on Earth? As of today, there's about 8.5 million people on planet Earth, and there's something like 10.8 million data-connected devices. Chewbacca Rampage says the answer is always C. 2 data points is a trend. I am sorry, Chewbacca Rampage. The answer is not always C. It is 2015. Was the year when, according to the International Telecoms Union, there were more data-connected devices than people. Now, of course, that doesn't mean that everybody has a smartphone. It means that some people don't have any smartphones at all, and some people have a lot of smartphones. And people who do front-end user experience design have a box in their house with about 25 different iOS and Android devices, just so they can make sure things work properly. But yeah, it's 2015. We had more connected mobile devices than human beings on this planet, which is just mind-blowing. Dan is holding on to the lead here, which is pretty impressive. Let's see if we can unseat Dan with the next two questions. How many submarine cables are in service worldwide? Events like the one we're running now, all of you who are watching from outside the mainland United Kingdom, all of you are watching this thanks to the wonder of submarine telegraph cables, which carry data and media and video under the sea and connect the whole planet together. But how many of those cables are there in at the moment? The correct answer is there are 426, about 1.2 million kilometers of cable connecting all of the continents on the world. Let's take a look at our leaderboard here. With a change at the top. Dan has knocked down a third place. Thomas and Milosh are up in first. John's still there. Andy is a new entry on the leaderboard. We have one question left to go. Now then, what I want to know is when the Linux kernel was first released, October the 5th, 1991, Linux version 0.0.1, how many lines of code was it? How many lines of code were in the first public release of the Linux kernel just under 20 years ago? 1,200, 10,000, 25,000, or 74,000? The correct answer is 10,239. And let's have a look at the leaderboard. So the top of this leaderboard wins an NDC Conferences ticket. It is Thomas Pisula. Thomas, congratulations. We will be in touch by email to get you a ticket to an NDC event of your choice in the next year. Andy, Milosh, Vincent, Dan, you will be getting limited edition NDC hoodies. We are going to get those. We'll be in touch to sort out shipping details. Mark got 5 out of 5 wrong and is in 66th place out of 66 people. That is impressive. We might need to get a limited edition hoodie for the 0th player as well. So we're going to have one more quiz this afternoon. We got a couple more prizes to be giving away. Don't forget to like and subscribe to our channel here. And now we are going to welcome back to the studio Janani Subbiah. So, Janani, you are going to be talking to us about building friendliness into server-side applications.
That's right.
Cool.
Yep.
You want to start sharing your screen? I'll push the magic button that makes the magic happen. Please, everybody, give a big, warm NDC Manchester welcome, Janani Subbiah.
Hello. All right. Cool. Can everybody see my screen okay? Sounds great. Thanks. All right. Hello, and welcome to my talk. My name is Janani Subbiah, and today we're going to be talking about building friendliness into server-side applications. A little bit about me before we get started. My name is Janani, and I currently work as a product architect for a company called Detroit Labs based in Detroit, Michigan, USA. Most of my experience in the software industry comes from working on some Android apps and mostly building backend services. I love to read and travel, given how last year went, a lot more reading than traveling happened. I'm hoping that there can be a balance between the two of them in the near future. I'm also a new balcony gardener. Again, given how last year went, I spent a lot of time at home. So I started experimenting with growing fruits, vegetables, and herbs from store-bought produce, just trying to figure out what seeds I can germinate at home without having to go to a nursery or a garden center. And it started out as a wonderful experiment and it continues. So I cannot wait for this year's growing season. All right, as far as today's talk goes, I'm going to start us off with why the friendliness, why I'm here giving this talk. Then we'll talk about my top friendly feature picks. And finally, there'll be a conclusion. So on that note, why the friendliness? Why am I here giving this talk today? As mentioned, most of my experience in the software industry comes from building backend services. And that includes building APIs and services for other teams and developers to use, while at the same time also consuming APIs and services built by other developers. In the process, evaluating and using frameworks that help with backend services development. During the course of all this, there have been a lot of times when I felt like a certain feature that's exposed by other service teams have been very useful for me. As the consumer of such services, I find it very useful that that feature is available. It makes my life very easy. And other times, certain frameworks provide certain things out of the box. Might seem very basic at first, but they might be things that are easily overlooked, and they make just building services so much more easy. And other times, I've wanted to flip the table because something is very obvious and basic, but not available or is very hard to implement. So a combination of all these three feelings is why I'm here today, and that is the motivation for my talk. So long story short, today we'll be talking about backend friendly features that help with making a service fun to use. So this is for your consumers. If you're a developer who's building a backend service, this talk will be helpful in understanding how some features that could be incorporated into your service might help people who are using your service. We'll also talk about how some of these features help with making life easy when it comes to building and maintaining backend services. So this is for teams that are actually building those backend services. And the hope is also that these features can be used as evaluation criteria when you're looking at frameworks out there that help with building backend services. And finally, if this is a feature that you think is friendly and useful, but not provided by anybody, then figuring out if that feature is worth investing time in, if your developers are the ones who are going to have to build them ground up. So in today's talk, this is the structure that I have. We'll be talking about backend friendly features. And because a lot of these features are not necessarily baked into the backend, instead they're things which could be other services or tools that help with developing these backend features. These features could be provided by different things. They could be baked into the backend. They could be provided by a framework or another tool that sits right next to the backend and helps with backend services development. So we'll also talk about considerations for such tools, especially if it is not something that's baked into the backend itself. And I also want to talk about why I think that particular feature is a backend friendly feature. So on that note, the first, and I think this is one of the most important ones, especially for backend services, is to have consistent APIs. And APIs here, I'm just talking about REST or HTTP APIs that are going to be exposed to your consumers, not really going to get into the code as much, just because I feel like we could dedicate an entire talk about having consistent APIs in code. So this is just going to be all the HTTP APIs or RESTful APIs that your consumers will be seeing. And at the core of this, in my opinion, is definitely consistent naming. Consistent naming of everything that makes up APIs. And some of the first few things that come to mind are URLs, query path variables, headers, responses, cookies, requests, and anything else that may make up some of these components. Making sure to have everything named consistently helps consumers and also the folks who are actually developing the backend service, because consistency is great. It sets up a pattern that's easier to follow, and it makes using these services very easy. For example, if we were to consider URLs, making sure that you pick a naming strategy and stick to it for all your URLs. Maybe it's camel casing, maybe it's hyphenated, irrespective of which one it is, picking one and sticking to it is very helpful. Similarly for query and path variables, making sure that you have them named consistently, and also ensuring that if there is a similar query or path variable across APIs, all of them have the same name, so that somebody who's looking at a certain query or a path variable immediately know what it's there for. And that applies to everything that makes up requests and responses, and everything that makes up APIs in general, but these are some of the first things that come to mind. So next, let's talk about why I think this is important. The first reason why is because it makes the use of such consistently named APIs more predictable. There is a pattern there. It makes building them and using them very, very predictable. And that in turn will make coding almost second nature. Somebody who's coding to a certain API in a backend service that has already exposed other APIs is going to find it very easy to code to that API if it's consistently named, versus getting frustrated because somebody decided to change the casing all of a sudden and things are now named differently. So that's one of the big wins of having consistent naming in your APIs. The next one is it makes it very easy to follow. And this is applicable to any documentation of the APIs you might have and the actual code itself that actually exposes those APIs. Just taking a look at the documentation and the code, again, becomes almost second nature because there are fewer things between those APIs to keep track of. Because most of the things that are common to them is more predictable. There is a pattern there, and that makes it very easy to follow documentation and code stuff relating to APIs. And finally, no code is set in stone, so is no team. You might have folks join the team and leave the team. And especially if you're on a team where you have people joining the team all the time, having consistent naming of APIs makes onboarding very easy. This is especially for developers who might be joining the backend team itself. It's again easier for them to follow what's going on. Maybe they look at the documentation and they immediately know what to expect in the code. And if everything is named consistently, the code also becomes very easy to follow. So that is consistent naming of APIs. Next, let's talk about consistent error structures. Consistent error structures, in my opinion, are absolutely very, very basic to any API, but they're so easy to miss. And the consequences of missing something like this can be very frustrating, especially for folks who are using your backend service, which is why I think this particular topic deserves its own section. So again, as mentioned earlier, I'll be talking about API errors in particular and not necessarily errors or exceptions that might be thrown within the code base itself. So this is any API error that might be passed back to consumers from your backend service. So it's more consumer facing. The first thing about making sure that your error structures are consistent is to make sure that all the errors from your API are conveyed consistently. And the code here is to make sure that the errors are driven by the errors itself, or the error responses are driven by the errors itself and not the API. Say you're building an application that requires valid credentials before somebody can access a certain API. And say you have a request coming in that either has invalid credentials or no credentials at all. And what you're going to pass back to the service is basically a 401 that stands for unauthorized. making sure that the message that is passed back is consistent across all APIs, meaning doesn't matter which API is being accessed currently, it's always a 401 and it's always the same 401 that's passed back to the consumers is helpful. Again, because consuming those errors on the consumer side becomes really easy. The next one can be a little hard sometimes is to have the same structure for all your errors across all APIs. And this can be hard because maybe you don't want to have the same things conveyed for all your errors. And I think an easy approach to achieving this is probably to take a step back from the code, figure out what different types of errors you want handled, and come up with a structure that works for most of them. Again, this is helpful because it makes using these errors, or rather consuming them, very easy. And finally, really important to make sure that you don't have any duplication, especially among your response components. A good example here is, say, when something goes wrong, you want something conveyed in the response body as well as in the headers, making sure to avoid things like that, because everything goes well so as far as both those values are the same and maybe convey the same message. But having the same information in two different places always opens the door to them diverging. And when that happens, it can be really hard to figure out the source of truth. So the best solution there is to just avoid duplication unless you absolutely need to have it. And if you need to have some form of duplication, making sure that it's always the same. That's just going to be some additional work for the service developers to do. So now, why do I think consistent error structures makes backend services friendly? The first and kind of obvious reason is it makes returning errors very easy. And this is more for the folks on the backend team itself. It's possible to dedicate a centralized section of the code base to error handling that could be used by all APIs. And basically, that's the single place in the code that's going to pass back errors to consumers. Becomes easy to test, and it's this centralized place. So chances of diverging is very less. On the flip side, it also becomes easy for consumers to consume errors, for all past, current, and future APIs. Again, if they can dedicate a section of the code base to consuming these errors, they know that error handling is taken care of for all future consumers if the backend keeps up its promise to make sure that that error structure is going to be consistent across APIs. And finally, similar to consistent naming, this also adds to predictability of the service itself. And especially when things go wrong and there is an error, it makes it almost second nature to code to those errors and really figure out what needs to be displayed to the end user or what needs to be passed to other services that may be using our consumers. So consistent error structures also adds to predictability. The next one is logging. Logging is probably one of those things that's always available, not just for backend services, but also for also on any software application. It's very core to all software applications. And I think it's one of those features that makes backend services very easy to use for anybody using it, including the folks actually working on the service. So today we'll talk about considerations for logging tools. And our considerations here are going to be a combination of things that could be provided by frameworks. And maybe these are things provided by logging aggregation tools. So it's going to be a combination of all those things. The first consideration for a logging tool, and this applies to tools that may be aggregating logs and maybe they have them stored in a certain place, is the ability to search through these logs. And this can be over different criteria. It could be based on an exception. It could be based on a certain time period. It could be based on several other things, depending on the needs of your application. So, but having searchability helps with looking through the logs a lot more easy. The next one, again, depending on what kind of application you're building and what kind of data your app is dealing with, the option to mask sensitive information. So this could include things like credentials or any other sensitive information that shouldn't be exposed to the outside world. Having an option to mask that information from the logs can be another important consideration of a logging tool. The next one is having the option to set different log levels based on the environment. So say you have a development, beta, and a production environment. You probably don't want the same logging level across all of those three environments, just having the option to set different levels for those environments. And this can be something that is provided by the backend itself, doesn't necessarily have to come from the logging tool. But if it does, and even if it doesn't, it's probably an important consideration while just building the backend service as a whole. The next one is very similar to the masking sensitive information, except here you completely want to remove it. So when you mask something, you know the field or you know what came in, you just don't know the value that it held. But when it comes to removing sensitive information, you don't even know what came in. Again, this depends on what kind of application you're building or what kind of data your app is dealing with. Based on that, this could be really helpful. And the last consideration for logging tools, which is also one of my favorites, is to have good formatting options. It can be very hard to go through logs, especially if everything's going to be printed out the same way, sometimes just using the same color. I like to have log formatting, so I like to see all my edit logs in red because I want to stop everything I'm doing and look at what's going on. Similarly, all my debug and info logs can be in green because technically everything's going well. I guess I can make that assumption when everything is in green. Having log formatting can be very helpful and adds to searchability of logs, just easier to consume. Another consideration here, especially if you have your logs aggregated in a certain place, figuring out how you want those logs to be aggregated. Do you want them all in plain text? Do you want them in JSON? And options for actually sending them over to the logs aggregation tool in whatever format you pick can be very helpful. So next, why do I think logging is important? Again, very obvious. It becomes very, very easy to debug your application, especially when something goes wrong, depending on how much of the searchability functionality is provided by the aggregation tool, figuring out, if you can search over a period of time, figuring out if you can search over a certain exception or based off of a certain request that came in, maybe from a particular consumer. All of those things become very easy if you have searching enabled. The next one is, similar to debugging, it also makes it very easy to search. Maybe you just want to search through your logs for certain things. You want to see periodically what's been happening. It doesn't necessarily have to be an error that is obvious to consumers. For cases like that, searching becomes very easy. And finally, I think this is really important. Something doesn't have to go wrong for the logs to be important. And I think security logs are a big example of that. Maybe someone's been trying to access your application in a suspicious way and nothing has really gone wrong, but having those logs still aggregated helps with finding patterns of such suspicious, activity. And it helps to be, proactive and fix things that need to be fixed before things actually go wrong. So it helps with faster feedback even before hell has broken loose. And that's logging. The fourth one we're going to be talking about today is tracing. Tracing is the ability to look at what happens to a request as soon as it originates on, say, a consumer side and comes to your service. Maybe it gets transformed into multiple downstream requests, or maybe there's a response sent back immediately. Just knowing what happens to a request from the time it originates on the consumer side all the way till a response being passed back to the consumer, irrespective of whether that's an error or a success response. So today we're going to be talking about, as far as tracing goes, about considerations for the tracing tool. Well, the tool needs to do what it says it does. It needs to be able to trace a request. So, starting with the consumer, it needs to be able to tell us where that request travels to next, how that request gets transformed, if it gets transformed, how is data collected from multiple sources, how are they combined, who combines them, and how it is passed back to the calling consumer. The next one is, I think most tracing tools do this, provide some form of latency information. So this is basically information about how much time a request spent on a given service. This can be very helpful, especially if you're looking to improve response times or improve the performance of your entire application in general. Tracing tools are maybe optional when you have two or maybe a single service that's serving all requests. When it comes to distributed systems or microservices architecture, tracing tools also, almost become a necessity. It becomes really hard to figure out what's going on and where things are going wrong. So having a tracing tool, especially when you have multiple systems in play, can be very, very helpful and almost a necessity. Having multiple systems or having a microservices architecture adds the necessary abstraction so that consumers don't have to know about exactly what's going on under the hood every time they make a request. And this can be great when everything works well, but when everything doesn't, having a tracing tool can add the necessary amount of transparency to help with figuring out what's going on. And finally, again, one of those features that's mostly provided by most tracing tools is some form of visual representation. And the hope here is that this visual representation is provided out of the box and can be used alongside your backend service itself. Again, based on what your architecture looks like or how many systems are in play, having some form of visual representation makes consuming this information very easy. So that's why visual representations are very helpful for tracing tools. So next, let's get into the whys of having a good tracing tool. It helps pinpoint failures, especially when you have multiple systems in play and there isn't enough transparency around what's going on exactly where. And when things fail, it's important to know what failure has occurred and which service has failed. This can be a little easy if it's a single team that's responsible for all these services. But if you have multiple teams responsible for different services, getting everybody in the same room can be harder than having a tracing tool that has a good visual representation where one look at the tracing tool will tell you exactly what has failed and where it has failed. The next one is related to latency information. Again, if the tracing tool provides latency information, you can be proactive about fixing slower response times. And in general, you can make performance improvements based on which service is currently the slowest in the link. And as mentioned several times, transparency is probably one of the biggest wins of having a tracing tool, especially true if you have a microservices or a distributed architecture where the abstraction of not knowing exactly how a request gets transformed works great. So as far as everything goes well, but when hell breaks loose, it can be helpful to have some amount of transparency, which the tracing tool usually provides. So that's tracing. And next we'll talk about secret storage. Unless you're building an application that all it does is prints hello world, chances are you're going to have at least one secret in your app. And by secrets, I'm referring to anything that should not be exposed to the outside world, anything that's needed by your app for proper functioning. So API keys, credentials, any other keys that might be required by your application, come under the umbrella of secrets. So today we'll talk about considerations for the secret store or considerations for whatever secret management strategy that you're going to pick. And this also could be baked into your application, or it could be mostly a service that lives alongside your application that stores secrets that might be required by your project or app. The first one is to make sure that the secret storage tool provides for good encryption options. This is almost a no-brainer. Your secrets are not going to be stored in plain text. They should not be stored in plain text. So figuring out what kind of encryption options are available and also looking at considerations put forth by OWASP or other security chapters. Making sure that you have options for different key lengths and different algorithms is very helpful. And a lot of this also depends on what kind of app you're building. Maybe it's very sensitive, maybe it's not as sensitive. So figuring out what encryption strategy works for your project is also useful when considering encryption. The next one is security. And when I say security, I'm talking about security around the tool itself, especially if this is another service that lives alongside your backend. So reviewing things like who can access those secrets and how can developers on the team access those secrets if that is a requirement, and figuring out if there is an option to provide some kind of access-based controlled rules around just managing and accessing secrets can be another big one. The next one, which is also one of my favorites, is an option to rotate the keys. And by keys rotation, I'm talking about changing the secrets periodically. So changing the key that encrypts them and making sure to figure out what the decryption key looks like. And this is especially useful because a lot of times this removes developer or any manual intervention. So say you have multiple services in your application and both of them need certain keys to talk to each other. And say all of those keys are stored in the secret storage tool. Developers don't have to go in to update the tool every once in a while or update it when it's compromised. Instead, the secret store itself takes care of changing those values. And because both those services are going to pull that value from the secret store tool, stuff should not break and there should be no downtime technically. Again, because this is a layer of automation, this can be very helpful. Just make sure to pick an optimal amount of time for keys rotation. If it's as long as 10 years, it kind of beats the purpose. Again, it cannot be too short because it's changing constantly. Just figuring out what that balance looks like for your team can be helpful here. And finally, everything works great only if your app can actually access those secrets. So making sure that your application, your backend service, or if you have multiple services, making sure that all of them can access the secret store is also very important. And next, we're going to talk about why this is important. And this is one of my favorite reasons why. Because it's important to stay out of the news for all the wrong reasons. Recently, the news has been flooded with, stories of data breaches and hacks, and with compute times becoming faster, it becomes all the more important to build security into applications and doing that the right way. And I think evaluating and picking a good secret storage tool takes you a step away from being on the news next, which is why I think this is really, really important. It's almost a feature that's necessary versus friendly, but I think it helps people sleep better at night. So in my opinion, it comes under the category of friendly. All right. Next, we're going to be talking about support for API documentation. Again, this doesn't refer to code documentation. I'm specifically talking about a place to document just the APIs exposed by your backend. And again, one of those features that could be baked into the backend itself, depending on what tools are available or what language or framework you've picked, or it could be a standalone tool that sits next to your backend and helps, with documenting APIs. The first consideration I like to think about while evaluating documentation tools is making sure that the tool is OpenAPI compliant. OpenAPI is a standard interface that provides good means to document RESTful and HTTP APIs. So the words used there and all the options provided there are standard, understood not just by developers, but also by computers. And because it's understood by computers, there can be some cool automation on top of documentation that is OpenAPI compliant. And again, because it's a standard interface, it's also mostly understood by most developers. So having a documentation tool that complies to OpenAPI can be very useful. The next one is the tool needs to do what it says it does. It needs to be able to document APIs. And this can look different for different teams. I think a good evaluation strategy here is taking a step back from your code, figuring out what APIs you want documented and figuring out what within those APIs you want documented. Maybe you have a bunch of custom things. Maybe you have a lot of custom headers. Maybe you want to document the schemas of your request and response bodies, including specifying what's required and what's not required. Those are just a few examples. Some apps can have very basic requirements. Maybe CRUD is all they want documented. Some others can, the documentation for some other apps can be more involved. So figuring out what that looks like and figuring out if the documentation tool provides those options can be very helpful and will definitely save you a lot of time down the line. The next one is a very, very nice to have, and I love this as a developer, is the ability to have the documentation automatically regenerated every time there's a code change. So every time there's a code change, especially with regard to APIs, the documentation tool automatically picks it up, regenerates the documentation, and you have a brand new documentation that's exactly up to date with your code. Saves a lot of developer time, and there's always confidence that what's in the documentation tool is exactly what's in the app at all times. So this can be very useful for the backend developers as well as for consumers or anybody else on the team. So now we'll talk about why having a good documentation tool is important. The first, and again, a little obvious one, is it is a central source of truth. It acts as a reference, it acts as a source of truth that people can use to understand what your backend does. Maybe folks don't understand or don't know yet the code that you've coded your backend in. Maybe they're not familiar with the framework. They don't have to know any of those things to actually be able to read this documentation, because technically this is code and frameworks agnostic. So it becomes very, very helpful to have this upfront. And it makes your service very easy to use. Say somebody is evaluating different services and your service is one of the things they're looking at. It becomes very easy for them to actually understand if your service does what they're looking for just by looking at the documentation. And say they pick your service, it also becomes very easy for developers on their side to start coding to your service without having to look at the code of your actual service. They just have to look at the documentation. And so as far as there is an understood promise that the documentation does exactly what it says it does, developers can just use that as the source of truth to start using your service. And if your team's not going to be the one that's going to see a project till its end, or if you have multiple teams working on something, documentation handoff also becomes easy. This also stems from the fact that the only other option to really understanding what your service does in a more structured way is to look at the code. Having documentation that's agnostic of the code can help with handoff. And if you have good documentation set up, this is probably one of the first things that any team that looks to use your service or start developing on top of what you already have is going to look at. And finally, this specifically, or rather, this is more easy when you have open API compliant services. It becomes easy to spin up mock services because open API compliant services could be understood, or documentation that's compliant with open API could be understood by computers too. So you can have automation tools on top of such documentation that spins up mock services, which could be used by your consumers in place of your service. Similar to proxying tools can proxy requests between consumers and your service itself. And it's easier to pass back responses from the proxying tool if there is a solid documentation available. This helps with ensuring that so as far as there is a contract available and it's documented well, and the promise is going to be kept up, development on the backend services side and the consumer side can actually happen parallelly, because you can spin up mock services, or you can use proxying tools for proxying those requests. Again, mock services and proxying tools also could help with error scenarios. Maybe your service is actually not down and you don't want to take down your service so that consumers can test what happens on their side when your service goes down. Having a mock service or a proxying tool, in this case, probably more the proxying tool, can be helpful in testing those error scenarios. So that's documentation. The last one we'll talk about today is using the RFC, which stands for Request for Comment, which is a running document of everything HTTP APIs related, including everything that makes up HTTP APIs. And in the section, we'll talk about how following the RFC and using the RFC as a true source of reference is very helpful in building friendliness into backend services. So as mentioned, the RFC contains a lot of information about everything HTTP APIs related. There are several things in there. Everything's pretty useful. But some of the first things, or rather, there are three first things that come to mind when I think about the RFC and how the RFC is most useful. So those are the three things I want to focus on today. But this is not an exhaustive list. So I would definitely recommend using the RFC as a source of reference for everything HTTP and RESTful APIs related. The first one is headers. Say you've identified the need for a custom header, and say you know what that custom header is going to contain, or what it is supposed to be there for. It's a good idea to go through the RFC to find out, one, if there is a predefined header already available, because chances are other services that you might be talking to would understand those headers better than a custom header that you come up with. And number two, also figuring out if there is a particular naming strategy around headers, again, useful for other services, unless yours is going to be a completely standalone service. Even in that case, I definitely recommend sticking to the RFC. So that's using the RFC as a reference, specifically for headers. The next one is status codes. Again, status codes are probably a little obvious, especially the ones that come from the RFC. 400s for all error scenarios, 500s for all, 400s for all the client error scenarios, 500s for all the server error scenarios, and mostly 200s for the success scenarios. The consequences of getting the status codes mixed up when there is a success is probably lesser, because no one's going to retry, making calls to your service when everything is going well. but the chances of getting the error scenarios can be much worse. And even within those error scenarios, say you've identified a need to have custom status codes. So it is a 400 bad request, but you want to tell the client exactly what went wrong, and say you want to do that actually using custom status codes. Personally, I like it when I guess having no custom status codes is always helpful, and finding other means to actually have that extra information conveyed. But if you absolutely need it, making sure that those don't overlap with predefined RFC status codes can be helpful. So for example, say there's a 400 that's going to be passed back by your service. It is a bad request that came in from the client, and you want to convey something more using custom status codes, or rather custom error status codes. Making sure to not pick something like a 200 is very helpful, because 200 is predefined by the RFC and actually stands for something. In this case, even worse, it actually stands for a success. So it can be very consuming for developers on the consumer side to see a 400 in the response status, but a 200 in, say, the response body. Of course, this can be fixed with documentation, but I don't think it has to be that hard. So picking something that's completely different from the predefined ones can be more helpful and less jarring. And the next one is to make sure to pick the right HTTP verb. So figure out, what your API is doing, and figuring out what HTTP verb closely conveys what it does. Again, one of the big uses of the RFC. So let's talk about why the RFC is very helpful and why we should use it. The first one is it's a central source of truth. It contains all the information that one might need when it comes to building HTTP APIs or consuming them. And it's been around for a really long time. So making use of that central source of truth makes it easier to build more friendly services, because chances are consumers are used to using services which follow the RFC. And because the RFC is very well documented, if somebody has questions around, what something means, and say you're sticking to the RFC, you can just link them out to the RFC and they can go read, what it means, or they can get any additional information from there. The next one is predictability. Again, chances are people are more used to using services that actually use the RFC as a good source of reference. So your service, if it does this as well, is going to be more easy to use for consumers as well as for people building it. And finally, it leads to consistency. And this is consistency across the industry, because the RFC is being used by developers all around the world who are building APIs and consuming APIs. This will ensure that your service is consistent with most of them, so it makes it easier to use as well. And with that, I have reached the end of all my backend friendly feature picks. I want to quickly conclude and talk about all the things we talked about today. We start off with consistent APIs, and the core of it, we talked about consistent naming. We talked about all the different things that need to be named consistently, and we also went into why that's important. Next, we talked about consistent error structures and how having them is very helpful, especially for consumers. Also a little bit for the backend service developers itself in making sure that it's easy to use, fun to build and maintain. Then we talked about logging and tracing more for distributed systems, which currently seems to be the trend. So it almost becomes a necessity. And finally, we talked about why it's good to evaluate and have a good secret storage tool to stay out of the news for all the wrong reasons. And we went into API documentation as well. One of the big considerations that I like to look at when looking at a documentation tool is open API compliance, because it's a standard, it's understood by developers and computers alike. And auto generation of the API, as soon as the code changes, is also something that can be very helpful. And finally, we touched on the RFC, and we just talked about 3 things that I like to especially use the RFC for. Definitely not just those 3 things, but those 3 things would be a good place to start. And on that note, I have reached the end of my talk. Thanks a lot for being here. Thanks a lot for your attention. If you have any questions, feel free to ask away. If you have any questions or feedback come up after my talk, I am Janani_Subbiah on Twitter. So please don't hesitate to reach out, and have a wonderful day ahead.
Fantastic. Thank you, Janani. Let me just
Thank you.
switch our layout back here. You can stop sharing your screen. We have a handful of questions, actually some interesting discussion going on in the YouTube chat there while we've been, let me just tweak, there we go. Yeah, we got some interesting chat going on about sharing data structures. So you talked about the importance of, consistency with error formats and stuff. How do you share those data structures between microservices? Like you got microservice style architecture. How do you share an error structure between your projects?
So I think, again, like I said, sometimes it can be hard, but one of the things I like to do is, take a step back from the code, figure out what kind of error structures are possible between most microservices. Again, if they're all HTTP based, chances are they're going to be, 400s and 500s, and trying to come up with a structure that mostly works for all of them, I think can be the first step. And I think if that is not possible, also looking at who the consumers are. If you have different consumers for your different microservices architecture, and it's taking longer to actually come up with a standard structure, maybe it makes more sense to not have a standard structure there. Again, depending on the trade-off in terms of time and difficulty. Yeah.
How often have you seen, so something that I've seen is when people reinvent the wheel. Like they don't know that something exists in the RFC or the spec, and so they come up with their own way of doing it. How often have you sort of come across that happening in systems you've worked on?
I probably should not put a number to it. But more often than I would like to count, I think it's just mostly it's been good. I also have to say that mostly it's been, using the right, especially with HTTP verbs, it's mostly been good. It can be hard with APIs that do more than one thing, where, you're trying to create something, but at the same time, you're trying to get everything back. That can be hard, but yeah, more often than I would like to count.
Great stuff. So we are going to take a very short break. Head over to our expo.ndcmanchester.com. Fill out your details. We're going to be running the prize draws from those, given away. We got some AirPods. We got some Lego sets, thanks to our friends at Black Marble. The AirPods are from our friends over at Synopsys. And we got some NDC workshop tickets to be given away. Janani said, any questions or anything? Go find her on Twitter. Thank you very much, Janani, for being part of it. Hope to see you back at NDC in person in the not-too-distant future, we all hope. Next up, we have, and I believe that he is on the call with us now. Let me do the thing with the buttons and the layouts and the gallery views and say, can you hear us, Mark Rendle?
I can. Can
Hello,
you hear me?
We can hear you. It's like
then that's an excellent start.
It's the Eurovision Song Conference.
Lights. Lights. Oh God, that one's bright. Help. There we go.
The Eurovision Song Conference, and it is working beautifully. Right, check out the expo, folks. We are gonna have a quick word from our sponsors and partners. Thank you all of them for making NDC conferences happen. While we get set up backstage, we will be back in a few minutes.
At Ivendi, we build technology that makes it easier for dealers to sell and consumers to buy vehicles.
So what Ivendi does is we build a platform that facilitates online retailing. This means that we basically make it easier for people to buy cars and for dealers to sell them. We do this from end to end, so the full journey from consumers coming to the site right through to the finance applications that go through. So to facilitate that, we have really important relationships with banks, with vehicle manufacturers and with vehicle retailers themselves. The tech stack we use is mainly AWS, and we use C#.NET as our predominant backend language, and we use a little bit of Azure as well. We deploy most of the stuff in containers using Kubernetes on EKS, and we're a big fan of event sourcing here. That helps us to separate the domains out into separate areas, which allows us to keep those domains nice and segregated, and also facilitates the auditing, which is a big part of us working in a regulated environment.
I chose Ivendi mainly because of the people. They're very welcoming, they're really knowledgeable and seem really passionate about the technology and the quality of the products that they're creating.
Welcome to Margo. We're an airport-centric travel company owned by MAC, the country's largest airport group. Most importantly, we're a globally unique digital tech business based right here in Manchester. We operate as an innovation hub, a truly agile e-commerce business driven by data and the latest tech to provide airports across the world with a unique blend of products, technologies and services for their passengers. We have become synonymous with airport customer e-commerce platforms, which we're constantly evolving. If you plan to fly again in the near future, you may well use our system without realising that it's actually a Mago product. We're a business for someone who wants to create and do something a bit different. For the techies, we have a fail-fast CI/CD approach using .NET Core at the back, Vue and React at the front, and AWS cloud hosting. We expect to grow our team over the coming year, so please keep an eye on our Mago LinkedIn page for the latest jobs. Thank you.
Hello, Internet, and we are back live here with my good friend and occasional comedy collaborator and all sorts of things, Mr. Mark Rendle. How are you doing, Mark?
I'm doing very well, thank you.
What have you been... so you're going to be talking to us very shortly about a subject I know is very close to your heart, which is
yes.
Migrating things. Tell us a bit more about that.
I'm all about migrating things. Yeah, since Microsoft announced .NET 5, so back in early 2019, I think, and they said the version of .NET Core after 3.1 is going to be .NET 5, and sort of officially going, please stop using .NET 4. anything at all, because we don't want to keep supporting it. And I think, currently the end of life for .NET 4. everything is 2029. And so I've been very keen.
That is a worryingly futuristic sounding year for something which is only 2 Olympics away.
Oh, yes. don't even. And the thing is, the older you get, the faster time goes past. And so, you go, oh, that's not for 8 years yet. And then that 8 years is going to go by in a couple of weeks.
Yeah, when you realize that movies like Blade Runner and Back to the Future 2 are now set in the past.
Yes. Oh, jeez.
Anyway, sorry, you were talking about .NET.
Yeah, .NET. And so I've become very interested in helping people to get themselves off of .NET 4 and onto .NET 5, .NET 6, and all the exciting new stuff. And so I've got my commercial product Visual Recode, which is a Visual Studio plugin that helps you. So it migrates WCF services to gRPC. It helps you just upgrade your projects. So if you've got a class library, you can upgrade it to the new SDK CS-Proj format, and then and dual target it with like NetStandard 2.0 or 2.1 or whatever. But there's a big, and hopefully I'm going to get it to do ASP.NET Web API and possibly even a bit of ASP.NET MVC. It'll help. It won't do it automatically because there's a lot of complexity in there. But there's this one kind of big scary thing sitting there in the middle of all of this, which is web forms. Yeah, there's no sort of automated way to migrate your web forms applications, and you could make one if somebody had built an application using just what was in the box with ASP.NET Web Forms, then you could probably do it. But nobody did that. Everybody used Infragistics or Component One or DevExpress, these huge, complicated control suites. And so, there's no way you can do it. And so, what I'm talking about today is there a way that you can do it manually that your business is going to let you do? Because, you've got hundreds of thousands of lines of blah in your.
So I was actually I was in Romania yesterday in the afternoon. I was in London at lunchtime, and then I was in Romania for the afternoon, and then I was home for the evening. And today I'm in Manchester because
Isn't it marvelous?
We can beam now. We don't need to fly. We just push a button, and there you go. No, I was at Code Camp Romania, and I caught some of Scott Hanselman's presentation there, and he's talking about some migration tools for different APIs that are one of the interesting things that he was saying is the tool, it doesn't just you give it your code and it spits out a bunch of files and a bunch of errors. It kind of goes through step by step, and it says, okay, this is fine, this thing here needs to be replaced with that thing. This thing we don't have a fix for, so we're going to put it on your to-do list.
Yes.
And, I love that idea of a tool that is both a migration assistant, but also it kind of shows you the old way, the new way. I was talking to some folks yesterday. The other event I did yesterday was City.js, which was JavaScripty, and I made the mistake of saying in a conference talk that jQuery is dead. And there are two things you can guarantee about jQuery. If you say we're using jQuery, everybody on Twitter immediately goes, but jQuery's dead. And if you say jQuery's dead, everybody on Twitter immediately goes, no, it's not. There's a new release. But that was to me a really interesting. A compelling framework that was incredibly popular because it fixed a lot of important problems. And now a lot of those problems, kind of the browsers have fixed them behind the scenes and under the hood and stuff. And so looking at the feature parity, there's a bunch of stuff in, reading the browser specs, now you're like, I don't really understand what that does. But if you see the side-by-side, like this is how you did it in jQuery and now this is how you do it. .NET Framework, web forms, WinForms, whatever it is to, something's like, hey, this is how you do it in WinForms, this is how you do it in Maui. That kind of thing I think could be really interesting.
And when I started out with Recode, with the product, I was aiming for just tell me the service contract and I will just generate the entire thing for you. But experience over the last year has taught me that that's just too complicated. And you can't guarantee that you're going to do it out of the box. And if you can't guarantee that you're going to be able to just do it out of the box, it's better to go down that route of I'm an assistant. I'm going to sit here and I'm going to say, right, so tell me which service contract you would like to migrate to gRPC. All right, let's look at what you need to do. So that references these projects, or it uses these types in these projects. And so these projects need to be upgraded. So let's upgrade these projects one at a time to support Net Standard 2.0 or Net 5.0 or whatever it is you're migrating to. And then as we're going along with that, we can say, oh no, you're using ionic.zip is one of my favorites. Everybody used ionic.zip. And there is no net standard version of ionic.zip.
There you go. Everybody watching on the stream, there is your opportunity. We need a net standard API compatible replacement for ionic.zip. Come on, and actually you can do this.
All it needs to be is a shim around the zip library that is now built into .NET, but was not there when ionic.zip was released. But yeah, and you know, almost I really have to resist the temptation to turn it into a Clippy.
Yeah.
and just when in Visual Studio, if you've got the plugin installed and you open a WCF application and go, hey, it looks like you're editing a WCF application. Would you like to migrate it to gRPC?
Surely there's an opportunity there to kind of standardize all of the, you know, the static analysis tools and the migration tools and everything. We just need to come up with a standard format for how they communicate their recommendations, and then you can build your own clients. So we could have a Clippy client, and we could have, you know, something that does it using Lego Mindstorms, and one that does it using Google Home, and all this kind of stuff.
Yes.
We do actually have a question in the chat before we've even started. Mark, tell us about the posters in the background.
The posters in the background are they were commissioned by NASA quite a few years ago, and they are imaginary travel agents photos for destinations throughout the solar system. And so there's Europa and Titan and Enceladus, which are my three favorite moons in the whole solar system.
Team Ganymede or Get Out.
Ganymede's good. Io is also brilliant, the most volcanic moon in the solar system.
Do you know the remarkable thing about Enceladus?
No.
It is the most spherical object in astronomy.
Really?
Yeah.
Is it more spherical than Europa?
Yeah. Enceladus is basically, the surface is ice. And it is ice that occasionally melts because of gravitationally induced heat and then refreezes very quickly. So if you put a mountain on Enceladus, it'll be gone in the morning.
That's brilliant.
And it is the most spherical object that astronomers have found anywhere, which I think is brilliant.
That is cool.
Yeah. And it's got a little hexagon on the bottom that looks like an engine, but we won't go into that.
Yes. But no, Europa's quite rough. Got lots of crags and stuff because it's so close to Jupiter and it gets ripped apart and freezes back together so often. Titan, actually, it was on this day in 1655 that Christian Huygens discovered Titan.
Well, there you go.
And Titan is a brilliant moon because it's 2.5 times smaller than Earth, which means that gravity is only 13%. So if you were on Titan, you could probably jump 10 meters straight up into the air and you wouldn't hurt yourself when you came down. But also, even better, the atmosphere is 3 to 4 times thicker than the atmosphere on Earth, which means if you just made yourself a pair of cardboard wings, you could fly on Titan just by flapping your arms.
That's fantastic.
Except you would also freeze because it's minus 150 Celsius, and what looks like water is actually methane.
You'd need a suit, obviously.
You would.
But you could paint it in cool colors and fly around. Did you ever see the XKCD thing about getting into orbit from the moons of Mars?
Yes.
On Phobos, you can jump into orbit, and on Deimos, you'd need a BMX.
Yes. I learned so much about the solar system from XKCD.
It's brilliant. For those of you not seen it, xkcd.com, Randall Munro does these wonderful little cartoons about science and mathematics and machines and information theory, and they're absolutely brilliant. But anyway, I make it 1:15, which means the agenda says it is time to learn all about migrating things from .NET old versions to .NET new versions. So I am going to queue up the layout. If you want to start sharing your screen.
I'm going to share my screen.
I will punch the button.
There we go.
The stage is yours, Mr. Rendle.
Thank you very much. It is fantastic to be here in Manchester. Thank you very much for hosting. It's a beautiful city. I did actually live in Manchester for 18 months when I was 18 or 19, back when the Hacienda was still open. Well, it's not. I didn't live in Manchester. I lived in Salford, which is in the middle of Manchester, but isn't in Manchester. It's in Lancashire, and it's surrounded by Manchester. And then there's more Lancashire. It's weird. It's like a little donut. But yes, I'm going to talk to you about migrating your web apps to ASP.NET Core one page at a time. I am Mark Rendle. You can follow me on Twitter at Mark Rendle, and you can watch me on Twitch on Tuesdays and Thursdays at twitch.tv/Mark Rendle. So why do you want to migrate your web apps and specifically your ASP.NET Web Forms apps to .NET 5 and .NET 6 and beyond? Basically because this ASP.NET Web Forms in 2021 is a dumpster fire on so many levels. It's a really shonky model for building web applications that was designed to hide the fact that you were building a web application, so you didn't have to worry about things like HTTP and browsers and even HTML to a certain extent. It's not going to be supported in any meaningful way from now on. Microsoft will continue to sort of issue security patches and things. But also because if you have an ASP.NET Web Forms application that you are maintaining in 2021, I would, in a sort of large spread betting, hedging kind of way, I would bet good money that it is an absolute dumpster fire just in terms of the code that's inside it. Yes, not all web forms, and that's why I would do a spread bet, because there are web forms applications out there that are beautifully coded, beautifully architected, well structured, using best practices. I've never seen one, but they are out there. What I have seen would just turn your hair white. Like that's why his hair was white in the movie, because he'd seen things you people wouldn't believe. I've seen if statements on fire off the shoulder of Orion. I saw an if statement in a web forms application recently that had over 400 OR clauses in a single if statement, and they were comparing a string to a pre-defined, is it one of these strings? And so all the strings they were comparing against were lowercase. And in every single one of those OR clauses, they called .trim .toLower on the string. So potentially, if it matched the last one, they created 800 strings by the time they got to the end of that, which is just a garbage collection nightmare. Web forms made it very, very easy for bad programmers to create applications. And that meant that a lot of bad programmers created applications using web forms, which means that there is a lot of bad code out there hiding in web forms applications. So I've convinced you. What do we want to move to? Well, we want to move to ASP.NET Core, because ASP.NET Core is brilliant. Why is it brilliant? Well, it runs on Linux for a start, which means you're not paying licenses for your hosting environment, and you can run in containers, in Kubernetes clusters and Docker containers and Azure container instances and whatever Google and Amazon's equivalent of Azure container instances are, which is just, that's what you want to be doing in this day and age. It's stupid fast. It is ridiculously fast. There's a thing called the Tech Empower benchmarks, and ASP.NET Core, when it started out, was not doing particularly well, but it has been optimized. The Kestrel web server has been optimized beyond all belief. It does amazing things. Scary, scary code in there. So it is stupid fast. And the key thing about that is that if your web server is fast, if the framework you're running on is fast, it means you can serve more requests per second on a single machine. And if you can serve more requests per second on a single machine, then you can run fewer or smaller machines, which actually saves you money in terms of your hosting costs. So that's good too. And ASP.NET Core is actively developed. There are a bunch of Microsoft's best people working on ASP.NET Core, and there's a bunch of highly motivated open source contributors from the wider community who are putting stuff in there. And so ASP.NET Core continues to grow, continues to improve. So you want to move your web forms code into ASP.NET Core, but there is a problem. Web forms is not supported in .NET Core or .NET 5.0, so you can't start running on that and then gradually migrate over. But more importantly, ASP.NET Core, since version 2.1 was released, I think, doesn't run on .NET 4 anymore. Certainly the currently supported, the LTS version, NetCore 3.1, and later do not run on .NET 4. So you can't do a gradual migration. And I don't know if you've ever gone to your business and said, hey, you know the 500,000 lines of code in our application. Well, the thing that those 500,000 lines of code are written in isn't very good anymore and isn't supported anymore. So what we'd like to do is stop working on new features and supporting our customers and just rewrite the whole thing in the new thing that's much better. And the business says, how long will that take? And you say, well, if you give me a team of 6 people, it'll take a year and a half. And they say, what if we give you a team of 12 people? And you say, then it will never get done because man-months. So you want a gradual migration process. So one existing solution to this, there is an open source-ish thing out there, but also not, with pricing on its website, called .vvm, which is a kind of, it's like a modernized version of web forms that uses the MVVM pattern. And that runs in both .NET 4 and NetCore 3.1 and Net 5.0. And so you can migrate gradually across, and they do actually talk about this on their website. They say you can modernize on the fly. So you can, while you're still running in ASP.NET 4, you can migrate your pages one page at a time to .vvm. And then once they're all done, you can just take your .vvm code and say, now it runs on .NET 5. And we can throw away half of our servers because it's so much faster and better. So that is one option, which I'm not going to be talking about because I have another solution. So I was bumbling my way around the internet a few months ago, and I came across a project from Microsoft called YARP, which stands for Yet Another Reverse Proxy. And it's a reverse proxy like Nginx or Traffic or HA proxy or any of those things. But this one is written in .NET, and it's an ASP.NET Core application. And actually, it's not even an ASP.NET Core application. It's an ASP.NET Core NuGet package that you drag into your ASP.NET Core application, and then you just add it to your pipeline. So you can drag that in there. And I was looking at this, and I had one of those moments. And I thought, hang on a minute, lads, I've got a great idea. What if you put that proxy package into an actual ASP.NET Core application that had pages and controllers and views and all that sort of stuff? And then if the new application had the address that the browser was looking for, then it would serve it from within itself. And if it didn't, it would just proxy it back through to a web forms application running behind it. So yeah, in this PowerPoint, clip art, smart text, whatever the hell this is, slide that I've made, because I don't do pictures. I find pictures on Google Images and I use built-in things in PowerPoint. But yeah, and I thought, I wonder if this would work. And so I started looking into it. And then it turned out that this is a pattern an official pattern, and it's only an official pattern if Martin Fowler has written about it on his Blicky. Everybody knows that. And Martin Fowler coined this as a pattern and called it Strangler Fig. Actually, he initially called it Strangler. And then people went, great pattern. Kind of not good on the name though, Martin. Call it something else. And so he called it Strangler Fig because his inspiration was the Strangler Fig plants, banyan trees and things like that. These seeds that actually they take root and germinate in the branches of other trees, and then their roots grow down into the ground, and then they throttle and kill the tree that they were growing around. So yes, that's where that comes from. And so I decided I was going to have a go at building this, and at the same time I decided that I'm so important and fascinating that people will surely want to just watch me do things on the internet. And so I started Twitch streaming, and so I combined the two things, and I went, I'm going to build this on my Twitch channel and people can come along and watch, and that's been happening, and it's been quite good fun. So let's do a quick demo. Does anybody remember Wingtip Toys? Wingtip Toys was a demo application. I'm going to run Wingtip Toys here. It was an ASP.NET Web Forms demo application from years and years and years back. And as soon as this page loads, you'll go, wow, that really was years and years back. Come on, page, load. See, I told you Web Forms was slow. This is a very powerful PC I'm using here. So yes, this is Wingtip Toys, and this is an ASP.NET Web Forms application, and to sort of date it for you, it's using Bootstrap 3, and I think we're currently on Bootstrap 5. So yes, it's a few years old, but Wingtip Toys, it's got cars and planes and boats, and it's got a shopping cart, and I can add that to my cart, and then we've got one thing in the cart, and various other things are going on there. And so I thought, I'm going to use this, and I'm going to try and replace one thing at a time, and we'll see if we can get that to work. And so I started out with MVC and Razor. Why have you got missing dependencies? Don't do that to me. Microsoft.reverse proxy needs upgrading. No, it doesn't. Let's just go into here, and I'm going to take that out, and then we should be okay. So yes, what I'm showing you is kind of the end result here, because I'm not going to do live coding. We've only got 45 minutes for this talk, and that is not enough time. But this is an MVC application. And so my Wingtip Toys example page here, we have a site.master. And site.master is our it's what ASP.NET Web Forms used to have instead of a layout.cs HTML. And so this is our kind of base site here, where we've got script references and lots of run at servers and all that sort of stuff there. And so in my my Cocoon application, I went with Cocoon as a name because Strangler is just nasty. In my layout.cs HTML, I basically copied everything across, and I downgraded my shiny new .NET 5 Razor application to use Bootstrap 3, and copied over the CSS and JavaScript files from the old Web Forms application. And so I created this. And then I went in and in my home controller, I added an index thing here, and I added my view here, which does this. And so when I run this application, you will see, he said confidently, that an error occurred while processing the request because my connection string is wrong in this version of the application. And let's try that again. It's not a proper demo if it doesn't crash first time. There we go. So that's running over there. So, I mean, localhost 24019 at the moment. And if I go to localhost 5001, you can see that I've got my slightly broken homepage from my Wingtip Toys 2. So the default page is Wingtip Toys, and where I've replaced the page, I've changed it to Wingtip Toys 2. So this is my my ASP.NET Core 5.0 application. But if I go to About, this just proxies back through to the, actually, no, that is, I struggle to remember. Okay, so this is, yeah, here we go. The About page is coming from the same place, from the old server, and the products page is coming from the old server, but the home page is coming from the new server. So if I go into products on here, and then I go add to cart, and you see we've got two things in my cart there, and I go back here, my cart item here is not showing up for reasons. So this works very nicely, and I thought, I think I'm onto something here, and I think this could help a lot of people out. And so I started thinking through the sort of additional issues, and I'm actually working on web forms applications during the day at the moment on my consultancy work. And tragically, I am working on maintaining and supporting legacy web forms applications, because you can't, replacing them is so difficult. But I have been exposed to a lot of web form stuff. And one thing that I've noticed happens a lot in web form applications, one thing that is used a huge amount is session. Web forms applications love session. They love session and they love view state. And if a web forms application wants to, if a web forms page wants to redirect to another web forms page and pass a parameter while it does it, it won't do that by adding a query string to the URL for the page that it's going to pass to. No, it will put the parameter into session, and then it will just redirect to the other page, and then the other page will load and get it out of session. Session's very, very important. And so if you're going to gradually migrate a page at a time from an old web forms application to a new core application, you need a way for them to be able to share session and work on the same session state. And so the first thing that I implemented in my specialized proxy for this was a way to share session. And on the server side, it's really weird. Both these things are servers. So when I say backend, I'm talking about the web forms application. And when I say front end, I'm talking about the ASP.NET Core application, even though it's not front end in the sense that it's not a SPA, it's not an Angular application or anything like, or React or anything like that. So in the backend application, we add in a session API handler. And we drop it in as an API handler so that it can be distributed as a NuGet package. And it implements IHTTP handler, and you just pass it a get and the key for the value that you want, or a put, so you can update session as well. And it shares the session. And then from the other side, from the Cocoon application or the front end application, we have Recode Cocoon proxy, and we have a session provider in here. And this is not, it does not integrate with the built-in session in ASP.NET Core, because the built-in session in ASP.NET Core is much better behaved. It does not allow you to say, hey, can you just put this enormous object graph into session for me, please? Because that doesn't scale. And another thing you see a lot with web forms applications is that they have sticky session or sticky routing. So in the rare case where they are actually running multiple instances of their server for redundancy and failover, they use in-memory session storage so that they can dump huge object graphs that won't serialize into them. And then they just make sure that each client gets sticky rooted to the same server every time they make a request so that their session stays intact. ASP.NET Core doesn't do any of that. And the only thing you can put into session or get out of session in ASP.NET Core is a byte array. And that's right and good, and that is how it should be. So what the Cocoon session provider does is it just provides its own session implementation that you can register with dependency injection and pass stuff around, and it will cache values over the course of a request. So if you call session.getValue multiple times, it won't keep going to the backend server. And then when the request ends and the scoped session object is disposed, it updates the backend server with all those bits of information. Oh, and it has this brilliant, this is interned numbers from 0 to 9, because when you're setting tags in diagnostics and things, and you want to do a count, you want to put a count on something, then if you just go, oh, I've got an integer, so I've created my integer, and now I'm going to put it on in this dictionary of string object, and so you'll box that integer. And if you end up doing that a lot, then you do a lot of allocatey things, which is bad. So this is just a general tip. If you have a situation where you are constantly boxing an integer and you have a constrained range of integers that it could be, then just once create a static read-only object array with those integers in it, and then index into that array, and you will not need to box integers repeatedly. See, this is the kind of thing that starts to matter when you're doing ASP.NET Core coding, because performance is king and everything's so fast and you don't want to slow it down. Didn't matter at all in web forms applications. You know, in web forms applications, we just box a few integers just to keep the CPU busy while we were doing something else, because we just didn't care. So yes, this is the session wrapper here. And so this gets passed around, and then somewhere hiding in my MVC Cocoon application, I've got a tag helper, and I've got a cart link tag helper here, which gets a shopping cart injected into it. And my shopping cart is in my service thing here. And this gets Cocoon session injected. And then when I want to get the count of how many items are in the cart, we go to get count async, and then we say session.getAsync cart ID, and that returns back the cart ID that's set in the session on the other side. But what the session provider is actually doing, the Cocoon session client, is it's copying across any cookies that have been set by the backend application in its call, so that session on the back end just works magically. Didn't have to do anything clever there at all. And so that handles session. And I think session will start to work if I log in. So if I log in, this takes me back. I don't want to use any of those, thank you. This is now the back-end application. You can see we've got our cart2 there. And if I log in as admin, and the password on this is p@ $WORD. Nope. p a $WORD. Yes, there we go. So now I'm back onto my homepage there, and my cart tag helper has stopped working. Why is my cart tag helper not there? What is wrong with you? Views, shared, layout. That's my cart link there. That should be working. I don't know why that's not working. I'm not going to go in and debug it now. Trust me, it works. most of the time it's just stopped in this particular instance. I'm actively working on this on a sort of every other day basis, and so stuff does sometimes break. Trust me, session works. It absolutely does, I promise. So that was the session side of things dealt with. So the ASP.NET Core app doesn't do session itself, it just passes back through to the Web Forms app. And the idea is that once your Web Forms app has been completely strangled and has died, and you go to your ASP.NET Core app, you implement an alternative version of the session provider that probably does wrap over ASP.NET Core session and takes care of serializing and deserializing objects in that way. One more thing about that. So the session serialization is handled by message pack, because binary object serializer or binary formatting serializer, binary formatter, whatever it's called, is bad. And you shouldn't use it, and it's a security nightmare, and it's being deprecated. Don't use it. And so technically it's in .NET 5, but they are talking about putting the deprecated or obsolete attribute on it at any point. And so it uses message pack serialization to pass things backwards and forwards. So that's how session is handled. And so apart from session, the other thing that you need to be able to share between the two applications, as we just saw, is authentication. And again, the easiest way to do this, because Lord only knows how web forms applications authenticate themselves. It was Windows authentication or Kerberos authentication or whatever it was. The easiest way to get this working is just to leave the login page on the old web form server and let it do the login and set the cookies that it's doing and all this sort of stuff. And then in the ASP.NET Core application, for authentication, just ping a message to the backend server and go, hello, are we authenticated? Who are we authenticated as? Give me all the information. And so to achieve that, I wrote an authentication handler. And again, on the back end, there is an auth API handler. And this basically says, if the context user is a claims principal, because let's hope it is, if it's a Windows principal, then somebody's going to open an issue on the GitHub repository for this and say, I'm using Windows principals and they don't serialize properly, and I'll see if I can fix it. But if it's a claims principal, we can say, is it authenticated? And if they're not, we just return a 401, which is fine. And if it is, then we serialize the claims principal. That was fun. Have you ever tried serializing the claims principal? It's not designed to be serialized. A claims principal contains a claims identity, which has a reference to the claims principal. And the claims identity has a collection of claims, each of which has a reference to the claims identity, which has a reference to the claim, which has a reference to the claims identity, which has a reference to the claims principal, which has a reference to the claims identity. And any sort of out-of-the-box serializer will just go and die. So I wrote custom claims principal serialization, again using message pack, which is a superb format and I love it a lot. And so the front end says to the back end, hello, are we authenticated? And if the back end is authenticated, it says, yes, we are. And then that means that in the front end application, so if I go, if I log in here, and I log in as admin and $WORD. If I go to admin in here, you will see that this is a terrible, terrible web forms page. And there's no kind of list of the things that are in the database. And you just have this add product and you can remove a product by choosing it from this. It's just, it's not good. And so we can rewrite this admin page as a lovely sort of proper modern style web application, and we can have an add a new product thing that goes to this lovely page here, and then we click submit, and all sorts of good things happen. And so that's sort of the basic principle behind what I'm talking about here. And the thing that I really like about it is that it is primarily, and its inception was for upgrading web forms applications. But as long as you can write the necessary back-end services, so as long as you can write the equivalent of the session API handler and the auth API handler, you could use this to upgrade anything. You could use this to upgrade a classic ASP application, as long as you can find a way of doing message pack serialization in VB script. But you know, you could wrap the message pack serialization in an ActiveX object or whatever it was we used to do in classic ASP. You could use this to upgrade a PHP application, although you could also just run your PHP application on .NET Core using PeachPy. But yes, you could use it to upgrade a Perl CGI application that was written in 1996. The possibilities are endless. And then, so having kind of proved this out and gone, yeah, no, this would work and this is entirely feasible, people who were watching on the Twitch stream started saying, well, what about Blazor? Because when Microsoft said no more web forms, that we are not supporting web forms, it's a bad product and you're a bad person for liking it, they said, what we recommend instead is Blazor. And I hadn't really mucked about with Blazor until somebody started asking about it in here. That punctuation thing at the end there is an interrobang, by the way, and it's absolutely my favorite punctuation character. It's an exclamation mark and a question mark in the same character, because I just have no idea which way round they're supposed to go if you use both of them. So we started looking into Blazor, because Blazor is actually, it's easier to write Blazor applications than it is to write Razor pages or model view controller applications. Blazor, once I started playing with it, and I was very, very privileged in that, because my first ever experience with Blazor happened on a Twitch stream, and I tweeted about it and got retweeted. And Steve Sanderson actually turned up in my Twitch stream and watched as I learned Blazor for the first time, and was going, press Shift and Alt and F12. It was great. But no, Blazor is really the ideal thing for migrating a web forms application to. And there's a brilliant project by Jeff Fritz and people called Blazor Web Forms Components, where they are re-implementing the sort of fundamental web forms components like repeater view and add rotator and all those things as Blazor components to make it easier. And they've got a migration guide on their site. And I'm hoping to sort of talk to Jeff and these people and say, hey, can we sort of mention Cocoon in here? Because Cocoon will quite happily work with a Blazor application as well. So let's start out, let's look at Blazor WebAssembly first. So this is a Blazor WebAssembly application. And here's my Blazor Cocoon server. And so in here, we basically just say, so this is how we're setting it up in ASP.NET Core. We add Cocoon session, we add scopes, shopping cart, we add controllers with views and Razor pages and Cocoon proxy, and DB context pool. Oh, this is another interesting thing actually. So the Wingtip Toys application uses Entity Framework, and I was a bit worried about that, but I copied the Wingtip Toys context across, and this is using Entity Framework Core 5.0, and I pretty much just copied it across, and it works with the same database. The syntax for calling it is slightly different, but it essentially just worked. I didn't really have to do much mucking about with that at all. But yes, and then in our configure method here, we have use authentication and authorization, and we have use endpoints and map Cocoon proxy with Blazor, because there was a weird thing to do with routing. But if I run this application, So this is Blazor WebAssembly. And this there you go. If you can see that this is the WebAssembly application running in the browser. And if I click this, this has fallen back through to the old Wingtip Toys site as before. And if I click login, then I can log in here as admin and PA $WORD and hit login. Nope, don't want to save that. And now, okay, so now the session's actually working here. Once I'd logged in, session did actually start throwing me, because the admin user, I've logged in as him a lot, and the shopping cart gets saved in the database. And the only thing, yes, the session ID becomes consistent. So I can see my cart there. That'll take me into the web forms applications. But if I go into admin, you saw the little loading thing there, which is the giveaway that this is a Blazor WebAssembly application. And I pretty much just copied the Razor stuff across from the MVC application. But this is a Blazor admin page for our ASP.NET Web Forms application. And yeah, everything in here works in just the same way. And I have to say, I was a little bit skeptical about Blazor when I first heard about it, and it wasn't that I thought it was bad. It's that a lot of people were going, "Oh, this is the best thing since sliced bread. This is the savior of the internet." And I thought, it can't be that good, can it? But actually, since I've started mucking about with it, yes, it can. It really can. There's a lot of good stuff to say about Blazor. Let me just drop into that admin page. So we've got our pages here and our admin.razor page here. And I'm just going to run. I know that Steve Sanderson, I think Steve Sanderson did, or somebody did a Blazor talk earlier. But yes, so there's my HTML in there, and we say if products is null, then just show loading, otherwise render this table thing here. And then we have this on initialized async. And so I had to add an API to my server application. So I've got my admin controller here, which has got a API admin products, and then that's pulling stuff through, because this is Blazor WASM, which means we can no longer just do talk directly to entity framework. But yes, you just do this and you say products equals await get JSON from async, and then you say products equals products.order by to array, and then that magically sort of triggers something to change up here in the sort of way that Angular and React and things do, and it re-renders the page. And that's just super, super awesome. And so, yeah, the only, there's a custom thing in here called Cocoon Authentication, which is a custom Blazor authentication component that makes an API call to the new front ends, to the Cocoon server, the Cocoon front-end server, which does the same thing and goes to the back-end server to check if we're authenticated, and then returns the information back down here. So you get the claims principal comes down to your Cocoon client. And so that was good. That worked perfectly. And so that was Blazor WASM dealt with. And then I thought, well, what about Blazor server? Because there are still a couple of issues with Blazor WASM. The big one being it's like a 5 megabyte download the first time you hit a Blazor page, because what I don't think I'd appreciated, I thought Blazor WASM, in my head, it was that you wrote an ASP.NET Core MVC application and it compiled a bunch of it to JavaScript and then threw that down into your site. But that's not what it does. They've compiled like the whole of .NET into WASM, and then it actually downloads net standard assemblies into your browser and runs them on a .NET runtime. That's what it, and that is nuts. That is absolutely nuts. One experiment I'm planning on doing soon is the Microsoft OpenXML package for working with Office documents has a net standard build. And so I'm going to see if I can make a Blazor application which can open an Excel spreadsheet in the browser without ever having to upload it to the server, just as an experiment. Going to do that on Twitch one day soon. It'll be on Twitter when I decide to do it. But that big download for a public-facing website, especially a public-facing website going, hey, buy my fancy new slippers that are made out of lucite and electricity. You want that to load very, very quickly. Otherwise, people are going to go and buy their lucite electric slippers from somewhere else. And so you might want to do something that loads a little bit faster. And you can't actually get something that loads much faster than Blazor server, because what that does is it renders the first page on the server and then throws it down to the client. So it's just a static HTML page, and it's got a tiny little bit of JavaScript that goes down with it, tiny, especially compared to things like Angular's runtime or even the React runtime. And then it has a WebSockets connection, and the application runs on the back end, on the server, and it just sends tiny little like diffs down over the WebSocket to the browser going, hey, change that, change that. So it's doing the sort of like the shadow DOM, the virtual DOM, whatever that DOM thing is that React invented. It's doing that, but it's doing it over a WebSocket. And that's really exciting because that makes for super fast pages, but still being able to write all your complex business logic in C# instead of having to try and translate it into TypeScript and then worry about Angular's dependency injection system or React's general awfulness and Redux and things of that nature. And so can I get it to work with Blazor server? And actually, it's pretty much the same thing, except instead of having two applications, I've got one because Blazor server runs all in one thing. And the only thing that was really funky about it was handling the routing, because Blazor server just wanted to handle everything. It did not want to proxy anything at all. And so we had to put in a thing that said, use explicit Blazor routes. And so this finds out what all the Blazor routes are, and you pass in type of program, so it'll find all the routes in here, and then it just uses those. And so now we have the same thing with Cocoon, but running in Blazor server mode. And you can see actually we're still logged in now. We're still logged in from the Blazor WASM application because the thing was still set. And we've got our admin page, which is done in Blazor server. And you can see how fast things load in this now. But I can still go back through, and this is the old web forms page at the back end. And so there you go. This is my master plan for getting everybody, including you lucky, lucky person, off of the horrible web forms or the horrible classic ASP or the horrible whatever it is you've got running on the back end. And if you have got classic ASP and you'd like to look into this, then drop by the GitHub repository and say so, and we can look at building some classic ASP components to make the authentication and session work. If you want more information on it, then you can get that from github.com/visualrecode/cocoon. So I should say that yes, this is it's kind of branded with Visual Recode, which is a commercial product, but it is not a commercial product. It is fully open source and Apache licensed to, and out there on the internet, and not tied to Visual Recode in any way. Although Visual Recode might support it, it will never require Visual Recode. All the packages are published, and in summary, It's based on Microsoft's excellent work with Microsoft Reverse Proxy, aka YARP. That's the GitHub thing. That's me on Twitter and on Twitch. Come join me on Twitch Tuesday and Thursday evening, 7 p.m. UK time, where I work on Cocoon. And when I'm done with Cocoon, I might try and make Simple Data 3 using source generators. You never know. We'll see what happens. Thanks very much for joining me, NDC Manchester. I hope that was helpful and fun. And I will see you hopefully in real Manchester next year. And we can drink Boddingtons and sing songs and make friends with people we've never met before, because Manchester's brilliant. Thanks very much. Bye.
You want to stop sharing your screen, Mark? Thank you very much, Mr. Rendle. If you'd like to stop sharing your screen. Now, we have an entire .NET Rocks show waiting here in the studio. If I switch to the gallery view, there we go. Look at that. We have a veritable rogues gallery, including, I think you can see me in the corner of my own screen there. Hello, everybody. That's what I really look like right now. How are you all doing? So, we got one question for you, Mark, in the chat, which is from me, but I'm going to ask anyway because it's my question. Do you think that we are going to see any legacy apps that they just figure out how to recompile them straight to WebAssembly? Instead of the whole take the legacy and port that to core, and then the core runs on Blazor, and then Blazor runs in the browser, do you think we're going to see like I don't know, web forms direct to WebAssembly so you can run it in a browser?
I did actually. This is way beyond my ability to investigate, but Blazor's .NET runtime in WASM is based on Mono, and Mono did have an implementation of web forms. And so I am wondering if you could just take Mono's implementation of web forms, which isn't dependent on all the Windows stuff like the ASP.NET web forms is. But yes, just take the web forms from Mono and throw it into the browser and just run all those controls and things that run at server now just run at WASM instead.
I have something to add to that if I can, Mark.
Yeah, go for it.
All right, so in .NET 6 timeframe, Blazor WASM will be using ahead of time compiling, which does what you're saying. It really compiles everything directly to WebAssembly before it goes down to WebAssembly. So you'll have the disadvantage, it won't be in a runtime, but you'll have the advantage of speed. And also today in .NET 5, you can use pre-rendering in Blazor WebAssembly, just like you can in Blazor Server. So that speeds things up. And also lazy loading. So that's there are ways, and it is getting faster, but I think in .NET 6, stuff will just become much faster.
Yeah. And my aim with Cocoon is to have it sort of battle ready for the .NET 6 timeframe, so that there are beta packages at the moment.
Nice.
But yeah, I'm really going to start pushing this when .NET 6 comes along, and Blazor WASM is, you're right.
Yeah,
it is going to,
I can't wait.
It's going to light up so nicely.
Great presentation. I enjoyed it.
Thank you.
So we got a question in the YouTube chat. Steve Collins says, "Hi Mark, any gotchas with both Cocoon pages and web forms pages sharing cookies?"
No, there's also a cookie. So if you're doing weird encrypted cookie things, then there is a thing that will do a pass through on a cookie to decrypt it from the back end. But for the most part, if you're not encrypting your cookies or using that sort of security stuff, it's fine, because it's not like a JavaScript front end thing where you might have HTTP only cookies that JavaScript can't see. Proxies always have access to the entire HTTP request and response. The only thing that there was a bit of weirdness with was when the backend server did redirects, the location header included the domain, including the port. And so I've put in a little thing that just checks the response, and if the location header mentions the sort of absolute URL, then it changes it to point to the same address but on the proxy server. But no, I haven't run into any issues with cookies other than those things.
So there you go. Are there any gotchas? No. Nice answer.
was a very
Bruce
long
Lane
way of
says,
saying no.
Shall I use
I think-
Cocoon or MSAL for a new Blazor project? He says, I've got a tenant and Azure.
Cocoon is, if you've got a back end thing that you want to migrate, Cocoon is a brilliant way to do it gradually, one page at a time. And yeah, but if you're just building a completely new application, then just build it in Blazor. And the really nice thing with Blazor, start building it if you want to use server now, because in .NET 5, the WASM stuff's a bit slow. That's the build time. There's quite a lot of interpreting going on in the browser. Then you can run it on server for the time being. And then it's pretty straightforward to migrate that to Blazor WASM when .NET 6 comes out. But yes, absolutely. If you want to migrate something, if you've got a website, even if it's ASP.NET MVC, and it's nicely crafted and everything, but you want to migrate it to Blazor, then you can use Cocoon to do it one page at a time with no downtime.
Fantastic. Thank you very much. One last question. Andy Clark, does it need special config to handle TLS/HTTPS?
No, it's just whatever the config is for an ASP.NET Core application. So your backend server, you would hide from the public internet, so that would no longer be available. And you would turn off TLS on your backend server, I would imagine. Or if they're running on the, you could leave it on. But yes, so the proxy, the Cocoon, the new front-end application would essentially act as an SSL termination point before hitting the back-end server. So there are no issues there.
Fantastic. All right. Very shortly, we are going to be handing over the virtual stage here to close out NDC Manchester 2021 with Carl and Richard doing a special live edition of .NET Rocks with Ian Cooper talking about test-driven development. But before we do that, we have some prizes that we have failed to give away thus far. We got a couple of things left in the NDC swag bag here. And so we are going to run the last of today's live quizzes. Head on over to slido.com/NDCMCR, or the code NDCMCR, and we are going to give away, we got one more live quiz for you here, then we're going to do some draws, so head over to expo.ndcmanchester.com if you haven't entered yet. We're going to be drawing the prizes for those in a few moments. So we got one more rapid fire quiz for you, 5 questions, multiple choice to win a NDC conferences or workshop ticket, and the special limited edition NDC hoodies. We got some of those coming up for you as well. So just give it a minute, let folks get signed up for that. Now this round is all about NDC. It is testing your knowledge out there of this wonderful series of events that started out in, I'm not going to tell you because it might give away the answer to one of the questions, and has been, growing internationally over the years, this wonderful worldwide community of speakers and experts and enthusiasts and people who just love getting together and going, hey, look what I made the computer do, isn't that awesome? And then some of us take it away and figure out how to get paid for it, which is brilliant. And so let's kick off the final quiz. So first prize is an NDC conference or workshop ticket. We got a couple of hoodies for the runners-up. We are going to kick off the quiz here. So what year was the first NDC conference held? Was it held in 1988? Days of C++, 1998, the days of Visual Basic, 2008, glory days of C# and .NET 3.5, or 2018 when it was all JavaScript frameworks? The correct answer is 2008, and the winner of that question is Douglas Cameron. Congratulations, Douglas, but it's very, very close. Douglas and Vincent neck and neck on the timing. Let's have a look at the next question. Which one of these cities has not hosted an NDC conference? Is it Porto in Portugal, Copenhagen, Denmark, Cape Town, South Africa, or Minnesota in the USA? Which one of these cities has not hosted an NDC conference? It is Cape Town, South Africa. We have not yet taken the NDC Roadshow to Africa. Jacob, hint, hint, are you listening, my friend? Big plans. Yes, NDC Porto, we had the inaugural one of those 2 years ago. NDC Copenhagen has been running for a couple of years. And NDC Minnesota, we kicked that off a couple of years ago. All fantastic cities that I cannot wait to visit again and put a couple more cities on the NDC map of the world. Vincent has taken the lead. 10 seconds, 2 for 2. Lee Selter, Douglas Cameron, Aidan Earnshaw, Sergio Azevedo. Let's have a look at the next question. How many total hours of viewing has the NDC Conferences YouTube channel had in the last year? So the last 365 days, how many hours of viewing has that channel racked up?
And how many of those were Dylan's Art of Code, which has been viewed something like 2 million times now?
It is. So the Art of Code is a 1-hour talk with 2.4 million views. And that talk was only put live in March last year. So the correct answer is 1 million hours. It's something like 1,040,000 and something. So there's been a lot of folks out there watching a lot of amazing content on the channel. Subscribe now. You're looking at it. The button is right there. You click that little button there, and you will be the first to know whenever we do conference content, whenever we do special partner content, and whenever we go live with any events like the one that you're watching right now. You don't want to miss out on any of that kind of stuff. Let's have a look at the leaderboard. Jacob B. Who is? Does anyone know this Jacob guy is? Jacob, you are not allowed to win your own ticket, my friend. There are terms and conditions. Let's have a look at the next one. So the next question: how many people applied to speak? So not how many talks, how many different people applied to speak at NDC Oslo in 2020. This was our flagship conference. It was online in June last year. How many people submitted talks to speak at that? Was it 222, 333, 444, or 555? It was 555 people submitted 1,140 different talks, and we had to pick the kind of 80 or so best ones to accompany the pre-booked speakers and things. If you've never been program committee for NDC, it is a very, very enlightening experience. But yeah, we had 555 people submit content for that. Have a look at the leaderboard. In the lead is Robin, then Nicholas, then Douglas, then Kim, then Milosh, and finally, NDC Manchester 2022 will be held at MOSI, the Museum of Science and Industry. What famous historical computer is on display at MOSI? Is it Colossus, Baby, ENIAC, or the Foonly F1?
Uniblab.
From the days when computers had a name, because there was only one of them in the world. It is... Baby is the correct answer. The Manchester small scale, it was called Baby because it was only the size of a room, and the previous computer was an American computer that was the size of a warehouse. And so at the time it was very, very small, only the size of a shipping container or something. And yes, if you go to MOSI, it is in the main hall there, and MOSI have done what Dirty Dancing told you never to do. They put Baby in the corner. So when we go there next year, you'll be able to see that. MOSI puts Baby in the corner, and then not ashamed to admit it. Colossus, of course, was built at Bletchley Park to crack the Enigma code. ENIAC was the first numerical integrating computer built I think at the post office here in the UK. And the Foonly F1 was a turbocharged, overclocked PDP-10 that was used to render all the graphics for the movie Tron in 1982. They took a PDP-10 and they took out all the transistors and replaced them with faster transistors. Created this one-of-a-kind computer, only one in the world. Absolutely wonderful.
Sorry, did you claim ENIAC for the English?
Did I make a horrible mistake there?
Yeah, no, Colossus was built by Tommy Flowers at the post office out of
Tommy Flowers.
Yeah, ENIAC, University of Pennsylvania.
Pennsylvania. ENIAC, Pennsylvania.
It's not even Canadian.
Hey, I've been on
It's not even Canadian, and Richard knows the
I've
answer.
been on YouTube for like 8 hours, and no one told me I was wrong yet. I needed to get something in there. And so, at the end of that, Robin is the winner. Robin, you get a free ticket to NDC Manchester 2020. Douglas, Lee, Mark, and whoever's sixth, because Jacob can get a hoodie anyway. He's the one ordering them. So we've got all the stats for these backstage. We'll go through those. We will be in touch. We'll get in touch with you by email. We'll get those prizes and things sent out. Thank you, everybody, for taking part. We are now going to do the prize draws. Now, those of you who had some of the NDC events, we did this live. We literally ran random number queries against SQL in real time. Let me just flip that across there, so that's fine. We are not doing that because I am not going to run SQL on actual customer data on a live YouTube stream, because if I press the wrong button, I'll show the wrong thing, and we all have to go to jail for GDPR violations, and we don't want that. But I am going to run the prize draw live now, and I am going to give the names out. If you're on the stream watching, drop a message in the chat so we can congratulate you on your winnings. If you are not on the stream live, don't worry. We will be in touch. We have your details. We'll get those prizes out to you. So first up, our partners at Synopsys are giving away a pair of AirPods Pro. Like attorneys general and courts martial, AirPod is the noun, it's the plural, Pro is a modifier. They are AirPods Pro. And the winner, drumroll please, of the Synopsys AirPods Pro is Gary Fuller from Prater Rains Limited. Congratulations, Gary. We will be in touch. We will get that sent out to you. We are giving away an NDC Workshops ticket to the folks who registered over on the Workshops booth there. The winner of that prize is gonna be, drumroll please, it is Andy Clark from Mr. Andy Clark. Congratulations, Andy. You got an NDC Workshops ticket. Now, our friends over at Black Marble, they are giving away 5 Lego Easter Bunnies and 5 Lego Brickheads Lego Sheep. So we are going to draw those right now. The sheep, Lego Easter Sheep. Easter Sheep, is that a thing? I don't remember Easter Sheep growing up. But yeah.
Sheepster.
They are given away, so the 5 Lego Easter Sheep Brickheads prize winners are going to be Rhiannon Rath, Mark Oliver, Grant James, Chris Rogers, and Shay Wong. Congratulations, all of you. Black Marble, we'll give your details to them. They will get in touch. They will get your Lego sent out to you. The final prize draw of the day.
Are you running SQL statements ordered by random to do this prize draw?
No, I'm running SQL statements ordered by new ID because random is evaluated before the order of rows, so it doesn't actually give you randomness. But new ID does.
See? This is educational.
And finally, the 5 winners of the Lego Easter Bunny sets from our friends over at Black Marble are Anthony Scott from Buybox, Kevin Riley from Riley Waterhouse, Mohammed Javarundi from Bid Identity, James Wadby from Proactis, and Kevin Riley from... Kevin Riley has entered twice, unless there's a Riley Waterhouse Limited and an RW Limited. We're going to draw that one again, Kevin. You can't win 2 Lego Easter Bunnies. They'll breed and you'll be overrun with them. Adam Hicks from Iris Software. Congratulations, Adam. Those are our lucky winners. Congratulations, all of you. Thank you very much for taking part in that. Now then, I am going to hand over the stage to my dear friends and collaborators in technology and comedy and educational entertainment and all these kinds of things. I am going to push the .NET Rocks button. How's that? Do we have audio? Did that work?
Hello? Hello?
1 second. Let's just figure out what's going on. I know what the problem is. It's all right. There we go.
Everything's fine. We're fine. How are you?
Everything's fine.
We're
We're all fine here.
How are you?
All right, he got it.
There we go.
Hey.
Hey. How about that? We have audio. The number of moving parts that don't move in this setup here is astonishing.
Fantastic.
So we're going to do about an hour of .NET Rocks. The Slido is running. Jump over there. Put your questions in the stream. They'll be taking those live. And then stick around. At the end of this, we're going to drop a Zoom link in the YouTube chat because, hey, what could possibly go wrong? And join us for some post-NDC Manchester drinks and chat. Be lovely to see you all there. But right now, please give a massive welcome to the NDC Manchester stage. .NET Rocks Live, Richard Campbell, Carl Franklin, and special guest Ian Cooper. The stage is yours, my friends.
So, Richard, should we tell the people what to expect? Because, watching a .NET Rocks show recorded live is a little bit different from listening to the podcast.
Yeah, I think the phrase watching the sausage being made is correct.
Yeah.
There's a lot of sausage involved.
There's a lot of sausage. We will stutter, screw up, and we'll say, let me say that again, or edit point. And our wonderful editor, Brandon Wen, is going to catch that when he's listening to every second of audio, and he'll just take out all the dumb.
Yeah.
So don't worry about it.
Sound smart. That's how that works.
That's exactly right. And one thing we're going to do before we even start is start our local recordings. So on 1, 2, 3, go. We'll push the record button. Guys, is that good?
Yep.
Ian, you ready?
Hang on, just me.
Ready? 1, 2, 3, go. And my wheels on the bus are turning round and round.
I got a blinky red light. It looks really nice.
Okay. The next thing we always do is literally hold our breath for 5 seconds so the ambient noise can be removed later, because we don't have the luxury of, Zoom and Skype already screwing with our sound. So go ahead, hold your breath, 5 seconds, go. Welcome back to .NET Rocks. This is Carl Franklin.
And this is Richard Campbell.
We're live at NDC Manchester online. Ian Cooper is here, but buddy, how you
that
doing?
Part where none of us are in Manchester? Yeah, okay.
Well, that's okay. Dylan's in
All
Manchester.
relative.
So somebody's in Manchester.
Well,
I think, Dylan, are you in Manchester?
I'm in London.
Oh, he's in London. So who isn't? Jakob's got to be in Manchester.
We had the Manchester contingent on the line this morning. We did a panel with Jem Cameron and Martin Thwaites, who's helping us put the whole thing together. But yeah, the vast majority of the people making Manchester happen are not in Manchester.
Yeah,
that's
but
awesome.
That's okay. We can pretend.
We did a road trip stop in Manchester and actually did the show in a
club, nightclub.
In a club, yeah, in a club. It was one of the more stranger sets we've ever done, but it was a lot of fun.
Because Manchester is known for two things: live music and football hooliganism.
Yes, and we saw both of that. Remember the day we were leaving? There was like a 2:00 game. We got to the train station at 10 in the morning, and there was beer everywhere. People had been drinking since 8 in the morning because clearly the pub's open early when it's going to be an early game. And it was a state of affairs.
And you don't wear the wrong colors in Manchester.
Oh, yeah.
It's like gang warfare. You'll get a wedgie, an atomic wedgie.
They'll find pieces of you in a dumpster. I don't know. It's Manchester, man. Things get serious sometimes, and football is very serious.
Right. But anyhow, let's start how we always do with a little thing we call Better Know a Framework. All right. So what have we learned here? We don't actually play the stupid music when we refer to the stupid music. It's a lie.
Yeah, we talk about music. We don't actually hear it. All gets inserted later.
We've heard it as many times as we care to.
We kind of know it. Yeah.
Yeah, we kind of know it.
I could have played it. I've got this handy, but that's not the same thing at all.
You could actually put the music
I could have put the music in if I've been thinking about it, but I didn't.
A mess with Brandon.
All right. Well, this is an edit point. Don't worry, Brandon. The sound effects are in a different channel. I wouldn't even send it to you.
Okay.
Ready?
Yeah.
All right, buddy. What do you got?
Well, this is pretty cool. Go to abp.io with your browsers now. This is an open source web application framework for ASP.NET Core. And why do you think you might need a framework for a framework?
Yeah, that's a good question. Why would I need that?
It is a good question. So just to read from the website, ABP Framework is a complete infrastructure to create modern web applications by following the software development best practices and conventions. So it sounds fairly benign and boilerplate, but
it's only missing the word paradigm and it'd be bingo, right?
Actually, the word boilerplate is really what it's all about. So it replaces the popular boilerplate template project with their own, which has some things in it that help you. So it's microservices ready, it's multi-tenancy ready, and it even has a Blazor startup template. Helps you follow DDD in the dry principle. Like it's some really good stuff, and it's of course open source and free to use. So it's a good thing to check out, I think.
Cool. Sounds like we should do a show on it.
We should. Yeah.
And it's an open source project, right?
Exactly.
So you can take a look at everything.
Right.
Awesome.
So
dude.
that's what I got, Richard. Thanks. Who's talking to us?
I grabbed a comment off of show 1458. That's right. Going back to the before times. July of 2017 is when we published the show, but we actually recorded it in June at NDC Oslo with one Ian Cooper. Maybe you heard of him.
Never heard of him.
And I entitled the show The .NET Renaissance because that's what Ian wrote in his blog posts. It was one of those things. In fact, I think we'd interviewed him maybe 4 months before. Normally I have people on maybe once a year or so, but it was one of those things where I read the blog post and I pinged Ian. It's like, oh, we need to do a show on this. Because he was talking about something I'd certainly been aware of, which was that Microsoft had kind of turned a corner. .NET was ascendant again. This very mature framework had rebooted itself, and there was this amazing community emerging around it. A really fun show, and I recommend it to your listen, even though it is pushing 4 years old now. And this particular comment is actually referring to me. This is from Chris Zink, and admittedly written 4 years ago. And Chris says, Richard made this comment during the show, and I have to correct it. He mentioned that software engineering is not a profession yet. In Canada, at least, software engineering has been a profession for almost 20 years. It is a regulated professional engineering discipline. All of the professional engineering licensing requirements apply to anyone wishing to call themselves a software engineer. Again, in Canada, you must be a licensed professional engineer, use the title engineer. You cannot legally call yourself a software engineer unless you're also a PEng. As well, there have been accredited Bachelor of Engineering software engineering programs given by Canadian universities for a couple of decades. The point to all this is that the profession does exist for software engineering. There are mandatory CPD requirements, ethics, professional practice guidelines, and so on that define a mature profession. Most provinces have licensing paths that allow a current protection. Let me say it again. See, edit points, magic. Most provinces have licensing paths that allow a current practitioner to get licensed with some effort. The regulating bodies are responsible for regulating the profession, and they are working hard to get practitioners licensed. The engineering regulators are doing this because there are major public safety issues around many aspects of software. As an industry, we need to understand. Okay, let me say it again.
Kiblik.
The engineering regulators are doing this because there are major public safety issues around many aspects of software. As an industry, we need to understand this and support the profession. And if you're looking for more information, you can go to engineerscanada.ca. And they do have a white paper specifically on what constitutes software engineering. And I have been doing some reading. And we're in this interesting state where here's this body that is identifying engineers and asking for qualifications and so forth. But largely, they are still kind of pitching this to the provinces. So, similar to the way the United States work, where the states sort of make certain rules, the actual regulation of software engineering and all kinds of engineering is at a provincial level. So the rules are different from province to province. And there's not really any enforcement around any of this right now. So they have the ideas, but they're still very much pressing against, can we put more legal constraints around this? What does this look like?
I mean, the United States is, anybody can use any term and just consider it a marketing term. You know, like pain reliever, for example, could just be a marketing term. It may not relieve any pain at all. Oh no, it's just what we call it.
Yeah. Well, there are rules. It's again a question of enforcement.
Yeah.
Right. The Federal Trade Commission does have very specific things about it. Generally, they enforce stuff like, can you call it bourbon if it's in Tennessee?
Well, yeah, that's a federal thing.
And yes, you can, but only if it doesn't do any carbon filtration. Looking at you,
Right.
Jack Daniels. Separate issue. So, I mean, Chris, great point. And I have to change my pitch on this whole issue because obviously there are groups getting together to get more serious about what engineering looks like. And you know, the same rules apply in engineering. Typically, there's only one PEng per project. Like if you're talking about constructing a bridge, there's lots of people involved in that. But not all of them need to be civil engineers, and much less have their PEng, their stamp, so to speak. So we could see a time when certain classes of software are built that way. And one would argue that some software is already starting to be built that way because, you know, more than ever, it's becoming abundantly clear that software is running the world. And we really ought to have some authorities around managing all of that.
Yeah.
So, Chris, thank you for your comment. A copy of Music to Code By is on its way to you. And if you'd like a copy of Music to Code By, write a comment on the website at .netrocks.com or on the Facebooks. We publish every show there as well. And if you comment there and I read it on the show, we'll send you a copy of Music to Code By.
And you should definitely follow us on Twitter to keep up with .NET Rocks. I'm at Carl Franklin. He's at Rich Campbell. Hey, send us a tweet. You know, you can use the boilerplate tweet template. We don't mind. All right. It's my great pleasure to welcome back to .NET Rocks Ian Cooper. He is a polyglot coding architect in London, a founder of IDNUG, speaker, tabletop gamer, geek. He is also tattooed, pierced, and bearded, the gov on at Brighter Command. Welcome back, Ian.
Hey, that's LDNUG, actually the London.NET user group, which
I get it. Yeah, you know,
other co-conspirators run.
My font doesn't really.
London.NET user group in Canada, who we occasionally get some clashes with in terms of our events on Twitter.
And that's London, Ontario, right?
Yeah.
Little London, not because nobody in Canada called it New London, because who would do that? Nobody would.
Who would do that? I know, we're the littlest London. I guarantee it. We're the littlest New London. Anyway, yeah, I'm sorry. My font didn't really differentiate between a capital I and a lowercase L. So I was just reading.
Oh, good.
But it's good to have you back, sir. We always
too long.
Always learn something from you, no matter what we talk about. So what's on your mind lately, sir?
So, I was talking today about test-driven development. And I gave a famous talk about that in 2014 at NDC Oslo, which I think was probably one of NDC's highest rated videos until Dylan stole my crown with his art of code.
I think I had something to do with that.
Yeah. But so I guess what it's about is this. There's kind of a fork that seemed to happen in the history of kind of practice of test-driven development. And this is the way I think about it. Originally, at some point, the people like Kent Beck, Martin Fowler, they're all working at the Chrysler Corporation in the US, and they come up with some great practices, XP, TDD, etc. And it's clear, I don't think people don't necessarily understand, when they produce the practices and they publish them, they've been doing them for some time. And someone sort of said, we should share this with the world. And Ken's book about TDD is that, if you read it, it's not really a great beginner's book, because it's actually him explaining a practice that he's been doing for quite some time, and it actually has quite a lot of detail. It's more like a kind of masterclass. But one of the problems with the book is what happened is that people who kind of read it and didn't really necessarily get exactly what he was focusing on brought in a lot of techniques from a much more classical approach to testing. So unit testing, integration, system testing. So unit testing, of course, this idea of take a module, I test what is inside that module in a kind of black box sense usually. And in order to do that, what I do is I say, well, any other modules it talks to, I'm going to substitute those with some kind of dummy. Then I'll integration test. I'll take 2 modules and I get them to basically talk to each other. And then I'll finally do a system test. And the idea is to localize where the defect's happening. Right? So if I'm doing black box testing, I've got a unit under test and some dummies. I know that if there's a failure, it's the unit causing the failure. If I'm doing integration, it's the integration of these 2 tested units that must be wrong, right? But that has really nothing to do with test-driven development. And unfortunately, what happens is really that people in common parlance, when they talked about TDD, they spoke about writing unit tests. And really, that wasn't what anyone was doing. But what happened is that brought all this baggage with it. People said, hey, we should isolate this thing. We should use substitutes around it. So they created this model where we took a class, for example, and we said, hey, well, that's obviously our unit. Let's substitute everything around it then, and let's basically inject all of its dependencies because we can't use those. That'd be violating unit testing, right? And we can do an integration test later, and that'll test us talking into real things, maybe a system test. Led to this growth of mocks. It also led to the growth of a constructor that had quite often a huge number of interfaces that was taking in a type language or even, duck types basically in a dynamically typed language. And these constructors already grew. And what happened particularly in statically typed languages was we said, well, we've got all these interfaces that I depend on. And this object may satisfy that, but it's got all these interfaces it depends on. We got these graphs of objects. So when we had to have IOC containers kind of built so that we could essentially realize as object graphs at one time. And this whole direction, I believe, was a complete mistake. You talk about, null being basically the kind of $1 million mistake. This is a whole path that, if we could take time back and say, hey, maybe if we got to history and we changed the fork when we went towards unit testing and actually went to what later practitioners began to call developer or programmer testing. So you can go and look at what's called the C2 Wiki. C2 Wiki is a repository of old school agile knowledge from the beginnings of XP and TDD. And it defines what developer or programmer test is. And it says essentially it's a test where effectively I'm going to test some behavior of my software. And I'm going to do that by essentially doing the smallest possible change that I can make in order to implement some of the acceptance criteria. And that its localization is simply, in the event that my test break, that last edit I did, which would be quite small, that's what caused that failure. And I should either revert it, effectively, purists always revert it, or maybe debug it for a bit and see if I can get unstuck and then effectively move back. And that path doesn't really use mocks. It doesn't really need IOC containers. And it's a very different approach. And it's where people struggle with red green refactor, right? Red green refactor, how does that work, right? If you've done all your thinking about design up front, such that you can inject all these interfaces that describe the collaborator objects, you must have in your head conceived of some kind of class hierarchy, etc., right? You've probably over-designed. If what you do is actually say, hey, this is behavior, I need to get under test, how am I going to implement that, right? And so the example Kent uses throughout the book is sort of a money class. And he's got this thing that says, well, I want to basically take 2 money types of different currencies and add them together and get a result in the first currency. That's a typical kind of requirement he's building with 2DD, not just basically a method on a class. And so what Kent would say is, well, here's this behavior. So that's where Dan Northlater came along and said, hey, maybe we should call this behavior-driven development instead, right? But that behavior, you would say, well, what's the simplest thing I could do, the smallest amount of code I could write to move one step forward towards that, right? And you essentially say, well, write a red test to prove that fails. A green test, which is the noddiest implementation I can think of. You're explicitly asked to do something horrible, like go to Stack Overflow and say, let's cut and paste that in, right? Great. Now I'm getting closer to that. Yeah, all the stuff that we say, those developers that do that, I guess you should do all that and make it get to pass as soon as possible. Then you kind of step back and you go, well, that code looks awful. I can't show that to any of my friends. Hey, but I could do some refactoring now. What I could do is actually make that, now I know effectively what the algorithm is that I want to do. I could refactor that, right? And that's when design emerges. And actually at that point, because that's under test, I could break out classes and do that without new tests, right? And the idea really is that they're private, or they're inside the module and they're export depending on language. So in something like C#, they'd be internal and not public. And you'd be saying, well, no one should be calling those. That's how I implement it. And I could, because it's refactoring, in a couple of test time, decide, well, that was a really bad idea. I'm going to throw all that away and redo it, right? So it gives you that kind of ability to keep changing your implementation, which is the promise of refactoring. And
it reminds me of a joke, Ian, that a tester walks into a bar, orders a beer, orders 0 beers, orders 9,999,999,999 beers, orders a lizard, orders -1 beer, and orders the first real customer walks in and asks where the bathroom is, and the bar bursts into flames, killing everyone.
Yeah, exactly. But it's not really about testing, right? It's more about designing an API. That's really what TDD is behind, and step by step, controlling scope so that you don't write speculative code. And actually, if you do it this way, you do get that promise of self-describing examples. And I've been kind of on this war path a bit because I feel that we've got this direction which isn't giving people the results that they want. That is very expensive to do. That ends up with these test suites that are very fragile, and then led to people going, TDD's not working. And I'm like, that's because you're not really doing TDD. Now,
and all your tests can pass, and it could still blow up in production.
Yeah.
Yeah.
The unit tests and integration tests and that are still valuable, right? They're still a valuable technique. It's just a different technique, right? And I often say to people, you know, when you're thinking about that, things like the test pyramid, right? There's a certain sweet spot for doing test-driven development, really, or quite often around what is the problem space, the domain you're actually addressing. There are other spaces like my user interface, where test-driven development is not the technique you're looking for, but testing, maybe unit testing and test after approaches maybe are, right?
End-to-end testing.
Yeah, and what we need to do is clarify exactly what TDD is and what problems it's good at solving. And so that's part of our mix of kind of QA tools that we want to use. And we should understand our tools better. It's the age old problem, right? Effectively, you know, if I've only got a hammer, I'm going to be banging those screws in, right? And really testing is a suite of tools. TDD is the hammer and it's great for nails, but sometimes I've got screws and I need my screwdriver. And we need to get a little bit, stand back and say, what are the tools I've got? And which one's going to get me the best result? And there are two results you're looking at. One is, I want to get feedback now on decisions I'm making as I write code. And that's basically TDD. Or, hey, I want to protect my software against regression, against blowing up in production. And that's more the classical kind of unit test, integration test kind of model that you've got going on. We need to get a bit more sophisticated about that conversation, I think.
Yeah, absolutely. The challenge here then is to sort of order of execution. Like we've always been pitched on this idea that we focus on the testing would make us think more clearly about what those APIs should look like. That's the right way to do it. Is that just putting yourself in the customer's shoes?
Yeah, I think so. I mean, generally what you should be working with is some kind of user story where there's customer-defined acceptance criteria. You don't need tools like Cucumber to do that. You can just be doing that in your X-unit style TDD. And really what you need to say is, hey, well, I'm going to test for something. What is it I'm actually trying to achieve here, right? So Kent's example, he's trying to achieve building a class that will support money. And he's trying to look at what are the acceptance criteria? I need to be at it if it's in 2 different currencies. Great, that's a criteria. Let's have a test that shows me how I do that, right? And that's what you're really driving towards. But you're also exploring how to make that SDK usable and effective and simple. So I teach a bit of a workshop on it. And one of the examples I do is a game of life. And one of the things I show a video of me doing it both styles, right? Doing it unit testing and doing TDD. And it's very clear the difference. In the one that I do a kind of more unit testing approach, I end up with a quite overcomplicated kind of design. Whereas the one that I do TDD, I end up going, you know what? I just need to pass in this kind of array that represents basically game of life. And my tests are so much clearer. You can read the tests and see exactly how the transformation is occurring between the 2 game boards that I've got. And that is part of what you're doing. You're saying, hey, if I was a developer, how would I want this to work? How to make this clear what the pit of success is for using this particular API that I'm writing, right?
Right.
And too often it's more, hey, here are all the weeds and the details. And by the way, go and look at this documentation because you're never going to be able to figure out how to use all the weeds and the details. without all this documentation. So it's really,
and isn't that just the kind of a punt? It's like, look, I'll put all the things in here. You figure out what you want.
I think so. Sometimes, yeah. I think we as developers are inclined to say, "Hey, maybe this will happen, or maybe that'll happen." And I think it's an attempt to be kind. It's like, well, that could come up. I better make sure that's kind of solved, right? And you're thinking of all these possible things, and you think, well, I'll get payback at some point in the future because this will come up, and someone will go, "Hey, that's really great. He's solved that already." But the reality is quite often what happens is that comes up and you're kind of like, yeah, we had a stab at that. It wasn't quite right.
Yeah. But this just gets straight back to the whole Yagni. Like, you ain't going to need it. Figure out the basic case, get the basic case out there, and then use feedback to decide what the next case, the next version is going to look like.
Yeah, it pretty much is. But even at the level of writing my own code, right? That's what you want, fast feedback. The idea is the test should be fast, because the reason for this requirement about speed is I really shouldn't be interrupting my development flow very much, right? I should be writing something that looks like it, do a small change. Okay, that seems to be making progress. Do a small change. And it really helps people quite often to work in that kind of really tiny increments. So I've only got to have so much in my head, right?
Yeah, I managed to justify spending a lot of money on testing infrastructure to keep test times under 15 minutes. My theory being that was as much time as it took for the dev to stand up, declare himself a god, and then walk over to get some coffee. And by the time he got back with his coffee, all of the errors were there, right? All the problems. Because what we were finding was they still stood up to call themselves a god when it got coffee, but the tests weren't gonna run at the end of the day, like we were doing those kinds of models. So they worked on something else, and by the time they got the error reports back, the code was out of their head anyway. Yeah,
particularly, I used to find if you were running CI suites back in the day and you had this whole kind of model where it was too slow and you ran them overnight, then it created what I would always call plausible deniability. Yeah. Everyone the next morning would go, that wasn't my change.
Yeah, it worked on my desktop.
Yeah, and I used to say that everybody used to play this game. I used to pin the tail on the donkey. Somebody's job was effectively in the morning to go around figuring out exactly whose change had caused the problem, and then kind of like you say, okay, you fix it, which is kind of an enormous waste of effort, really. But if you could give the people the feedback now, they'd be like, okay, I can't escape this, right?
Well, and now there's no excuse. We have the cloud, right? Like, you can distribute this huge test suite across a bunch of servers for a few minutes and then tear it all back down again. So it actually doesn't cost that much. But that you checked in this code and minutes later, these are the errors we got back. Like, it short circuits that whole debate.
Yeah, and I think effectively you're still in the same context, right? That's the other big thing. I mean, talk about developers and not interrupting them, because it kind of I guess the way I perceive it is, I built up a model in my head, and it doesn't take a lot for that model to have to be ejected from my memory to do something else, right? And then I have to rebuild that whole model. And there's a certain point of I don't want you to have to eject that model between testing runs. So, I don't want you to really think, maybe I'm going to go away and do this other thing that I've got on my to-do list, and I'll start writing that email and that document.
I'm thinking of a story from a project that I'm working on. We had this issue where this null reference exception was happening, and it wasn't the code that was expecting that to not be null. It was the code that was sending the null that was the problem. And so the developer just said, just did a test for null. And if it was null, we'll just exit, right? Just return. And then, we couldn't find the real problem, which was that this thing over here that was calling it was passing null. So it's good to not do null checks sometimes, especially when you're developing, or at least do something constructive when it is null. But those things will help you find the real problems. But it was just an interesting thing that came up.
Yeah, fail faster sometimes. Like, I think, underrated. We can swallow and catch stuff because we don't know what to do with it, right? And actually, a better thing to do is to crash at that point, because at least
don't fail silently. Like on error, resume next. Like, that's just evil, right? I'll just
people don't even remember what that means, Richard. Yeah. They don't even remember what that is.
Yeah, roll the dice and hope, man.
But
Richard's bringing up VB.
Dragging out old languages, right? I do think we're in a time now where we're starting to think that being opinionated right? That this is how I work, this is what I do, and no secrets, like failing loudly, making it very clear, this is what made me unhappy. It makes for better software. Software's too complicated as it is. Everything that can be expressive and out and forthright, so forth, that's, you spend a lot less time chasing these ghosts around.
Yeah, I mean, I was thinking about this. It's a slight tangent, but in relation to running software in containerized environments like Kubernetes, where in some cases, when you get a sort of transient error or something you're talking to, like I work on an open source library, Brighter, which deals in messaging, and there's this whole question I occasionally ask myself is, how sophisticated should we be at coping with the loss, say, of a broker and sitting there continually retrying, etc. Because the trouble with that is it can be very hard to observe that from outside. Whereas if I just crash, then someone writing the scheduler can say, okay, great, well, I'll pause and restart a new instance, right, to replace that one. And that's this problem where, by being quiet and silent about the failure, I'm thinking that, I'm helping the operator. But in fact, actually, I'm not, because he can't now observe the error and take a suitable action.
Right.
You can't reproduce it.
Yeah.
Yeah. You thought you were being clever,
but if he looks at his monitor, right, I'm still running, right, but maybe I'm not doing anything useful.
But it's in a state that's corrupted, so you really do have to. Hey, guys, hold that thought while we pause for this very important message. All right, and we're back. It's .NET Rocks. I'm Carl. That's Richard.
Hey.
And that's Ian Cooper. We're talking about TDD and the problems that have plagued us about this. And Ian, it's interesting to hear somebody say, I think we got it all wrong, and there are better ways to test your application. And I'm concerned that, the alert listener missed that part where you said, now unit tests are still important, integration tests are still important. So I guess what I'm saying is, what is the prescriptive kind of fix for this, TDD behavior that people have been doing now for years?
Yeah, sure. So I think the thing is this, right? Decide that you are in a position where a test-first approach is going to help you. And then really the context for that is I have a requirement that's reasonably well defined. I've got some, say, user stories or use cases with acceptance criteria. And it's kind of a domain problem usually. It's a problem basically I'm going to deal with it in terms of entities, etc., rather than technology. And I want to essentially explore how I write code that solves that kind of domain problem, right? And then I focus my efforts on saying, okay, let's take the simplest kind of thing I could do to move towards that criteria. Quite often it's essentially something that says, I'll return 0 in this condition, right? I try a couple of lines of code, get started, and then you say, well, what's the simplest move I could make towards the maybe initializing a kind of base level thing. So taking the example of money, right, that Kent was using, it'd be like saying I need to create a money class that basically has kind of 0 value. Great, and I can test it at 0. Awesome, that seems like a good start, right? And then maybe now I think, well, maybe I need to set a value to it and test it still got that value. Okay, maybe I should add 2 of them, right? And you build up kind of that functionality of acceptance criteria towards getting something. But each time you're trying to express a behavior, right? Separate, and then when you do that, really try and follow red, green refactor, and really try and avoid using any kind of mocks, right? Generally speaking, you can work in different architectural styles. Like I tend to recommend ports and adapters, and quite often now rephrase as clean architecture because it cleanly separates, here's my domain, around that is things that basically do I/O. So I can focus on that thing and I can add I/O later, right? And then I can use TDD to do that. It's a sweet spot. And then when I'm saying, hey, I'm going to test my UI, or I need to test actually how it accesses this database, say, hey, is that the best tool in the box? Maybe actually unit testing this is fine, or even just testing it by running it, right, and having a look and saying, okay, I've had a look at that, right. And so if you do things where you're testing by looking at just running it, then your problem you're solving now is regression, right? You're saying, hey, I need to write some tests to make sure that keeps running, right? So I can write some tests that just check that's going to run still. I'm not exploring that. I don't need to explore that. So my common example of this is a lot of code where I'm saying, oh, well, I've got this idea of an entity that I need to save to the data store, right? And generally, in a lot of cases, all I'm doing is probably I've got some data access object wrapper, and I'm just going, you know what? I need to get the docs up. I just implement that. There's no real exploration. There's no real kind of like, how does this actually work? It works when effectively I save stuff to the database, right? I could label, check that as I work through it. Once it works, I go, okay, that's the working code. I need to, I write a little test. Now you can use XUnit tools to do that for you. That, you know, they're agnostic to what the approach you're using. And kind of you can do that there, right, to check that. Maybe it's doing a UI, right? You can use, I think one of you were mentioning to me earlier, kind of snapshot tools. And I did have a colleague who wrote one of those where effectively you're saying, hey, compare this UI to the image basically and see whether we've moved buttons and, you know, around into the wrong place and they've shifted a few pixels to the left, and that isn't a requirement.
A good tool for that is Playwright for .NET, WRIGHT. Yeah, that's a good end-to-end tester for UI. And I like that because you can basically tell it, you know, fill out this form right here, push the button, wait until some ID shows up on the page, and now we can test that. And you can actually write a script that goes through the whole thing and hopefully gets the desired result.
And all we need to do is just bear in mind, you know, that's not really what I'm not doing TDD, but I'm doing QA, and that's perfectly fine. Both of these things are equally valuable, right? I mean, there's this notion called the testing pyramid that kind of says, hey, I can draw a pyramid, right? And the bottom is unit testing, and at the top is essentially, you know, manual testing. And as I go from up, it takes me longer to get a result, and those results are less easily repeatable. So obviously, because, you know, I would prefer to get repeatable results that are fast, I might want to put a lot of my effort into getting a lot of the problems I can solve with TDD. But there are other things that TDD is just not the right thing to solve, and you use the correct techniques for those, right? I mean, we all know, we were joking earlier about, you know, someone walking to the bar, right? Effectively, but actually, you know, shipping code to a small number of users will find you things that you just never expected. And you look there going, well, why would you do that? You know.
Well, but there's also sets of personalities that really like that work. I mean, I also think that's not a replacement for QA. It's an addition to QA, and it takes time and cultivation. You know, I think back on, like, Windows created the slow ring, fast ring thing. And what really happened was most people just put it on a secondary machine and never looked at it, didn't actually take it out for enough exercise. So they weren't getting the useful feedback until they actually pushed patches into production, so to speak, and broke things. So you really got to evaluate these different strategies. Like, I kind of think we're abusing our customers via the cloud with this, where we're not really finishing software. We're just sticking it out there and letting them finish it for us by forcing them to give us feedback, by crashing the app.
Because they expect, you know, version 1, there's going to be some errors. Oh, but, you know, we can get...
It's an interesting one because when I started my career, I shipped disks, right? I used to work in medical software and ship disks. And I can remember a fault that I'd added to the software that shipped, and we had to ship all the disks again. And I was a young junior developer, and my boss, to teach me a lesson, sent me down to the department, helped me make me pack all the disks that I had to be resent out, that I would learn by doing basically that particular job quite how much they wanted.
We're older and more mature now. We don't ship disks, we slip disks.
Yeah, very true. But I think the thing is the purpose of talking about things like testing in production, of course, is that we can't predict everything anymore, right?
No.
And it's more saying when you do release something, there's sufficient complexity that you're going to have to accept that the first thing that you release is probably broken. That's what to me, that's what it means more testing in production. It doesn't mean, hey, actively don't do any QA, just ship the thing and let it explode. It's more accept that by the time it gets to production, you're still testing.
Yeah, you'd hope that some group of customers are going to be able to successfully use it.
Yeah.
And that you slip that new version out bit by bit.
Right.
So you don't break everybody at once to create total chaos. But it's almost like do a release, listen, get that feedback. Oh, everything's going well right now. Add a few more and wait until the screams start and then stop shipping it.
Yeah.
Start dealing with the screams.
And what's your advice, Richard? Never ship 6 p.m. Friday night.
Yeah, well, geez, don't ship anything. Don't change anything on a Friday unless you like working weekends.
All right.
Right before vacation, ship it.
Yeah, out of here. Thanks for playing. Phone doesn't. You wonder why I went to Nepal? Phones don't work there. Remember my out of office message? It literally gave you that long to send the helicopter. If you really need me, this is where you need to go.
I'm climbing a mountain in Nepal right now.
And I'm willing to be interrupted if I get video of you picking me up in a helicopter. That's acceptable. But otherwise, no.
Yeah. The friends don't do that to friends sort of thing, is it?
Yeah.
Yeah.
But I think there's a respect angle on this that you're right. We're never going to test for all scenarios, but we should test for some.
Mm-hmm.
And then really being careful with who you break and how you break them. You know, we got into this situation at Strange Loop where there were some customers that wanted the leading edge features really, really bad, that they were willing to take risks. And they went on this beta program, so they got those bits first. And there were other customers who's like, I will accept a modest performance improvement. Do not break my site. Right. And they were sort of in the conservative ring. So part of this was just listening to where the customer's at, giving them that choice. And building our deployment practices around those things so we could really learn.
Well, I think the thing, I mean, you're talking about, licensing of engineers and the risks that one of your correspondents was talking about, the risks that effectively that we get from a world that's running on software. And I think that we underestimate that we can make people's lives, quite miserable because a service they've depended on is not going to work for them for the next, few hours.
Or you could flat out kill them. Ask the folks who got on the Boeing 737 MAX. Like there were some hardware decision failures there too, but it was also a lot of software. Like no kidding. Or I'm going to just keep picking on Boeing. The Starliner spacecraft that didn't make it to its correct orbit because literally a time and date problem, like straight software mistakes. And only after it was up in orbit did they do the rest of the testing to realize, oh, if it continues on this path, it's going to be destroyed. And they managed to fix the software enough to recover the spacecraft. But still.
That was Geordie LaForge that fixed it, I think.
That's what the visor's all about, right? Look, augmented reality in the 90s.
I think the pandemic's also taught us that. I mean, there are other things that we think perhaps are less vital that it turns out can become vital, right? So, I need to get groceries shipped to my house because I can't. If someone can't leave because they're too vulnerable clinically to actually really risk going to the supermarket, that's essentially now become a really essential service for them, right?
All of a sudden, I ended up talking to organizations that had not unified their purchasing and return process from in-store to online. So the stores had inventory, but you couldn't buy it online, and you couldn't go to the store because the stores were closed because they, two different teams had built it.
At a point, I want to invite anyone who's in the Slido channel to ask questions for Ian. This would be a good time to take questions. I'm watching it, so ask away. Continue.
So, it's all those little things you've done along the way, just not actual, one team built the software for the online product. One team built the software for the in-store product, never got around to merging the two. And all of a sudden here we were in a situation where it's like, people need these products. Like this is serious. And you're broken because of a dumb software thing.
Because they didn't do an integration test.
Well, or just, wasn't important. If all the products we're selling, who cares?
Yeah, but even things like, if I've got an app on my phone to get a taxi, right, or I get a cab, right? Actually, that can be a situation where if that doesn't work for you, you may be in a very vulnerable place or position, right?
Yeah.
I mean, I've been, in situations with small children. We've been, out somewhere effectively. You wanted to get them home, right? And you suddenly discover you can't get service on something, and that's actually that turns from something that basically is an annoyance into quite a drama for you. And I think that we underestimate, as the world gets more and more built on software and becomes more and more dependent on the dream we've kind of sold them.
I've had that exact same issue, not because of lack of service, but because there were no Uber drivers or Lyft drivers in the area because of the pandemic.
Yeah.
And we've actually been stranded at places for hours because there's, we thought we could count on that service,
Mm.
but that's another story.
Yeah, but I think I think the problem is, of course, I think it was Bruce Schneier once said, I think he was talking about basically, the dying of newspapers, and he said, you were promised a future, you weren't promised that it would be better, and I think we don't always think through the house of cards that we're potentially constructing, right?
Yeah, and we're only as strong as our weakest link.
Mhm.
But also, I mean, and if I think there's a recurring theme in this episode, it's like, listen, you're not your customer.
Yeah.
Your customer uses your product differently. Your product is more important to your customer, or is important to your customer in a way that's not like you. You are not your customer. And so if you're not listening to them, if you're not actually, you're missing out on what your product's actually about. Just because you built it doesn't mean you own it, really. Ultimately, once it's out in the world, like any piece of creation, once it's out in the world, the people interacting with it have as much to do with it as you did.
I learned a really important lesson when I was a very junior developer, and I was fortunate enough in that era really you were kind of more quite soup to nuts. So I went out on site when it was kind of deployed to the first site, and it was early days of kind of office automation, and people were just really doing data entry.
Mm-hmm.
So it's quite a simple app for a junior engineer to build, something that was just, let fields, they can enter the data in, click OK, move on to the next one, a little bit of validation so they didn't get things wrong. And I sat down with the crew that were basically doing all the data entry. And quite rapidly, they gave me a piece of feedback that I'd never thought about, which was that essentially I hadn't really thought about tabbing, right, and tab order. And I was making their life misery because those people worked really fast and were tabbing between fields the whole time. And the tab order was basically for them dictated by what was on the paper form that they were entering. And that simple thing, I was making their every moment painful. And I, as a junior dev, I've got some validation on there. You can't enter dates that are basically, the crazy, but it's kind of like, doesn't really help us. What really helps us is the fact that the tab order matches the field order on basically the paper document, right?
Yeah. Interesting, different set of priorities. And of course, the moment you see it, you get it, but you got to go see it.
Yeah.
So are we kind of stuck in this development practice now? Like TDD's been around a while, DDD, like this whole genre. Like, are we looking for a new term, a new name, a new practice?
It's interesting, right? Because Dan North, renamed it behavior-driven development, but then that went away and became something I think quite different. It's become really a full kind of agile approach to delivering software now, BDD. I don't know whether, I think we are at a moment where TDD has kind of got people who are in favor of it, and also some people who dislike it enough that you can kind of present back and say, I think many of the problems that you are afflicted with are due to the fact that you're using the wrong technique here. You're not actually doing TDD, you're doing unit testing. The reason you're finding it difficult to get this nail into the wall and you keep complaining basically that nails are rubbish is because you're using the screwdriver. And hey, let me hand you a hammer, right? And so I think we are at an opportune moment when we can begin to really reverse some of the muddier thinking here. And it's once you do it, it's one of the keys to this kind of more extreme. People talk about other sorts of problems like overuse of patterns when it's unnecessary, etc., that kind of thing. Once you get into this model of TDD, it becomes clearer because you can say, well, I've got this green passing test. It tells me what I need to do to solve the problem, but it's rubbish. But now I understand the context. I can figure out, do these patterns really apply here? Do I need those to help clean this code up? So these other conversations that I see emerging on Twitter this whole time saying, is this pattern valuable or is this pattern actually been negative because people have gone away and implemented it without thought? Something like this technique can say, hey, well, I can tell you the answer in the green phase as to whether you're going to need it. Now it's a target for your refactoring or not, depending on what, because now the context better now, right?
We have a comment from Neil, who says one of the biggest problems for grokking TDD is the lack of meaty examples. The contrived money example is great, but it's hard to apply in one's real projects.
And that's very true. I think that that there is this difficulty that says these contrived examples don't help you because they fall apart when you hit kind of real problem. Is like, well, what do I do with the IO, right?
Yeah.
Like every Hello World example.
Yeah, I definitely agree with that. I think the answer probably is more, I mean, internally, I recommend you do kind of katas, right? And explore doing TDD a lot in this technique until it becomes kind of more, you say, okay, I'm going to really push myself for this 2 hours to do it this way. And then you learn new kind of muscle memory that helps you then apply to wider stuff. I think there's another answer really, which is, you know, people doing streaming and stuff more. So and Twitch streaming and stuff to actually do more demonstration of trying to solve problems around larger projects.
Right.
Always this problem of, if I have a complex enough domain to be real, I have to bring the domain to you as part of what I'm doing. But I think maybe that may be what some of the answer of how we actually solve some of this training problem is showing more solid examples of working in this style with bigger domain spaces.
Yeah.
Yeah. I mean, part of me wonders if it's just that when you actually get into the meat of really understanding software being built this way, it's now so complex you can't explain it meaningfully. Like that's hard too. And you also pretty quickly dive into some proprietary aspects. Like one of the things I've found in really well architected apps is that the secret sauce is abundantly clear, like the value proposition of software. And that's often things that leadership is pretty protective of.
Also, one of the things you said was don't use mocks. And so I guess that means you can't really test anything that has service dependencies with unit testing. So that's not the right test for something that uses a service.
So generally there are three, I mean, Ken outlines 3 cases where you might want to use mocks, right? So one is a shared fixture, like a database or a file system, where one test can affect the other, right? And that's to do with basically 2 tests interfering. Other is it's slow to talk to, so it's over a network. And the other is it's fragile to talk to, right? And those are the 3 cases. That's where he says you use mocks to replace those things.
Yeah.
I think if you have a decent use of a layered architecture, that helps, because you can say, well, those things are actually outside this layer, right? I'm just focusing on my domain, and I don't worry so much about those. And I then tend to use other techniques, the kind of more the test after a unit test for testing those. I feel they're better.
So for example, if your data comes from an API endpoint, you could make an NPI endpoint that returns data that you can test against and use that for your test.
Yeah, that's an okay use of a mock, because I'm really substituting for something that's fragile, slow, or multiple tests are going to impact, right? But it's not a class-to-class dependency thing that became the kind of mantra of the people who treated this as a kind of obsession.
Plus, you could also like put some intentional delays in your API, you know, to sort of simulate what happens if this takes too long.
Is a way to look at this. What the problems I solve with mocks are going to be replaced with problems with integration later.
Yeah, exactly. What we don't want to really solve are problems where 2 classes are collaborating, and I want to mock one out of those collaborators.
Right, which means I'm now presuming their piece is going to work this way, and I put it in the mock, and I'm invariably wrong.
Yeah, and generally in a lot of cases, it's an implementation detail. Your public surface area of your module doesn't need that. It's something you built as a result of refactoring to clean up your green code. You've got this small class that does this thing, has a single responsibility. It helps you as a developer to understand and manage that code. But for the consumer of your code, that's just additional complexity they don't really want to know about, because it doesn't help them answer the question of how do I use your code.
Right. I get it.
Awesome.
Yeah, good stuff. So what's new for you, Ian? What's next? What's in your inbox?
In my inbox, we're trying to get V9 of Brighter, the open source project I work on. Helps you do messaging really between 2 services out the door. We got a bit delayed. We had a couple of people who had a paternity leave. So one of them, you guys know Toby Henderson? I can't remember. You met him ever? I think you might have.
The name sounds familiar. I don't think we got him on the show, but I think he's been at the events.
Took a good slug off to look after his child. So we got slowed down a bit by that. But that's I think a very positive thing in this day and age, right? Taking your very fair share of childcare responsibilities when the child is young. So but yeah, so V9 is going to have some better support for what we call outboxes and inboxes. So really stuff that essentially helps make sure that the message is delivered or removes duplicates. We've got some rewrites of our Kafka and our SNS and SQS from AWS kind of providers, make them more robust. And we actually, I mean, transports transports are kind of an interface that you implement, and they're fairly straightforward. And but none of the core team were actually on Azure, so we never really had one for Azure Service Bus, which is a huge hole. And we knew people had written them, I mean, they were out there, and we were like, can we have one, right? And of course, these people were like, oh, it's a proprietary secret. My boss won't let me. We've got one back in now, so we've got one we know runs in production at scale. And that's going to come out hopefully in the V9 as well. So all the people on Azure don't have to roll your own anymore, right? We've actually got someone to contribute one back to the project, which is a big win for us, I think. What we always want to try and avoid is ones that are speculative. We don't know somebody's actually tested this code and run it in production. That's one of our kind of guarantees. And so that's been really good for us. We got that one back in. So that's what I'm doing there.
Very good.
Other than that, yeah, I mean, I've got to focus still, I think, for me on that kind of messaging side, microservices, domains, etc.
Cool. Well, Ian Cooper, it's been a pleasure. It always is a pleasure. Always learn something. You always have some new perspective on stuff. And thanks again for being on .NET Rocks today. And we'll see you next time on .NET Rocks. And now we can stop recording. And I believe Dylan's going to invite everybody for a drink.
Hello.
So, yeah, he put that message. Yeah. I'm stopped.
Yes, hello, folks, and thank you very much. Thank you, Carl. Thank you, Richard. Thank you, Ian. And this is it. We are done. That was NDC Manchester. Just remains to say a final huge thank you to everybody who has helped make this happen, to our amazing speakers. So we had a Stacy Cashmore this morning talking about, using Blazor and static apps and building your brand. We had Ian Cooper doing, TDD Revisited. We had Janani Subbiah. We've had Steve Sanderson. We had Irina Scurtu on. Martin and Gemma this morning talking about the technology scene in Manchester and all the great stuff that's happening up there. Mark Rendle talking about migrations. .NET Rocks, Heather Downing. It's been a fantastic program. Thank you to all of our partners for sticking with us and helping make this happen. Thank you, speakers. Thank you to all of you, because if it wasn't for you, we would just be having a really, really complicated Zoom call with each other. So thank you, everybody out there who has tuned in for all of this. What we are going to do now, there is no official after party, mainly because all the equipment that I use to run live stream concerts is currently being used to host NDC Manchester. We are going to run a bit of music on the stream. I am going to drop the link. We've been running all this in we got a little Zoom backstage area where we've been doing all our talks all day. We're going to invite all of you in there. Come and join us on Zoom. Say hello. I'm certainly going to open a beer because I've been sitting here all day and I'm extremely thirsty. Grab yourself a time-appropriate and lifestyle-appropriate beverage, whatever that might be for you. Come in, meet some of the crew, hang out. I'm going to drop that link in here in a second. Just remains for me to say thank you very much to everybody who put this together. We will see all of you soon, online, offline, in person. Who knows? These are uncertain times, but whatever happens, we are going to roll with the punches and keep on trucking. And please welcome to the NDC Manchester virtual stage some people who might look ever so slightly familiar to some of you who've been at NDC events in the past, playing us out with their variation on the Disney classic DuckTales. Please welcome the Line Breakers. Thank you very much. We'll see you all soon.
Go. Life is like a hurricane here in tech world. Deadlines, roadmaps, e-campaigns, all those tech nerds chasing that bonus. Act like they all know tech sales. Every day they're out there making tech sales. Signing up and lining up train wreck sales. mission, global markets. They're on a mission, hit those targets. That's the reason they got into tech sales. Every day they're out there making tech sales. Signing up and lining up train wreck sales. Not fire sales or million sales, no tech sales.
Your API is a